Hello, hello. All right, good. We're on. Good. I don't think they can hear it. They don't, does this? They're crank. All right, so we got to kill the music. Get ready to go. Hello, hello. Hello, 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 hello. Well, can they hear it here? All right, guys, we're getting ready to get started and kick it off. Let's go. Okay, fine. Okay, good. All right. All right. Should we kill the music in here?
And if there's a light switch, it helps out.
Yeah, light switch for sure. And can I grab a water? Is there a water anywhere? Is this water?
Coffee? Nope, it's coffee.
No, it's coffee.
And I will look for one. You know what? Taking out the microphone doesn't really help if you leave the speakers behind.
No, I know. Well, the speaker's here. Look at that. How's the shirt doing? All right, there we go. Let's. All right, come on. Should we go? Should I start? Hello, welcome everybody to DePIN Day in snowy Denver. Welcome. I'm Tom Trowbridge, co-founder of Fluence Labs. Let me first start by thanking our key sponsors and partners in this event. IPC, Ceramic, Foam, DRPC, Orchard, and Beware Labs. Thank you guys. Let's give a round of applause to the sponsors that helped make this all happen. So first, a moment on Fluence, and you're going to hear more about us from different team members going forward, but let me set the stage a little bit. For those of you that do not know Fluence, we're building a cloudless computing platform. And what does cloudless means? It means we're using CPUs from all over the world to create a DePIN network that's resilient, it's low cost, secure, and with a software stack that replicates the cloud. All of this runs on a decentralized network. So we are right square in the middle of the DePIN ecosystem and thrilled to be here and excited about all the attention that DePIN's getting. And we've seen a lot of spike in press on the DePIN sector recently. Masari published a report this year and showing the interest kind of broadly. Two exchanges, Binance and OKX, each published reports as well. All right, so DePIN is now getting a lot of attention, and some people have asked, is it too much attention? Is this really warranted? And the question, my answer to that, this is not overhyped at all. This sector hype hasn't even started. And I think the way to put that into context is to think about traction. And most of us, have been in this space for a while, and we've heard the promise of dApps, as an example, decentralized applications that should be growing, and gaming. And I have full confidence that those two use cases will grow and will scale over time. But DePIN networks have traction now. And I think what we're seeing is the combination of crypto economics with physical infrastructure is actually really working and is showing a real viable use case for crypto in a way that is taking longer in other sectors. And so if you look at this, some examples for you. Helium has over 1 million hotspots, creating a global decentralized Wi-Fi and IoT network. To put that in context, there are 40 telcos in the world, most of whom are domestic, that are worth, there are 15 of those that are worth over $40 billion, all right? And Helium is global, and it uses no CapEx. Besides Helium, you've got Filecoin that is storing over 2 million megabytes of data right now. Fluence is launching decentralized CPU network that is going to very soon have thousands of CPUs at about 80% cheaper than the cloud and with verifiability that isn't offered by the cloud. And then you can look at Hive Mapper. It's mapped over 8 million kilometers of roads. So you have Teleport, a decentralized Uber, launching shortly in Austin. That's going to be cheaper than Uber, and drivers will be paid more. So you have real traction that we can point to and see, and I think that's what's getting people excited. This didn't happen overnight, right? Filecoin raised its first money, almost 5 years ago. So this sector has been growing somewhat quietly for a long time. Only now attention is turning to it, and I think it's exactly because of this traction. And my thesis is that every network, every industry out there that can crowdsource its infrastructure is applicable for a DePIN disruption. And DePIN competitors, I think, will be very difficult for established companies to surpass. DePIN competitors have very little to no CapEx and can operate globally. That's really hard for single legacy companies that traditionally move slow and are burdened by a number of elements that that crypto companies don't have. So I think you'll see a real boom in DePIN. And the thing that's really exciting about DePIN is everyone here can participate. Users participate, people that contribute to the network participate, and everyone benefits as that network grows. So as DePIN networks grow and scale, the rewards for everyone that owns that token, everyone that's involved in it, also scale. And I think that is what also makes them so difficult to compete with, because users are rewarded. If you're an early user on an Amazon platform, all that happens to you down the road is Amazon raises your prices, right? Raises your costs. Not if you're a DePIN person earlier on and you've gotten rewards, those rewards grow over time. So I think that is why I'm super excited about DePIN. It's going to be a terrific day today. We have a very packed schedule, so I want to launch into it immediately. And starting this all off is Robert from 1KX. 1KX is one of our core investors, one of our seed investors. So thrilled that Robert's going to be here talking about economics. So big round of applause for Robert to kick it off. Thank you.
All right. Thanks Thanks a lot, Tom. Yeah, good morning, everybody. And I want to kick it off with some, easy question. Who here, hands up, knows what a DePIN is? All right, yeah, seems like you came to the right event. Then next question. Who of you is contributing to a DePIN by running a hotspot, running a server, providing storage, anything like that? All right, that's also nice. Seems like I came to the right event. Want to talk to you. Yeah, and for those who just raised the hand, do you know your monthly dollar cost that you spend for your operations? That's what I assumed. Yeah. Again, my name is Robert. I'm researchers 1KX, very much into network economics, token design, stuff like that. And yeah, over a year ago, I started digging deeper into economics of DePINs. And yeah, what was really surprising to me, or astonishing even, was when I looked at Filecoin, for example, and the rewards that they are emitting in dollar terms, right? Really what they're basically handing out in tokens and converting this in dollars. This was hundreds of millions, in the peak even over $1 billion in a month. And I was like, okay, I mean, I don't know what a storage provider needs to do, but either it's very costly and complex, or these storage providers just had the best time of their life. And yeah, this is what I want to explore today with you, because the point is, knowing the cost to operate your network is super fundamental when you want to design your network economy. But we're running decentralized networks, so knowing these costs or assessing these costs, it's not trivial, right? And yeah, this is why I want to walk through our approach or our idea to come up with some cost estimation for DePINs. Before I jump into it, I want to give a brief recap first about DePINs and some of the common roles there, then present a little bit about our framework and caveats and issues, and then of course also show you how this looks in practice with showing an example and some numbers. So let's get started. This is yeah, colorized image of my head. Every time I hit refresh on DePIN Scan, DePIN Hub, DePIN Ninja, all these tracking sites, Who Loves Burritos, like all of those. It seems like even the tracking sites for DePIN are hard to keep track of. So this is a space we're in, like super fussy growing, the use cases, and that makes it obviously hard to, come to a framework that combines them. There's one way to do it. You can break it down by sectors. And here you have the two big pillars, the physical resource networks and the digital resource networks. The physical resource networks, right, these are basically the ones that depend on location, where you need to set up an antenna or a hotspot somewhere. But this goes all the way to solar panels, so it's really physical, as the name suggests. And on the other hand, the digital resource networks, where this is less dependent on location, right? Because you just need a server, compute, storage. Bandwidth is a use case. And then obviously in that realm, everything that's now coming in with machine learning and AI use cases. But yeah, even if you classify it by these sectors, that's still a little bit too cluttered to, come up with a joint framework for cost estimation. And this is why I took an even step back and looked at, bunch of DePINs, and yeah, realized, okay, actually the roles that you need to run a DePIN, they're always the same. And this is on the supply side here, right? So ignore the business management with DAOs, governance, things like that, or even the demand side, because some DePINs even have sales teams. This is really the supply side. And yeah, let's walk through these roles a little bit. Obviously, the center is a little bit the service nodes. These are the guys who provide the hardware, who set up the antenna, right? They provide the service that the DePIN then sends to the user. Then you have the validators. They are kind of like keeping the service nodes in check, because just because I'm a service node and I say like, yeah, I provide the storage, or I saved your file, we're living in a trustless environment, so somebody might want to keep an eye on it. There are different names out for that: validator, watcher, fisherman, all these types of things. And then you have an accounting layer. This is basically the blockchain, your settlement layer. This, is a whole topic by itself. We're actually talking tomorrow at the Real World Summit about the accounting layer more in depth, if you want to come there. But essentially, it's just like, the accounting layer is the bookkeeping system for what work has been done and which payments has been done, high level speaking. And yeah, obviously you have also users, ideally, and they request the service, store my file, give me some data signal, and these guys use it, but also pay for it. And then two other roles. The one is the gateway that helps orchestrating, load balancing, the request, or even the payments. And sometimes you also have delegators, who stake with service nodes or validators. Obviously, not every DePIN needs all these roles, like, for example, gateways or delegators. There's a bunch of networks that don't have these roles. And each of these roles must not be a different entity. For example, if you're familiar with Filecoin, the storage provider, he provides the storage, hardware disks, right, where you can store the data. So they are the service node. But the storage providers also join in the block building, in the consensus for the Filecoin L1. So they also form the accounting layer. And in that function, they're also the validator. So that's one example where you basically have all roles combined into one entity. And yeah, why is this nice to have? Because this is basically our entry point into the cost estimation framework. Because if you want to assess the cost for DePIN, you say, okay, let's go role by role and assess their cost. All right, then you can break down the costs. Like, what are the costs that these roles have? And this might not be too hard because there's cost for hardware, the server, the antenna, the dashcam, whatever. There's some labor cost, right? Some DevOps person probably sits there, spins up Docker or whatever. So there's some time you need to invest. Then, besides the hardware, there's obviously also all sorts of like other OpEx, bandwidth, volume and the data volume, transfers, power, and things like that. And last but not least, there's typically the question about, cost of capital. This is a topic where, we sat down and like, okay, this gets into like corporate finance textbooks, where then you would say, oh yeah, let's assess the weighted average cost of capital, the debt, and the finance. Like this type of stuff. I mean, I'm not sure how you feel, but in a DePIN, like some of you guys who are contributing to a DePIN network, I'm not sure if it's reasonable to try and assess such thing. But what I think is fair to assess and keep an eye on is kind of like the opportunity cost of staking. Because a lot of DePINs have this work token model where in order to join the network, you need to stake, right? And this stake is, money typically. Right? You could argue, well, I wouldn't join the network if I'm not convinced, and that's why it's not really cost to me. Fine, right? That's why we're saying it's more like an opportunity cost. But if this were not a thing, then I would ask, why is all this like LST, LRT hype going on, right? So there must be something to it that this, securitization of the network via staking is a potential cost factor. All right, then, technically we're done, right? We have the roles. We just go, row by row and say, what's your hardware cost? What's your labor cost? Other OpEx, staking. Try to assess a dollar value per month, sum it up. Here we go. But of course, it's not easy. Lots of caveats. I'm running through those just in the interest of time. Sharing economy is one of those. Filecoin miners have a GPU, but they can also put it, to support LivePeer or Akash or Render, right? And now you have even guys like IO.net who say like, hey, I help you do that. And then there's even the more traditional sharing economy definition, right? Hivemapper, for example, typically if you're supporting Hivemapper, you probably don't go into your car and drive around just to map things. it's typically the other way around. You're already on your car, you drive somewhere, you just turn on the camera, right? So classical example of sharing economy. So other impact on why is it so hard to come up with a cost estimate? It depends a little bit on, you know, when you look at the cost, right? This is storage cost, came a bit down lately, but then also like where you buy it, right? This is the variance across the y-axis here. And I mean, this is for storage, but I guess you guys know, right? The same is for CPU, GPU, all sorts of other things that you have this variance in what does it actually cost to provide certain hardware. And this also applies not just to server types, but also for these, you know, Bobcat, Helium hotspots, right? They also came down quite a bit compared to what they used to cost. Well, we mentioned labor cost earlier, and DePIN is global. So yeah, good luck and, you know, coming up with some you know, common wage assumption. Actually, we in our framework did one, but I'll talk more about this later. And another issue is guys like this. That's Nick Hawks. Shout out to the DePIN State podcast, really good one. I mean, he climbs just mountains, sets up the antenna in the middle of nowhere just because he likes to do it. At least I'm pretty sure, I haven't asked him, but I'm pretty sure it didn't account for like all the time it took to go up there and, you know, the time to invest to set up the antenna and all this stuff. So yeah, how do we account for these types of, you know, cost aspects when people, you know, do it because they for fun, basically. You know, economists don't have good frameworks for hobbies, right? Well, we can go on, but there's one major piece that is for sure worth accounting for, economies of scale, right? This is just some examples where you say, okay, if we think back about our roles, the service nodes, for example, Pocket Network at the bottom, there's like 15,000 nodes in the network. And but if you look at the operators, they are really transparent about that. It's just 150. But then if you look at the top, you know, I don't know, top 10 node operators, they own like 80% of all those nodes. Like they're node operators that run thousands of nodes. And obviously their cost structure per node is a different one to someone who just has one node running, right? So, and this is something, I mean, yeah, we have bulk discounts, right? I mean, Demo has bulk discounts, Helium has bulk discounts, or like specialization optimization. So another aspects to consider. And yeah, so what can we do? How do we end up with, you know, some cost estimations? How do we get some numbers for a given DePIN network? One way to assess the cost is dig deep. Discords, forum posts. People are actually quite transparent what they do. There's obviously only so much that you can get there. That's why another approach we took is even do surveys. This is an example which we did last summer, a survey with the Pocket Foundation to really say, hey, all you node operators, please tell us. What's your setup? What's your cost base? So we can come up with some model to kind of like understand what is the impact of economies of scale, right? As you can see there, we found it out. But then also, what's the impact of running it in a cloud structure? What's the impact of labor cost? Things like that. Yeah, and with that, I want to actually move over to the fun part of this presentation, some actual numbers. And yeah, I'm staying with Pocket Network here. So our framework is, of course, first you define the roles, which in Pocket's case is you have service nodes. These are the ones that service the RPC relay requests that users have to the Pocket Network. These guys need to stake a certain amount of Pocket token. And yeah, as just mentioned, there's 15,000 nodes currently run by 150 node operators. Yeah, the validator nodes, actually, you don't have separate nodes for that because everything is basically handled on the accounting layer. Pocket currently still has like a sovereign L1, the Pocket network. where you just take the top 1,000 service nodes actually by stake, and these guys don't, service the relay requests, but they actually produce the blocks for the chain. And yeah, gateways. Pocket used to have just one gateway from the founding team, basically. Now they're in the process of decentralization, and as you can imagine, the main cost driver for gateways is the bandwidth, right? Basically, paying for all this data transfer. Delegation as the last role. There is no delegation as part of the network, but these node runners that have like thousands of nodes, typically they also allow pocket holders to just stake with them, right? Because each service node needs a pocket token, so you benefit from just attracting this capital. And yeah, I don't want to go too much into the details of what's the data exactly on this cost estimates. No worries, there will be a link at the end for the survey if you're really interested in it. Was quite interesting to go that deep. But yeah, just to show you like the numbers that we have. So we start with some assumptions, right? To just say, okay, how many nodes are currently live? What's the current demand? Roughly 500 million relays served per day. And then we plug it into a model and we see, well, it's roughly $200,000 per month. This is what it currently costs to run the Pocket network. And as you can see, the big chunk right now are the service nodes. And then, roughly a third is the gateways. Obviously, you can also take the percentages from the bottom. Or we can also take the other cut and say, hey, half of it is basically the hardware, 20% labor, and 30% on the bandwidth side. So this is just based on like, okay, we ask the node operators, how is your setup? How can we translate this into costs? I mean, there's obviously lots of caveats depending on, like, related to the points I made earlier. But yeah, what can you do with that, right? That's a little bit the question. Okay, this economics guy, made a little model, produces some numbers. One thing to do it is what we also did, is to then, play with those inputs. For example, here, not sure if you see the difference. We just 10x the demand to 5 billion relays served per day, which is actually not that uncommon. I mean, Pocket already 10x'd a while ago. And yeah, since we know from the survey and from the assessment of the network, the hardware costs, the service nodes, they can scale. They can easily scale 10x, 50x, right? So basically, you'll expect that the hardware costs will not grow that much, but bandwidth, data volume and paying for that, this is something that grows quite linear with your demand and your utilization. And yeah, that's why also then in the total, you see, I don't have the last slide, but basically the service nodes, the hardware is still pretty much in the same magnitude of costs, but the bandwidth cost for the gateways, this is the stuff that just goes off. And yeah, what these numbers itself, again, might not be too telling. It's actually interesting to see. I mean, I'm not sure how familiar you are with the Pocket ecosystem, but right now, if you want to use it directly in RPC relay, you pay 85 cents for a million relays served. So if you put that into it here, right, and say, assume it's 5 billion served per day, and they pay 85 cents, this is $130,000. So again, this is the thing like bypassing the gateway, so we directly go to the service node network. So that would cover the cost for the service nodes. And if you are kind of like an end user and call the gateway and enter this way the network, the price is up to the gateway operator to set, obviously. So we don't know that. But for example, if you look at the competitors Alchemy and Fura, $5 is roughly the lower mid end of the pricing level currently. So if you assume that price with that demand, you end up with $750,000. So that tells you like, okay, cool, we are actually in the profit region. So yeah, lots of numbers. I hope that was not too confusing. What I want to make clear is a little bit, okay, despite all these like caveats and issues, you can come up with a model, especially when you're really close and do service and dig deep into the data, to come up with cost estimates and especially sensitivities, how your network costs will behave under certain assumptions. Because that's the whole point, right? I don't know the truth of like every single number is true here, but that's not the point. It's just like, you know, you open up this tool basically to everybody, and then the community can just like play around and say like, oh, actually we think this will happen. Or even the gateway provider can say, hey, you know what, we'll add this and this and that, and this is how we get the cost down. And then you can plug in the numbers and then inform basically the discussions that you have via governance and elsewhere. So yeah, coming to an end here. What's next? We obviously did this exercise and continue doing this exercise with various networks. Where you can see on the x-axis is basically the rough estimate on the monthly cost. And what you can do with that, you can plug a bunch of things on the y-axis. One thing that I personally find super interesting is to hold that against the demand, which by itself is a whole new topic. There's, you know, similar complex with similar many caveats that you will have. So that's why this is like tons of grain of salt for such a chart. But I still liked it to see, right, the exercise I just did for Pocket, you know, where you saw, okay, roughly 10x, and then you're in the profit region. You can do this for the other networks as well. And why is this relevant? Because, yeah, this helps you to, you know, inform decisions on like, yeah, should we focus on, you know, getting more efficient on the supply side, you basically get the cost down. I mean, a lot of these networks did not have a choice the past years because bear market kind of like forced you to go the cost route. Or should we focus on the demand side, fostering demand, actually put more incentives on the demand side, right? Which is also interesting to see. For example, Akash currently very much focused on that, for example. But yeah, for me as a researcher, so much more having such a framework. And yeah, we'll post an article on it. We'll also publish the framework because we're looking obviously for communities to, you know, plug that to their network and provide their numbers, so we get better comparisons. There's a bunch of more DePIN related tokenomics stuff we do. As I mentioned earlier, even a year ago on rewards. Yeah, and these other two links are on the node operator service. We did it for Pocket, for LivePeer. These are the ones we did with the communities. But if you just want to be lazy, just follow on X or Farcaster, and then you'll see there when I have something new to report. All right.
Great. Well, big round of applause for Robert, please. Thank you, Robert. And now we have Angela. I think she needs your mic. So introducing Angela from IO.net to get into, I believe, the GPU marketplace. Big round of applause for Angela, please.
Awesome. I think the slides are just getting set up now. Cool. So I'm Angela, VP of Business Development at IONET, and we are on a mission to create the world's largest GPU cloud for AI applications. And we're currently on a mission to put over 1 million GPUs in a single DePIN through decentralized distributed computing. So I'm sure, as you've all seen, with the skyrocketing rise in demand for compute power, GPUs have effectively become the most valuable commodity in the world. And in fact, the CEO of Intel called GPUs as the new oil. Lightspeed AI adoption has truly been accelerating the need for these compute resources. As you see on the graph over here, while it took Netflix and Spotify over a decade to reach over 100 million users, OpenAI was able to accomplish that in less than 2 months. Instacart and similar enterprises of that scale are also deploying thousands of models themselves. For Instacart, for example, they deployed tens of thousands of models for predicting delivery times, planning the supply of couriers, as well as optimizing routing models for shoppers. And as another example, on Hugging Face, a very popular DevOps platform that we've seen, this is a little outdated. There's actually over 350,000 models on Hugging Face today. And all of these are actually done by not just early stage startups, but also individual machine learning hobbyists who are taking advantage of all of the low code dev platforms that are out there to start deploying their own models. And so this has resulted in compute requirements for AI increasing by 10x every 18 months. However, supply in the traditional cloud has only doubled over the same period. And this has ultimately resulted in the cost of AI to soar. And if you see the projected hardware spend driven by AI, I've actually seen personally when talking to early stage startups and our clients that it's not really unheard of to spend over 80% of your OpEx on compute resources alone. Larger enterprises like OpenAI spends millions of dollars just on GPU resources. And so we see a massive problem today where the already existing supply shortage of GPUs in the world has been very much exacerbated by the rise of the AI revolution. You know, in the crypto community, we've also placed a lot of supply constraints on GPU resources as well when it comes to mining farms and those types of activities. And then as we saw with the launch of ChatGPT and all of these rush of new startups popping up in the AI space, this has only exacerbated the need for compute resources throughout the world. And that's where IONET comes in. We take advantage of underutilized compute resources from independent data centers, crypto mining farms, and even consumer GPUs from anyone with additional compute capacity at their at-home computers or laptops. And we actually support some mobile GPUs too, so we have a lot of diversity there. And so IONET Cloud is our GPU network. It's also the place where engineers can seamlessly deploy a GPU cluster of any size and any scale, and they can just choose configurations which are very seamless UI to go ahead and deploy their GPU clusters and get their models up and running. So like I said, by taking advantage of the underutilized GPU capacity, we're building the world's largest AI decentralized GPU cloud. We're currently at over 25,000 GPUs on our network, and so I think we could honestly argue that we are already the world's largest decentralized GPU cloud, but we want to become the largest GPU cloud overall and compete against centralized cloud providers. We also have, and I'll show you in a demo video at the end of my little spiel here, but with a single click of a button, engineers can deploy a GPU cluster of even up to 20,000 or 20,000 GPUs and truly harness the power of our global network with a single click of a button. And so what we're building, or what we have been working on since we launched in November of last year, we're offering services that are ultimately better, faster, and cheaper. By aggregating supply from all over the world and taking advantage of the underutilized compute capacity, we're able to provide services that are up to 90% cheaper than centralized cloud offerings. We can also provide near instantaneous cluster deployment. Originally, when we started, you could deploy a cluster within 90 seconds. We've since improved our platform, and now you can deploy a cluster within 40 seconds now. And our permissionless architecture means that engineers don't have to face long KYC processes or wait times in order to get their GPUs. Instead, you just come to our platform, sign up, and you can get started just in a few seconds as soon as you make your configurations. Then on the flip side, we have IONET Worker, and this is where suppliers can contribute their hardware capacity and start earning on their hardware. And so we put your GPU farm to work, or you don't need to have a farm. We can put your computer or your laptop or whatever additional compute capacity you have to work. This is a snapshot of what the interface looks like on the IONET Worker side, where you can keep track of your reputation score. That represents your uptime, your device uptime on our network. We also show your connectivity speed, overall performance to allow you to keep track and monitor your device performance. We also have a page where you can keep track of your earnings and rewards as well. And so we allow you to maximize your infrastructure, and we've found that we can offer up to 15 times more earnings through IONET on average than with your average crypto mining returns. I'll get more into that later. And so when you look at other types of GPU aggregator projects, I'm sure you've seen a lot of them either at ETH Denver or just on Twitter, or what if you've been, staying on top of all of the latest buzz around crypto. There are a lot of other GPU projects that are out there, but what makes IONET special is this concept around clustering. And so when you're thinking about an AI startup, even if you're very early stage, once you're at that level where you're no longer a hobbyist just cranking it out in your basement or your garage, and you're now ready to create a team, you're ready to train your models, have a proof of concept going, all of that, it's not enough to have access to just single instance GPUs. Single instance GPUs is just another word for sort of like single server machines. A server machine can typically host up to 8 GPUs per server. And so that can be enough in some use cases. Let's say you're just trying out, you might not be an engineer, but you just want to try out creating your own model, but you don't want to pay exorbitant prices to access compute. A single instance GPU could be attractive for you, and AWS, for example, offers things like spot instances where you can rent out GPUs for a short period of time on demand just to power your model. However, when you're thinking about scale and you're now at a company stage, you're a startup and you're ready to go, single instance GPUs are not enough. You need something called clustering, where you can take GPUs and put them together. We're talking about 50 GPUs, 500 GPUs, 5,000, tens of thousands, hundreds of thousands of GPUs, depending on your workload needs. You want to deploy them together, cluster them together, and orchestrate them so they're working together in concert. Now, you can create clusters in the traditional, in a centralized cloud, where they have massive data center infrastructure, they have huge server rooms. All of these devices are interconnected, all these GPUs are interconnected with each other. And so in that sense, you can create sort of like that traditional GPU cluster. What IONET can do is we can create virtual clusters, and we can take GPUs from all over the world. If you're an engineer and let's say you went through IONET Cloud and you've made all your selections, you selected what GPU model you wanted, you selected your location for your devices, your connectivity speed, security and compliance level, all of that. Then we can go ahead and our platform automatically groups together the GPUs that matches the specifications and clusters them together regardless of the location. So we can take GPUs from Tokyo, from Lisbon, from New York, from San Francisco, from truly anywhere in the world, and deploy them together and orchestrate them together so they're working like sort of like a single potent supercomputer of GPUs that are processing all of these workloads in parallel. And so that really allows us to take advantage of all of the underutilized compute capacity that's out there in the world. And we not only, let you use the GPUs, but we have that managed services component on top of that, so we can orchestrate those devices all together so they can actually tackle and process ML workloads. And so this is an exciting snapshot that I want to share with you. So this is our 2023 report. Mind you, we launched in November, so this is just the first 2 months of launch. And our metrics here just shows the traction that we have in the market and how our value proposition is truly resonating in the AI space, as well as with our suppliers as well. So we cover over 40 different countries. The graphics here says that we have 20,000 GPUs total, but since then we have now grown to 25,000. And in 2023 alone, total earnings have amounted to $185,000 over the course of those 2 months. Since then, we've grown that by about 50%, and our IO workers have earned over $350,000 on our platform. And all of this information you can go to IONET Explorer and see what live stats are looking like. We've also launched BC8 AI, and that's a stable diffusion generative image app that we created to truly showcase the full potential of our platform. On BC8.ai, all of the training, fine-tuning, and inferencing has been fully powered by IONET, really showcasing that we can support your models truly end-to-end. So showtime. I had a little demo video here that I wanted to show you. In the conscious of time, I might need to skip some parts of it, but I think we're ready to start. Yeah? No. Business development at IONET. Okay. I'm really excited to share a demo presentation of the IO network. Since we launched to the public on November 3rd of 2023, we've been revolutionizing AI compute as we know it through decentralized distributed computing. Today, I'll walk you through IONET's 3 core elements. IO Cloud, where AI companies can seamlessly deploy their GPU clusters. IO Worker, where compute hardware facilities can provide their GPUs to the network. And IO Explorer, where you can see everything happening in a network from clusters to inferences and all of the microtransactions behind them. Each element has a simple and intuitive UI to ensure a frictionless user experience. Let's start with IO Cloud, where engineers can seamlessly deploy GPU clusters at any scale to power the AI compute needs. IO Cloud is truly pushing the boundaries of innovation. Engineers don't have to wait 2 weeks to do KYC or 3 weeks to access their GPUs. Instead, with their fully permissionless architecture, at IO you are only 40 seconds away from deploying a 20,000 GPU cluster. We are here to serve your model end-to-end, from training to inference, and provide a solution to most of your problems. First, connect your Solana wallet to top up your balance in USDC. You can also make your payments through credit card in fiat payments. Now, deploying a cluster in IONET is a really simple and quick process. Once you make your feature selections, your cluster will be deployed within just 40 seconds. Let's click on Deploy Cluster. And we currently have 2 powerful options, Ray and Kubernetes, along with the Mega Ray cluster option. And we have even more integrations in the pipeline, like Ludwig, Ray LLM, PyTorch, Hugging Face, along with Unreal Engine and Unity streaming to really expand our use cases and applicability of our network. In this example, let's deploy a Ray cluster. First, select the cluster type appropriate for your model. General workloads, training, or inference. Then select a supplier type. Each supplier has different specifications. IONET to access high-end chips in a data center, Render for light workloads or massively distributed tasks, and Filecoin for data-intensive workloads. Select your GPU model. We cover a diverse range of NVIDIA cards from high-end RTX series and all the way up to A100s and H100s. We're also the first cloud provider that can cluster Apple chips, M1, M2, and M3, along with the Max, Ultra, and Pro variations of all 3. Apple chips have a powerful neural engine and high memory bandwidth that makes these types of hardware attractive for AI use cases. And now with IONET, millions of Apple device owners can contribute their compute capacity and start earning on their hardware. Choose one. After you select your GPUs, let's say for this example, I wanted to do the 3090s. Select the location for your GPUs based on your needs. Maybe you want to bring inference closer to your users, or if you have low latency ML-powered quant algorithms, you'll probably want your devices to be close to stock exchanges. Or if location isn't that important to you, you can select all of the ones that are available for the type of GPU that you select. So here, I'll just go ahead and select all of our options, and you can see a snapshot of all the regional coverage we have. We currently cover 40 different countries, and our regional coverage is expanding by the day. Then select your level of security and compliance. Your model graphs and weights are end-to-end encrypted by default so that no one can access them. In addition, all of the data traffic in transit between the GPU workers is TLS encrypted as well. We also have SOC 2 as an option, and we've been partnering with enterprise-grade data centers with SOC 2 compliance to ensure the highest level of security. Then select your desired connectivity speed. This way, you only pay for what you need. If you want to save on connectivity, you can simply select the lowest speed. If speed is more critical, you can select the higher tiers at a more premium price. So here, I'll go ahead and select high speed. Select your appropriate cluster purpose with our out-of-the-box configuration that will be ready for your existing code base with no additional setups. Since we're deploying a Ray cluster, I'll select Ray app. As you can see, we have several more integrations in our pipeline that is coming soon. Now we just have a couple steps left and your cluster will be ready to deploy. First, you can go ahead and name your cluster. As a default, your cluster name is pre-populated based on the configurations that you can select, but you can easily rename it here. So for example, I'll go ahead and call this ETH Denver Demo. Enter how many GPUs you want in your cluster and select how long you want your cluster to run for. You can select your duration on an hourly, daily, or weekly basis. So in this example, I'll go ahead and select, let's say, 6 GPUs, and I'll deploy it for 10 hours. Now at the bottom of the page, you can see the average price per card for the cluster meeting your specifications, as well as how much this entire cluster will cost you for the full duration that you selected for. Then click deploy, and your cluster will be ready in just 40 seconds. And that's it. A simple and quick process. Our system is fully permissionless with no KYC and no limitation on the quantity of GPUs that our clustering can support. You just need to make your selections and IronNet takes care of the rest. We'll go back here a few minutes later just to check on whether or not this cluster was successfully deployed. But for now, let's go into our Kubernetes page. IronNet currently supports Kubernetes along with Ray, and deploying a Kubernetes cluster is also a very similar process. Available nodes for Kubernetes on our platform have ultra high-speed internet of at least 2 gigabytes per second download and upload speeds, as well as SOC 2 compliance. All of the decentralized Kubernetes clusters come with pre-configured master nodes and workers at the highest level of security and specs available on our platform. The first configuration you can select is your supplier type. So for here, let's select IronNet. And after that, select the Kubernetes operator you'd like to activate on your cluster. Finally, similar process, you can enter your SSH key access, name your cluster, select a duration and a quantity for your devices, and then click deploy, and your cluster will be ready for you shortly. Now the cluster page shows all of the clusters you deployed on our network. And as you see here, the ETH Denver demo cluster was successfully deployed. When you click into a specific cluster for an overview of its specs, you can also see the performance of each worker device in your cluster, as well as the amount that you've paid so far. So for here, you can see the worker nodes that are comprising our 6 GPU cluster. Now, the most exciting part of this page is in the dev environment, where you can deploy your code with Visual Studio or Jupyter Notebook and keep track of distributed computing and parallel workloads deployed on your cluster through the Ray dashboard. Playground is also an exciting visualization feature where you can play around with your cluster and test it out. You can add or remove neurons and see how that affects your cluster performance. Now, let's go into IO Worker. This is where suppliers can connect their devices, monitor them, and keep track of their accrued rewards. To connect your device, first, click on Connect New Worker. Onboarding is a fairly intuitive process. The very first thing you do is select your operating system, Mac OS, Windows, or Linux. In this example, I'll select Linux. Select your supplier category, IronNet for enterprise-grade GPUs, and Render if you have consumer-grade GPUs. Name your device, so I will call this Angela node. Select your device type, whether you are a GPU worker or a CPU worker. And now all you have to do is follow steps 5 and 6. Just download the scripts to install our containers and run the command to start them. And once your devices are connected and all of the proper containers are installed, this button will automatically refresh, and then you'll be able to see your devices after that. Now, this entire process should only take a few minutes. Then when you go into your devices page, you can actually monitor your devices here. Let's click on one of our nodes as an example. And here, you can monitor your device's activity and keep track of your reputation score that's driven by your uptime. So this score, the higher the score it is, the more jobs that you'll get allocated towards you. Now, finally, the earnings and rewards page allows you to monitor and withdraw your accrued earnings.
Once you set up your account, connect your Solana wallet to IO so that you can claim your rewards. You can also view all of the compute jobs your devices have been hired for and keep track of how much you've earned. Join IONET and make your GPUs count.
Yeah, I think
Last
we
but
can
not
pause
the least, let's go into
here.
our Explorer.
Just being mindful of time. But those are the two apps that I showed you out of the three. So that was IO Cloud and IO Worker. What's also really cool that I wanted to re-emphasize is that I've updated our networks that we now support Apple devices as well. And so any Apple device owners can actually now earn on their hardware with IONET. And what's also super cool, I guess it's kind of like a small alpha, but we have a proof of concept that's in the works and a really exciting partnership that's testing out MacBook chips in real AI models. And so we're powering them to with this partnership, a really cool company, they're a generative art startup, and they've been really interested in exploring the potential for MacBook chips as well. And so we're excited to get the ball rolling there and to demonstrate the full capabilities of the new type of hardware that we're supporting. And the final one, I skipped that part just because of time, but the Explorer is where you can see price information on all of our devices. You can also see what devices are currently on our network today. And you can also go through each tab, like clusters, workers, to see non-identifying information of all of the clusters that have ever been deployed on IONET, as well as all of the workers that are on network. The inferences tab is pretty cool. So if you have a model that's powered and your inferencing is powered by IONET, you can also have that inferencing on chain. And so each time a real user runs a prompt to an app, then that's recorded on chain. And then in the future, later this year, we're launching a model marketplace so that model owners can actually start earning on their open source models instead of just having that available and letting anyone use it. And so that's been pretty cool. And those are some of the updates that we have that we couldn't cover here. But thank you so much for listening to my presentation and for listening to the demo. I'm really excited to be here. Our team will also be here all throughout this week. And the next tab has contact information somewhere. Yes. Yeah.
Excellent. Well, thank you, Angela. And another round of applause for Angela, please, and for IO.net. And now I'd like to introduce David Vork. Thrilled to have him here, a OG in the crypto space, multi-time founder. So, David, there you are. Well, welcome, and take it away.
Hello, I'm David Vork. I'm here with Glow. We are a DePIN project that rewards solar farms with tokens when they produce carbon credits. And today, I wanted to speak about DePIN incentive basics. Before we get into it, a little bit of background about me. I've been in the space since 2011. I mined my first Bitcoin at $1.50. And so I've seen a lot of things in the past 12, 13 years. In 2014, I founded Sia. Sia launched before Ethereum launched. It reached an all-time high of $3 billion in market cap. I founded Obelisk, a mining company that shipped more than 20,000 working machines to customers. And then I've been held as a leading expert on proof of work for a long time. So today, I'm here to talk about DePIN and the fundamentals that make DePIN great. I want to define DePIN real quick. I know a lot of you probably don't need it. But DePIN is short for Decentralized Physical Infrastructure, and it's this broad category of crypto projects that use token economics to incentivize the construction of infrastructure in the physical world. And one big DePIN project that I think often gets overlooked is Bitcoin. And so Bitcoin is kind of like the grandfather of the entire space. It's the most successful DePIN project ever launched. The hash rate of Bitcoin today is 568 exahashes per second. That's 568 followed by 18 zeros, which is a lot of zeros. And it's basically as much compute power as 5 billion with a B, 5 billion NVIDIA 4090s running 24/7. So Bitcoin kind of showed us all how to do it, and then everyone else has sort of remixed it and done their best to copy it and replicate it. And so some notable successes have been Filecoin, which got to 5 million hard drives, Helium that got to just under 1 million network hotspots, and then there are over 100 DePIN projects in production today. And when talking about DePIN basics, I actually want to focus on a subset of DePIN that I call foundational DePIN. And these are DePIN projects that follow the core incentive structure of Bitcoin. And all of the really successful DePIN projects in crypto today follow these foundational DePIN principles. There is no second place. There's like one way to do DePIN that I've seen that works super duper well, and everything else is kind of just like, there are things that work that are different, but this works the best by a lot. And so there are 3 things that really make up a solid foundational DePIN project. First, you have a large rewards pool. The second is that rewards get distributed proportionally. And so this is especially important for smaller players. Smaller players make just as much money per unit as bigger players. And then finally, you have permissionless competition, which means it's an even playing field. Anyone, anywhere, no matter who you are, can come and participate in your ecosystem. So to expand on this a little bit, and I hit the wrong button. To expand on this a little bit, when you have a large rewards pool, I think the most important thing is that it's like essentially a big dumb pile of money. It's just a pile of money. It's not using any sort of like algorithms or techniques to distribute things. It just kind of gets out of the way and lets the market do its thing, and lets market economics control the flow of money. So you want a big dumb pile of money. This money is guaranteed to be distributed. And to use Bitcoin as an example, the rewards for Bitcoin today are $18 billion per year. And if Bitcoin had just a single 4090 NVIDIA card mining on it, all $18 billion per year would be distributed to that mining card. The Bitcoin economics really don't care how much, like it doesn't measure how much hash rate is produced and then adjust the rewards. It just has a pile of rewards and says whoever shows up, that's who gets the rewards. And it doesn't worry about being cost efficient. It lets the market take care of being cost efficient. Then the other thing that's worth pointing out, because it's pretty much universal, rewards are usually token inflation. And I don't think that's actually like an important fundamental for foundational DePIN projects, but it is a constant, and so it's worth mentioning anyway. The second thing, you want to make sure that your rewards are being distributed proportional to the amount of services provided, and that means that it's super important for these rewards to be objective. And I'll use an example, like if we were to create a DePIN project that rewarded haircutteries for cutting people's hair, this is actually like a terrible fit, because how good a haircut is like a super subjective thing to do. It's very difficult to measure. It's very difficult to say this person's providing this much value to our haircut network. It's just a poor fit. You want it to be like Bitcoin, hyper objective, hyper precise. On Bitcoin, if you're hashing, the number of hashes that you did is how much rewards you get. Pardon. The other thing that is really important is you want to make sure that your proportional rewards distribution extends as far down financially as you can. You want the smallest possible player to be competitive. And so in Bitcoin, this is true all the way down to about 0.2% of the hash rate. And so if you are essentially like 1/500th of the entire or 5,000th of the entire Bitcoin protocol, you'll actually still be making the same amount of money per hash rate as someone who is, as much as 90% of the protocol. And so Bitcoin leaves a lot of space for small players to come in and get competitive and to optimize and to innovate. And that's important because it allows people who don't have a lot of resources but are smart and innovative to get competitive and to bring the whole protocol to a better place. And then finally, and I think this is something that's super important and cuts really deep on DePIN projects, is that you want permissionless competition. And so that means that, for example, do you know what the biggest Bitcoin mining farm is? I don't, and this is my life. It doesn't matter. You might know Bitmain, but they're not necessarily the mining farm. Nobody cares who the mining farm is. What they care about is how much hashing happens. And so there's no marketing, there's no sales. And so traditional capitalism has enormous business overheads, and DePIN just kind of cuts past all that. They say the protocol will worry about the business overheads, you provide the infrastructure, and you be really good at optimizing infrastructure. And I think that this point sinks home with like an example of competing with AWS. So if we have this like hypothetical person who's really exceptional at building data centers, they're the best data center builder in the world, and they say to themselves, I'm going to compete with AWS, I can build a better data center, I can build a better infrastructure, I'm going to take down Jeff Bezos. It's not going to work because AWS is not about how good their data centers is. They have branding, they have sales, they have trust, they have connections, they have SLAs, they have an entire software stack, they have stuff like Lambda, they have customer service, and all of these like business capitalist overheads makes Amazon totally dominant. It doesn't matter how good your data center is if you don't have all of these extra things attached to it. However, if you're really good at building data centers and you say, I want to make money on Filecoin, I'm going to plug into Filecoin, Filecoin doesn't care about your sales or your marketing or your business. It just cares about the raw metrics, the raw power of your infrastructure, and it will pay you based on the strength of your infrastructure. And that's why DePIN projects are able to be so competitive, is because the brightest minds who can build the best infrastructure are allowed to focus entirely on building just infrastructure. And we kind of separate those things out. It doesn't matter if you're not good at sales. All that matters is that you can optimize. And then the final topic that I really want to cover about like what makes DePIN special is this competitive flywheel. So the big dumb pile of money strategy ends up bringing in a lot of market intelligence. And so if you have a fixed pile of rewards that say like if you bring more infrastructure, you'll get a bigger piece of the pie, you end up driving a ton of competition, and people will continue to add more infrastructure until it's no longer profitable for them to do so. So again, I'm going to use an example of a hypothetical protocol that offers rewards of $8,000 per week. Let's say miner A can provide infrastructure at $10 per unit, and they've like totally saturated the network. They don't even care about profits. They just want to win. And so they've built 800 units of infrastructure for $10 a unit, and the protocol is paying $10 a unit for infrastructure. Miner B shows up, has a better cost structure. They can build infrastructure for $8 per unit. What ends up happening is that it's profitable for miner B to keep building more infrastructure for the protocol, basically beyond the point where A was saturated. And so the math works out to miner B adds 90 units of infrastructure. The protocol ends up at 890 units total and ends up paying $8.90 per unit. And so this big dumb pile of money has just managed to purchase 890 units of infrastructure profitably, despite the fact that the dominant player and most of the money is going to someone who's not that efficient. And so the competition structure of proof of work and of DePIN, of foundational DePIN, ends up allowing the protocol to pay the lowest sustainable price for every single unit of infrastructure that it buys. And it doesn't matter if it's buying it from a less efficient competitor. The more efficient competitors will push the price to its equilibrium point, and effectively the miner A over multiple iterations is going to be outcompeted. And each time that A loses business and has to wind part of its infrastructure down, B becomes a bigger part of the network and the overall price drops. And so that's why you see Bitcoin at the very top. It's an enormous pool of money. It's a bunch of people who have worked very hard over the past decade to optimize the hell out of SHA-256 hashing, and they have found thousands of corners to cut that cumulatively result in the most efficient compute platform in the world. Dollars per hash, Bitcoin's something like 200,000x better than NVIDIA, who's like the second place most efficient compute platform in the world. Bitcoin is so far ahead, and this is all owed to this like absolutely brutal competitive structure. DePIN, when it's working at its best, sets up this like hyper competitive just landscape for producing better infrastructure. And the protocol doesn't need to know anything about it. All the protocol needs is a giant dumb pile of money that it's not afraid to spend 100% of. So I've been building Glow, and I wanted to make a DePIN project that focused on solar. And so we just wanted to apply all of these principles to how Glow works. So today, Glow offers $22,000 in cash per week and $525,000 in Glow tokens per week as rewards to solar farms. That's your, in Glow, that's the big dumb pile of money. As the token price goes up, the rewards go up. And then solar farms earn money as they produce carbon credits. The second thing, proportional rewards distribution. Just like Bitcoin, we wanted to make sure that the participation barrier was as low as possible. So the minimum viable Glow project is a solar farm on a rooftop. It's about a $15,000 cost to build that, and then you can be a miner on Glow. And so everyone's on the same playing field, and importantly, it's totally permissionless. So Glow doesn't have like a specific Glow branded panel that you have to buy. You can use any solar panel, any installer. You can be seated on any modern power grid. And basically what matters on Glow, the core metric that Glow evaluates its infrastructure providers on is, are you producing electricity that's outcompeting dirty energy? Are you pushing coal and natural gas off the grid and replacing it with something cleaner? And then Glow expanded on this using an idea that I've seen a lot of other DePIN projects pursue, but a lot of these other DePIN projects, when they go this direction, they like lose the fundamentals. And so Glow works very hard to remain a foundational DePIN project while also building this positive feedback loop, which does not exist in Bitcoin. Basically, solar panels earn rewards when they produce carbon credits. The carbon credits are owned by the protocol. The protocol sells the carbon credits and then uses the proceeds to burn Glow tokens, brings up the Glow price, and so you end up with this like virtuous cycle on Glow where more solar panels means more carbon credits, means more revenue, means more Glow token burn, and each cycle Glow gets bigger and bigger, and so Glow grows as Glow grows. And so that's about all I have to say. But in conclusion, like the one thing that I really want you to take away is that the most successful projects in the space, in the DePIN space historically, have been these foundational projects which make sure they preserve three core principles. One, a super large rewards pool or a big dumb pile of money. Two, proportional rewards distribution. No matter who you are, no matter how big you are, you get the same rewards per unit of infrastructure that everyone else is getting. And then finally, there's like no sales team. You don't need credentials. You're not looking for MIT students. MIT students might show up, and that's fine. But also, if some dude in their basement invents something amazing and brings it to your protocol, they don't have to ask permission. They don't have to tell people how amazing it is. They can just flip a switch, turn on their infrastructure, and make a ton of money. And that's it. Thank you.
Great. Thank you. Thank you, David. Appreciate it. We've got a panel now, so let's come up for the panel. Daniel. Thank you. Appreciate it, David. Here's your mic. It's another mic. All right, there we go. So we've got an AI and DePIN infrastructure panel coming on right now. Let's get everybody up here. Oh, no, we don't need that, I don't think, actually. So we've got a mic up here for you. Mic's up. Waiting for one person. There we go. Right under the bell. Sorry. All good. Welcome.
Is there the chair, or should I just?
You know what? I guess we're short chairs. I can grab it. No, it's fine. You know, I grab this. Grab it.
Sure?
Yeah, it's fine.
Thank you.
I'll lurk. So, welcome to the panel, DePIN and AI, match made in heaven. We've got some terrific panelists here, so I think we'll start this off kind of the regular way by just people introducing themselves and their projects, and then we can kind of get a little bit deeper pretty quickly. So first, you got a mic, Jan. You want to go first?
Yeah, I'm Jan from Filecoin Foundation. So we are a decentralized storage solution, and we're hoping that more AI projects can be built on top of our layer. And right now, I'm doing some technical integrations for AI projects in general. So if there's any projects and you want like a decentralized network, please come to me.
Hello, my name's Mark. I'm the CEO and co-founder of Aether. We build decentralized enterprise-grade GPU cloud infrastructure. You can think of us like an enterprise-facing GPU cloud marketplace. We allow kind of enterprises, data centers, crypto miners to contribute their GPUs in a way that allows them to be rewarded through our network for work that they contribute. And then on the other side of the marketplace, enterprise buyers can come, purchase compute from us in kind of a high accessibility, low cost format.
Hi, my name is Daniel. I'm the CEO of Syntropy. We publish Web3 data decentrally and stream that in ultra low latency, any chain, anywhere to apps and AI machine learning protocols that need it.
Hey everyone, I'm Ben. I'm the co-founder of Jensen. We're a decentralized machine learning compute protocol. So we connect up all of the machine learning capable compute hardware in the world, GPUs, TPUs, CPUs, anything like that, and provide it as a resource to anyone who wants to train machine learning models. Jensen's a kind of long-running research company. We are building things to verify that the compute was done correctly. We believe that the future of machine learning is very, very automated. So most of the entities triggering the training of machine learning models will be models themselves. And for that to be the case, we need verification built in. So you can't just trust that the person that has the compute has actually done the task. You need to know that it was done correctly. And that comes down to cryptographic proofs, game theoretic incentive mechanisms, and probabilistic checks to ensure that programmatically you can check that the work was done. You don't need to trust a human at any point, essentially.
Great. So I think to summarize, we've got storing, operating, connecting, and training. Right. So that's the one sentence summary here. We can all go home now. But what I want to get a little bit deeper here and think about what the challenges are. And so you just, Ben just talked about some of the challenges with regard to this, which is verification, validation, right? So that's a huge challenge. I guess let's get into on the other, start back on this side, or whoever wants to take it, challenges on your side with regard specifically to implementing your area with AI, right? So Filecoin storage, how does that integrate with AI, and what are the challenges there, and what make you guys kind of specifically suited to meet those challenges?
I think from a machine learning perspective, from the machine learning lifecycle, for feature training, we can ensure that the features used to train a model has not been tampered with, or even the model versioning of the AI models can be archived onto Filecoin to ensure that there is a proof of space-time. So the data there will be immutable, and it's ensured that nothing has been changed there at all. So this is something that we can contribute to the AI ecosystem. The next thing is generally a lot of logs, a lot of audits happen, needs to happen, and to trace it back to where the training, it has to be traced back to where the training occurs to ensure that no one has tampered with the model, all the decisions made are sound. Yep.
So proofs of the data is hasn't been corrupted, hasn't been altered, hasn't been changed.
Yep, and I think it's going to be really important in the audit in future, so that people can trust AI more.
Definitely.
Yeah, so I think at Aether, we're on the infrastructure side, right? And when you look at DePINs, traditionally we've been very good at kind of aggregating consumer hardware, right? Consumer GPUs and equipment that's contributed by our network. The issue with this type of infrastructure is it's quite difficult to kind of package that infrastructure and then sell it in any meaningful way to large enterprises, right? There's kind of pretty strict service and uptime and quality requirements that these compute buyers have that are really difficult to kind of meet when you're trying to package up this really kind of distributed, diverse compute that comes from kind of a number of different I guess, lower end compute providers. At Aether, we kind of took a very different approach to how we built our DePIN network, focusing kind of exclusively on onboarding really enterprise-first, enterprise-focused GPU infrastructure, right? That contributed by data centers or large enterprises. And we've very much kind of streamlined the type of infrastructure that's committed to our network in such a way that we can kind of really attack and meet the requirements of these big compute buyers in a way that I guess traditionally DePIN projects have struggled with. I think what that kind of allows us to do is kind of challenge this concept of, I guess, instability that exists within Web3, particularly around DePIN networks, such that we can kind of hopefully start to build that trust and encourage these large compute buyers to kind of look at DePIN infrastructure as a viable place for kind of long-term compute contracts.
That's a fascinating point, because you've hit on a critical kind of issue here, where DePIN is about crowdsourcing infrastructure, but that doesn't have to be individual retail infrastructure. Some of the biggest projects it is, right? Helium 100% is, right? HiveMapper for sure is. But when we're talking about institutional use cases, that kind of perception inhibits the deployment of this DePIN infrastructure, even though it just as easily can be coming from institutional grade infrastructure, which is put together on this type of network. And so that's something obviously we're doing at Fluence. Filecoin's a great example where Filecoin, you can have individual miners, but who's really dominating that network are professional miners that have run and built data centers at scale. And so that's what we've seen happen, and I think that perception issue is something that we certainly need to overcome. I know we've had to deal with it at Fluence, where people think, we mentioned peer-to-peer network, and people are like, oh, that's not going to work, no one's going to use that, that's not reliable. Like, hold on a second, we're using the same data centers that Netflix is using. Like, this is not all happening in someone's house. So I totally grasp that. On Daniel's side, love to hear your perspective on this, because you're sort of institutional from kind of the beginning, right?
Yeah. So I guess from our perspective at Syntropy, it's kind of hard to underestimate how big the data challenge really is. As soon as you start going into something cross-chain, so running a Solana node is 110 terabytes. Add that Ethereum, another 17, you're 150 terabytes, and you need to start to train your models on this kind of data mass. And so what we work on is data in blockchain is by its nature open. And can be read by block explorers. But if you need to then look over multiple chains, and you need to be able to see the immediacy of the data sort of in the 30 to 50 millisecond range, right? Because these chains are trading wrapped assets that all represent each other, then that's where Syntropy comes in, right? And you need to be able to get that data after you've trained your AI model sort of, from the Genesis block. You need to be able to then work on the immediacy and act on that data cross-chain. And in short of running all those nodes yourself or indexing yourself, you have to trust somebody. And that's where we come in. We're the trustless, low latency variant of streaming data.
Gotcha. Well, Ben, question for you. You could have a DePIN network that runs centralized applications, right? And in fact, we expect to see that very often. Can you talk about decentralized AI and decentralized networks, where it's where you actually get that sort of, I think where I sort of love to see things go, but particularly where you are, love to hear your perspective on it.
Yeah, I think we've in the machine learning space, we've seen a progression of greater sizes of centralized models, and that's been really exciting. You've seen like ChatGPT, GPT-3, 4, etc., like really impressive models, but to us, they're the sort of tip of the spear. They're the research that shows what's possible with machine learning. The wave that comes after is how we actually productionize those models, we get them in the hands of loads and loads of people, and we get developers able to build their own versions of those models. And I think what we see, if we continue to build them in the way they're currently built, there's just a huge squeeze on the kind of number of people who can do that. They're built in this hyper-centralized way. It requires huge amounts of highly centralized infrastructure. But then you look at the entire world and you look at how much compute we actually have. We have huge amounts that we're just not using. And I think the machine learning space, I've said this a few times, but the machine learning space has quite a short memory. A lot of people assume that the way that we build models now is the only way to build really performant, like next level models, but it's not. It's just the first way that was effective. And what decentralization is showing us now is you can actually go from maybe 4,000 GPUs in a data center that are all hyper-connected to millions of GPUs if you just change the way that you build the model. And there's some really exciting ways of building models in a decentralized way, where actually, instead of being this kind of like singular brain that we've built in a single data center, it's this huge, rich ecosystem of kind of shards of model value that can be connected up. And I think that's what's really exciting within AI and machine learning, because there's no kind of ceiling on top of that. Whereas now we're starting to see that ceiling where we just can't build bigger data centers. The cloud giants and the tech giants are actually, they're not constrained by money. They can buy GPUs, they can buy TPUs, they can put them in data centers, but they can't physically get data centers because we're running out of geographical places that can host data centers with enough GPUs in them. Actually, if you kind of take the Bitcoin approach and look at the entire world and say, well, if we just created a market over this and incentivized the people who have that location, who have the electricity, et cetera, to provide the compute, then you can build a much better system, a much richer system than the current one where the cloud giants have to go and fight for specific locations of data centers. Let's let the people who know how to build data centers do that, and then give everybody else access to those, to that hardware, essentially. So yeah, I think decentralized models are the future, and I think it's going to be pretty exciting when we actually see the first real massive model exist.
And just could you summarize that a little bit? Do you think the challenge to decentralize the model, the first or scale decentralized model? Is it hardware access? Is it human expertise? Is it team size? Like, is it a combination of those things? Which is the gating item now, do you think?
That's a good question. I think we're sort of flipping back and forth between the expert knowledge to build those models and the access to like decentralized hardware. So can I access 1 million MacBooks to train a model right now? Well, kind of not. Could I design a model that could do that? Probably, but I wouldn't really be able to test it until that infrastructure existed. So there's sort of a chicken and egg where those two things need to progress. And I think we've seen the start of the expert knowledge progressing. There's some really good research papers that show within open collaborations, so just people volunteering hardware, we can actually build state-of-the-art models over these infrastructures, but that only scales up to maybe 1,000 GPUs, where there's being 1,000 kind of given voluntarily. We want to see what happens when you create a real game theoretic ecosystem over that, where people are actually being paid, and then there's an incentive for people to provide those MacBooks, and we can get millions of them. Long term, we can get every iPhone on a network like this. The problem is, if you introduce those economic incentives, then you introduce the incentive to cheat and not do the work properly. It's very, very hard to verify that when you're talking about a tiny shard of a decentralized model. You can't just say, well, the user will be able to tell, because they won't. You have to have some kind of proof system in that before you can build a model like this. And I said large models before. I don't necessarily think large models are the future. I think it's going to be lots of kind of small pieces of model all being connected up where they need to be. So maybe you run a path through a large model. Maybe you only actually use a tiny bit of those models. It'll be very use case dependent.
So super specific models with specific data sets for specific kind of functions or expertise. I could definitely see that. But what's the analogy I was using previously was Windows had a massive head start, unlimited budget, and Linux was able to beat it. But Linux, the gating item there was just developer resources. It was not hardware specific. And the difference here is we have a hardware component as well. I guess with regard to that, on Filecoin, could you talk about hardware, right? Because you guys are the experts in incentivizing hardware kind of investment by people, right? And so, maybe mention the scale that the Filecoin network's grown to, the scale there, because that kind of provides a path for hardware deployment.
Yeah, sure. I can't recall what's the exact exabyte of data we are storing now, but I think it's around 9.7 exabyte of data, and it's still expanding. I think Ben spoke about two different things, which is the partition model, something that's very specific to each region on specific data sets. And I think the Filecoin ecosystem can also provide that. Other than the infrastructure side, there's the data side of things. Data can't move out of regions because of specific data protection laws. So generally now what's happening is that people send the model to where the data resides and train the model there. It's not that performant yet, but I think in the next year or so we can see it improving. It's called federated learning, and it's going to be something that's quite big in the space as well, something that decentralized or Web3 can incentivize to build this kind of machine learning models as well. And I think Filecoin's data storage providers have a great head start in this economy as well. So,
and Mark, do you want to talk about that a little bit? Obviously, you're in the infrastructure side as well, so you want to see as much capacity joining the networks overall. And one of the questions: who do you see using your capacity you're adding as well?
Yeah, I think there's two different types of, I guess, capacity, right? There's a capacity that maybe is facing the training side of the market, and there's a capacity that might be facing kind of inferencing side of the market. And I think what's quite interesting about DePIN networks, and maybe something that I can talk to that's maybe a little bit different to what you guys might be discussing, is how decentralized networks provide this really interesting use case for ultra-low latency networks, right? So when you look at AI inferencing, latency is kind of a pretty important concern. But when you look at how GPU networks scale, certainly in a traditional sense, you generally have a large amount of equipment deployed in a single location, and essentially the further away a user is from that compute, the more degradation you see in the performance of that compute, right? So the further away you are from where the compute's happening, the more latency that user is experiencing. And in centralized solutions, all of the unit economics and the economies of scale of how that infrastructure scales kind of encourages people to put that equipment in one location, right? Google, if they're expanding into a region, will put all of their hardware in a kind of one data center, right? Because it's the most cost-effective way for them to manage that equipment. right? But when you start to look at decentralized networks, you're kind of removing the incentive for hardware to clump, right? You're creating this ecosystem where there's really no independent or overarching motivation for all this hardware to exist under the same roof. So as the network kind of grows in size, instead of kind of this one blob in the center of the dartboard kind of just getting slightly bigger, you actually have a larger number of smaller nodes kind of appearing over the map, which from a network perspective allows your network to start prioritizing kind of this local compute delivery, which is generally kind of higher performance and lower latency, which is kind of really interesting for the inferencing side of the AI market. So I think from a hardware perspective, there's a lot going on in the training side, but DePIN also has this kind of really interesting angle on the inferencing side that I think is equally interesting.
Are those small kind of elements you mentioned, are those like smaller data centers? What are those in physical terms?
I think it's a combination of both, right? It's distribution of equipment through data centers, distribution of equipment that's contributed by enterprise players, but eventually definitely inferencing that's happening on equipment that's more contributed by consumers as well.
And so do you see then, you talked about the network being relevant for, or customers wanting the performance of institutional capacities. Do you see yourself and you see the market moving beyond that into retail as well, with perhaps more software layer on top of it to ensure resilience, or how do you see that moving?
I think the benefit of DePIN networks is this ability to kind of have these unique ways to incorporate consumers, right? We don't necessarily need to just rely on the equipment that consumers have, right? We can encourage them to purchase certain types of equipment that help us kind of unify and reduce variability on the edge. And I think that's something that on the inferencing side will kind of address a lot of this variability and current difficulty that we have meeting a lot of these enterprise compute requirements, specifically as it relates to kind of consumer hardware and equipment that exists on that kind of bleeding edge of the network.
Gotcha. So I guess one other thing is, what does it take, I guess, for each one of your businesses, do you think, to scale? Is it capital? Is it team? Is it access to something else? And I'll start with Dan.
Yeah, I mean, I think when it comes to data, I think probably the easiest way to explain it is to like one of the companies that we didn't think we were going to be working with that reached out to us was a company working on autonomous economic agents. And I think that if you start to and these are agents that have one job, but they do this one job really, really well. But they have to, and they have a wallet, and they can act on that impulse, and then they can execute, right? So what they need to rely on 100% is that the information that they're getting is accurate, and it has to happen in a time frame that they can act on it. And so we didn't go hunting for these guys because but they came to us, and I think so. For us, that's a great example of like if you started thinking about like if you were born today, landed from Mars, you looked at the way that blockchain has evolved and what you have right now, you would be building on completely different architecture, right? You would be building on, immediately you would be multi-chain, immediately you would be decentralized, immediately you would be relying on a lot of the DePIN infrastructure that's out there. And so for us, there's two ways, right? We can convert the initiated that sort of grew up on these islands with their own religion and their own faith, or we can focus on the net new conversion, the next 1 million wallets connected. And like from our perspective, it's much, much easier to kind of go down that route of the next 1 million builders. And that's really where we're focusing a lot of our attention. So I think that it's getting the inception into the brains of the next 1 million builders is really where we're heading for growth and scale.
Sure, I'll jump in. I think for us the biggest challenge is just the difficulty of what we're doing. We have a very long-term view, and balancing that long-term view of this is how we think the world will exist in the future and why we're building what we're building with what exists right now. And some of those points you make bets. So you make bets that your prediction will be right. You won't always be right. So you've got to kind of balance, okay, do I build something right now which solves a problem, but it's much smaller than what we think will be the kind of solution in the future? Or do I just go straight for that end goal? And I think that balance is really hard for projects to achieve. And I think DePIN's really felt that. The last kind of wave of DePIN projects went through this, where you talk about use cases and demand side, and the demand side that you might actually want to address might not exist yet. And if you only build for that demand side, you're going to struggle because you'll kind of bootstrap a supply, you'll get all of the kind of things in place, but people just don't realize what they can do yet. And I think you've got to somehow address the current problems, but also be building for the future. And very tricky balance to achieve. I don't think there's a kind of solution in like capital or people or kind of amount of hardware on the network or anything like that. I think it's just the kind of business decisions and the incentives you have within your organization, which is a difficult thing to build.
Anybody else? All right, let's think about something else. This is DePIN Day. We're talking about AI, but I wanted one more question on AI, and then I'm going to zoom it out into DePIN even more. But with regard to AI, anything out, and this is a bit of a leading question, but we've seen the challenges that some of these centralized models have, the biases inherent in them. And I guess I'm just curious on any of your guys' perspective on AI and DePIN and centralization, and how, we touched this a little bit, but how you think, where you think the future goes. And you mentioned, Ben, it's smaller models, specific models, maybe, but there's another world where Google and Microsoft just dominate, regulate, and those models are. So kind of curious your guys' perspectives on what type of models and what kind of AI future we see over the next, in the next kind of, this world moves fast, but let's just say the next 3 years from now.
So I think I'll go a little bit more technical in this. I think today's LLMs are not going to exist in 4 to 5 years' time, because in general they are auto-regressive, and you can't control the output of the LLMs itself. So probably there needs to be a reinvention of the architecture of the models. And if there is such a thing, then it will be smaller models, and it's more specific to each data economy, each region, because every region has its own consumer patterns. So the partition model that was mentioned, I think it will work more. It will be smaller models and decentralized models.
Could you talk about the auto-regression and get a little bit more?
Generally, I think, so generally, like when you put something into the LLM, you're not sure what's going to, the output of it, you're not sure what's going to come out. So when it hallucinates, it gives like a random output. You can't control that, and it gets to the end consumer. What ChatGPT does is that it does a filter to ensure that some of these content doesn't get out to the public. Like if I ask some things that are taboo, or like I ask like how to build a bomb or something, they will not output this to me. But in general, the LLM knows, because it has been trained on a generic data set for that. So I think it's kind of hard to control these LLM models.
So your point is they won't exist because they'll be regulated, or because people, I've heard other arguments that people using them actually make them dumber as well?
Yes, I think generally if you do the retraining of the model correctly, it's not going to get dumber, but you'll get smarter and more accustomed to what people want. I think my point is that for all LLMs, you probably need to build like a rule-based engine to ensure that, or a filter to ensure that some outputs don't get out. But the big data there is still going to be existent.
But that's a challenge for decentralized ones, because they will certainly exist, right? And they will not be filtered.
Yes, that will be a challenge, yeah. So probably there needs to be a blanket governance over all of these things.
Not holding my breath for that.
Yeah, that's the hard part.
Yeah.
Yeah, I'm not really kind of a machine learning engineer in any sense. So I'll kind of take maybe a different view on the kind of trajectory of the market, and maybe look at actual distribution of infrastructure as an indicator, right? So if you look at the development of high-performance computing data centers across the world, those that are capable of dealing with and handling high-performance AI chips. They're popping up everywhere, right? If you look at the distribution of H100 GPUs, again, in overseas markets, they're popping up everywhere. And those are resources that are really kind of out of the reach to a certain degree of these large language models that dominate the market today. So unless the expectation is that those pieces of equipment remain entirely idle over the next kind of 3 to 5 years, definitely there's this assumption that a certain amount of training will be occurring on equipment and infrastructure that is separate to that of the infrastructure that we see kind of out there deployed today.
Daniel, anything?
Yeah, again, I'll start this by saying I'm also not a machine learning engineer, but I think you know one of the things like that we see with the ultra low latency data delivery is in one simple use case. It's the use case of a circuit breaker. Right, so just flip a switch. You see something that you are, or you see something the machine learning algorithm is not happy with, then the switch gets flipped. And in this specific use case, I think that this is what we see. We focus a lot on the composability of data between multiple streams, right? So looking at multiple different blockchains, bringing that data together, and then having sort of that ultra low latency that you can act on. And we see that people leave kind of half finished builds. Right, builds that they thought, okay, I got to this point, and this is quite interesting, and I'm going to just leave this and let other people build with this. So when it comes to actually these sort of models, we see that these very specific task-specific compositions that actually can like Lego cubes build on top of each other to achieve different outcomes that might be specific just to the Philippines, for example, right? Or might be specific just to a certain situation between certain chains that somebody's looking for. We completely see that as the future, not because we, again, not machine learning expert, but because we can see that's how people are building on our technology. And that's what, we can see as the trend right now.
I think I'd strongly agree with that. I think that's the progression we're going to see. And I think I'd probably disagree with some of the points earlier. I think in my opinion, we're in the next revolution of technology right now, and it's the machine intelligence revolution. The last one was the connectivity revolution of the internet, where we scaled up all of the technology that we had and allowed it to communicate, but it was very, very deterministic and imperative, and that's what most people are used to. They're used to interacting with technology in this way where I know exactly what it's going to do and I know exactly how it works. I think we're moving actually forwards but also backwards with machine learning, where we're moving to a probabilistic world. We exist in a probabilistic world anyway. As humans, we're used to it. We had to kind of change our mindset to interact with technology to be more imperative, and we're trying to enforce that imperative nature on top of models, and I think that's going to be a really weird thing that we tried to do for a while, but realistically we'll eventually embrace this probabilistic world where actually interacting with technology isn't interacting with imperative code anymore. It's interacting with essentially another person. So if I want to understand what's going on in this room, for example, I would use a machine learning model to process an image that's of everything in here, and it would pick out certain points and things like that. In the traditional world, I'd say there's an exact color here and I know what it is. But actually the new models will be able to pick out information in a much more probabilistic way. They'll be able to have inferences about this room that a person might have, and some of them might be wrong. And I think we're going to get used to that, and eventually we'll move to this world where we don't actually need those kind of imperative checks on top of model outputs that we think we need right now. And I think Gemini, the Google model that we've all probably seen, where they've put kind of inference side checks in to say that actually this should reflect the world in a certain way and it's not acceptable for it to kind of make these inferences, that will start to move away because we accept that models are actually closer to people than they are to code. And I think that's going to be a really weird thing for the world to accept.
Listen, that's we could have a whole discussion just on that. And the thing I'd say is that we live in a probabilistic world, but humans don't like that. And that's actually the problem, is that we don't like that. That you could look at religion, you could look at all kinds of constructs we've come up to actually avoid any uncertainty, because we don't like uncertainty. And so I think that's why we're seeing this Gemini built the way it is to actually try to teach and give an answer that a certain group of people want to have as a definitive answer. And so moving away from that, I think, is going to be complicated. But necessary and open sources, I think, is the path there. We're running out of time. I want to have one other question, though, for everybody here. Besides what you're working on, what else do you find out there in the DePIN space that you think is interesting, exciting, or important? Last question.
I'm happy to jump in. The way we view what we're working on is very, very thin. So we only connect up compute. It's very hard, so we don't want to do anything else. We want to focus on verifying compute and making that work really well. But the vision of the future we have requires lots of other things. So some of the things that I find exciting are the data problem. So if you've got a network where you can access any GPU, TPU, CPU, whatever it is in the world, and you can run a model on it, how are you finding the data to run alongside that? And what we'd love to see is a network that could sit alongside Jensen and allows access to the local data on the device that is performing the compute. So anyone that's kind of building that, there's been lots of attempts to do that in the past. We've got certain kind of views of how it should work, but that's one of the things that I find incredibly exciting, because I think, like you mentioned before with federated learning, that's going to be the future of how we build these models. It's going to be highly, highly federated models training over millions of devices using local data. But then in order to do that, you need privacy preserving machine learning techniques as well. These are all really nascent things, but really exciting. And I think they all need to happen kind of at the same time for us to get the true kind of vision of the future. One of the other things is the expert knowledge in model design, some way of incentivizing people to bring their own models and say, hey, I've designed a slightly better federated piece of model. I'm going to deploy it here, but I want to be rewarded for that. And then I think what we see in the decentralization space is we can have incentive mechanisms over all of that. And you can apply them in very similar ways with like deep challenges for each of them. So people who are building that kind of stuff as well, I think, are doing some really good work, and it's pretty exciting.
Yeah, so I mentioned them before, but I think autonomous economic agents are really cool. I think that empowering bits of code to be fully self-executing is really part of the future. And but I also think that right now, if you look at the cost of doing a lot of this processing, a lot of it gets bundled up into storage. And I think what we see is that a lot of the storage providers, like everybody's saving their own data, everybody's indexing their own data, and it's 60 to 70% of the cost of most of the models, right? So getting to this point where people really kind of accept the trustlessness of centralized storage solutions for some of the common data that we all rely on, it will be a huge breakthrough, and it will also free up a lot of resources to making them to use for other purposes. So we'd love to see some of that. Go ahead.
I'll use two mics. So I think on my side, we're really interested in the gaming side as well, right? And DePIN has this fantastic kind of use case for gaming. If you take a look at kind of the gaming ecosystem as a whole, there's like 3.3 billion gamers out there. 2.8 billion of them are gaming on low-end devices, right? And as we all know, the cost of GPUs are higher than they kind of ever have been before. So this like price of participation is increasingly rising, yet the proliferation of gaming as kind of a hobby and access to it through kind of low-end forms of technology is kind of improving year on year. So you have this kind of situation where, as a gaming industry, you're asking yourself, how do I unlock access for this 2.8 billion gamers to kind of high-end content that's being produced in these big AAA studios that are what you and I would consider mainstream gaming. So I think DePIN has this really cool potential to essentially increase the scalability of technology like cloud gaming, right? Whereby you can disconnect the user's requirement to have and own types of hardware necessary to play specific games, and you can kind of take that solution and scale it in a way that's far more realistic than, for example, raising the GDP of a region so everyone can afford an iPhone 15 or a 3090. So I think DePIN will play a really interesting role in gaming as well moving forward.
Yeah, for my side, I'm excited about the convergence of DePIN, DScience, and Zcase. I think medical data is something that's really, they need the data to reside where it is. The data sovereignty there is really important there. So with the amount of data available, like we can I hope that one day we can sell our own personal data and not like medical institute to monetize it, and somehow they can create new vaccines or new medical inventions that will benefit us. So I think I'd love to see the convergence of both DeScience, DePIN, and ZKs soon.
That's great, but I'm sorry to report that you all got that wrong. The right answer is Fluence.
Yeah.
Our cloudless computing platform is obviously the most interesting project besides what you guys are on. So that was an easy one. You missed it. But with that, I want to thank our panel. Let's give them a round of applause and on to the next. And I think we're looking for Nico now from Streamr Networks. Is Nico ready? There you go. All right, great. You need a mic. Grab his mic right there. There you go. All right. Nico's making his way up, so we're not ready for a break yet. Oh, and sorry, guys. Also, I keep forgetting to say that we have a developer workshop ongoing at the second stage. So if you want to get a little more technical, please join the developer workshop. It started about 20 minutes ago. And now we have Nico from Streamr Networks kicking off. You have the mic, Nico.
Awesome, thank you. And thanks for organizing Fluence, by the way. Just waiting for my slides to come up. What do I have to press? Ah, there we go. There we go. Okay. Thanks, guys, for coming. I'm Nico. I do developer relations and partnerships with Streamr. I also do I also do business development. And today we're going to talk about Streamr and how you can power AI solutions with real-time data. Who here has heard of Streamr before? Okay, awesome. That is not a lot. That's perfect. So I don't waste time on explaining what Streamr is. I'm going to start with explaining what it is, and then just kind of dive into how you can use real-time data with AI and how Streamr can be used for that. I'm going to show you guys some code. Who here is technical? Are you guys? Yeah. Okay. Seems like a few are. And then I'm going to show you guys some use cases, just in general, like what you can do with real-time data and AI, and then just some resources. Okay, so what is Streamr? Streamr is a real-time data transport protocol. So think getting data from one place to another place in a decentralized manner. So you don't have like a centralized server such as AWS that propagates the data. It's all peer-to-peer. It is a topic-based publish-subscribe system. Who here has heard or knows what a publish-subscribe system is? Nice, okay, that's a few people. So for the people that don't know what it is, it's essentially you have a publisher that is publishing data, right? I mean, they're sending data to a stream, and then you have a subscriber that is listening to the stream. And when I say sending or publishing data, I mean like in real time, right? There's data coming up all the time, and then someone subscribing to this data, reading the data, and doing something with it, processing it. We're also a fully decentralized P2P network. I mentioned this before, P2P network. I'm going to explain this a bit more in a minute. But basically, you have no service, you have no single points of failure, and there's no trust required. Right, so here you can see a centralized and a decentralized version of this publish-subscribe system, right? On the left side, you've got the centralized version with AWS. So you have the single point of failure. You have these weather stations down there that are publishing JSON data, weather data, and then AWS is kind of propagating this data to the subscriber, which is like this little cube on the right. Listening to this data, processing it, doing some calculations. Maybe it's a dashboard, could be anything, right? And on the right side, on the right side, there is a decentralized P2P, which is Streamr. And here you can see there's no AWS. They're all like kind of interconnected with each other. It's like a mesh network. And they're all talking to each other, right? So there's kind of avoidance of this AWS central instance. And the great thing about this is you don't have a single point of failure, right? So you've got these weather stations, they're all publishing, and you've got this cube, which is maybe a subscriber, a dashboard, an AI, that is listening to this data and processing with, this data. And this scales very well with Streamr. So the more nodes join this network, the stronger the network gets, right? While if you have like a centralized instance, you need to think about like load balancing and all of that. Right, so streams and topics. This is, again, I just want to nail this down, what publish subscribe system means for the people that don't know what it is. For the people that know what it is, we say stream to topic. It's just a change of terminology. And for the people that don't know what it is, again, we have these publishers, as you can see here. Maybe there are more people over there. So you can see the publishers, you have the weather stations, they publish the data, and then the application, which could be an AI, which could be a dashboard, whatever, is subscribing to this data in real time, right? So, and this is all happening like maybe every second, or like the weather station is publishing the data every second, and the application is getting it immediately, right? So, an example. You have, you guys know what a request response pattern is, right? Where you send a request to a database, and you get a response back, okay, this is like the new data. And the difference here is that you don't have this request response pattern. You just listen, you subscribe to the stream all the time. So you get like in real time, you get the messages. Well, like imagine you have to request a database for your WhatsApp messages all the time. Like, is there a new message? Is there a new message? That would be terrible, right? So you kind of listen to the stream all the time. I hope that's clear now. Okay. Here we have a snapshot of a stream. So each stream, like for example, weather data stream, is its own topology. Topology is just a fancy word for node constellation, like how the nodes are connected with each other. And in the Streamr network, let's assume this would be a group chat. I think this is a very easy example, with 30 people or participants in the network. And each group chat member is one node, right? So you have like 4 participants, 4 neighbor nodes that you connected with in this peer-to-peer network, right? So you whenever you send a WhatsApp message, you send them to all of your 4 peers, and then those 4 peers propagate the message across the network to their 4 peers, right? So and that's like a chain, and that way everyone gets the message in real time, or almost real time. There's some typical data patterns in DePIN that we support. There's the up one, where you have many-to-one. So many devices share their data, and then one instance is subscribing to them. You have many-to-many, right? So let's say you have an autonomous driving use case where you have a bunch of cars that publish their data, like a car coming from this side, and then there's another car coming from this side, and they share their location data, so the cars know when to stop. And broadcast as well, one-to-many. Right. And now let's get into some cool stuff. Let's see how this works with artificial intelligence. I think we've all heard of ChatGPT, right? I mean, this is kind of not new anymore. So here we have this weather stream again, right? And what happens here is there's an AI listening to this weather data stream, and it's aggregating this data and calculating some averages, and then just printing out or generating a weather report. Super easy. And a super simple example. Obviously, you can do much more about this later. How would this work with Streamr? Is, again, we go back to the weather station example. We have a publisher. We have this weather station that is publishing every second, let's say. As you can see here, there's an interval that publishes a data point every second. And then you have this awaits streamer.publish. Streamer, this object over here, is essentially from a JavaScript-based node node package. And you see also here this weather stream ID. So this weather stream ID is the specific ID for this specific topology that I showed earlier, right? Like this topology over here, right? We know exactly, okay, I'm going to publish a message to this topology or another one, right? And there you go, and then you send the data. So you send every second, there's data coming in, right? And then you have this AI server that is then listening to this data to the exact same weather stream ID. You can see this in the top line, streamer.subscribe to the same ID, and it then is aggregating this data. So you can see here there's like a callback function message, so every second this function is basically getting called, and it's getting aggregated, some averages are getting computed, and basically then it generates the weather report after those 60 data points. And this is basically how this could work in code. I don't need to show you guys the prompt. I think this is all clear. And again, there's the result. So this is all cool, but are there any other use cases than ChatGPT? Yes, there are, of course. Really, really cool use cases. So of course, with real-time data, there is improved decision making, right? So financial trading, autonomous driving are basically use cases for this. Financial trading, like imagine you listen to the current Bitcoin price or like the current Ethereum price, really nice prices at the moment, and then an AI is taking this data in, and maybe there's a trading bot making trades based on this. We actually had a hackathon project that did that with the Binance market data. Enhanced predictive analysis, weather forecasting, adaptive learning. Like imagine you have a model that is constantly getting refined because you're listening to this real-time data and it's taking it in and it's training based on this data. Operational efficiency, improvements in logistics and manufacturing processes, anomaly detection, used in fraud detection or cybersecurity, improved customer interactions, back to the group chat, for example. You have an AI that's listening to this group chat or Discord channel, Telegram, whatever, and then can help you with whatever problem you have. And then health monitoring is also a really cool project. There are lots of DePIN projects that, or data unions actually, that have this real-time data where you share your health data in real time. Now, if we like do this and it's all ethically available and everything, you can use that for AI, right? You have some hospital listening to it, or like whatever you can think of, and making decisions, telling you, hey, like maybe you have a problem with your heart, go see the doctor, stuff like that, right? And then one last thing I just want to show you guys. I'm not sure how much time I've got left, but I don't think I have a lot. Is our marketplace. Who here has heard of the project Demo? It's a big DePIN project. Nice. To the people that haven't, it's basically a project that is sharing that is enabling you to share your car data and earn tokens by doing so. And Demo happens to use Streamr, and they also, and cars have like a lot of data, so it's not just the weather data that you can see here in this project, but they're sharing this weather data from all the cars that are using Demo, and you can like use this data for dashboards and other things. Down here we have also Binance market data, so you can subscribe to this data, build an AI with that, and so forth. Okay, some resources, time, all good, okay. Some resources, if you want to join our Discord server, please do so. We have another AI blog article written by our head of ecosystem, really, really cool blog article. I highly recommend to check it out. And of course, the documentation. And if you want to talk to us, we're here like the whole day, basically. And happy to talk to you guys, answer questions if there are any, if you want to talk about partnerships, if you want to build with us, or just to chat.
yeah, I'm going to be like around the area back there. And yeah, this is it. Thank you,
Great.
guys.
Excellent. Big round of applause for Nico, please. Thank you.
Thanks for having me as well.
Excellent. Well, thank you. And now we have from Super Oracles, Aniket, who please welcome Aniket, who's going to grab the mic right now. There we go.
Sorry?
Excellent. Well, welcome, Aniket. The stage is yours. The mic is on. Take it away.
Hello, everybody. My name is Aniket Kate. I'm a Chief Research Officer at Supra, and I also have another job where I'm a professor at Purdue University. So I'll be talking about something that I'm very excited about and have been building. Hopefully it comes up soon. And yeah, I see it's coming up. And yeah, looking forward to get question. As compared to previous talk, my talk will be a bit more on the technical side, but I'll try to just give a high-level purview, and let's see, we can take it from there afterwards. I'll be around afterwards if you have any questions and thoughts to share. Thank you. Okay, I can see it here, but let's wait for it to come over there. All right, so let's get started. Hi, so today I'm going to talk about how to build multi-party computation or MPC securely on blockchains. So if you are interested in privacy-preserving machine learning, that's a topic that came up sometime earlier, or performing secure aggregation of the data. In all those environments, multi-party computation is a mechanism that allows you to do that. Basically, if you heard about fully homomorphic encryption or FHE, there's also one more topic, which is basically just a sub-branch of multi-party computation. And my presentation today will talk about how to get some interesting guarantees in this environment, and what to keep, what to be aware of when you're building such solution in blockchain space in general, and especially in the DePIN environment when you are collecting data, what kind of challenges that you can be considered in this space. So when we consider this threshold cryptography or multi-party computation problem that we require for any kind of a learning, the moment we want guarantee that we need data, we need the processing to finish, we want guarantee that we get output, and we don't, not a single party just destroy my computation and just make me do that again. These we call as robustness property. You require an honest majority. Like you want 15% guys to be at least honest and be always present over there. But typically what happened, most of the solution in this space, as they started to build, at least from the academic background, consider what is known as a broadcast channel model, which means that you have magical access to some kind of broadcast channel, some kind of a bulletin board where you put things there and they are available to be used. Assuming that network keys or our internet is synchronous, that means it works at an exact clock tick. It says that I send a message, somebody else is going to receive that in exact same time, defined by my system. If you make such an assumption for the internet, indeed you can build such broadcast channels. However, that's not true for blockchains, as we are going to see, and that's not true for internet in general. And the question is that can we really consider internet or in general any network where we're building our solution in DePIN environment to be synchronous to build such protocols, such broadcast channels? And the answer is simply no, if you want high performance and low latency. So the idea is that, I'm trying to click, hopefully it will come soon, okay. Yeah. So unless we are fine with the latency of minutes, and probably you'll say, hang on, Sachin, I don't want to go for, we cannot assume internet to be synchronous. Okay, so what instead we want, consider that typical models that are more meaningful to call the internet is what we call as asynchrony, which means that there is no guarantee that message will read, but it will not get dropped. Eventually it will reach, like email. Sometimes you get email which is supposed to come yesterday, just came today. I know that it happens very irregularly, but it can happen. And the aim here is that to be prepared for that. So that's a synchronous model, asynchronous model, sorry. Or you assume a slightly weaker version of that called partial synchrony, where you say that it can be, for unknown amount of time, it can be slow, but afterwards it picks up and then things continue to work. And this unknown time is called GST. just a technical term, but the idea is that these are more meaningful models where we can build indeed internet-based protocols. And in such an environment, in general, the broadcast channels are not something which can be built in general. So I just here wrote down the definition. I won't go to the technical detail here, but my slides I can share with you if you want to understand in this here. And these are the definition we want for broadcast channel. And we can't achieve that in the model if we assume that to be not synchronous in general. And if you want to do MPC or all these tasks, then beyond synchrony on the real internet, then the typical one thing that's going to happen is that you can't solve this problem for only 51% honest party. You require much bigger super majority of them, like 67% of them to be honest for these things to work out. But not only that, it do make also the development a very cumbersome task because you have to deal with what are known as common coins, have some kind of a randomization present, or timeouts and other things. Basically, it becomes, think in this way, if you want to, it's more like you want to build an SMR but private, or sorry, if you want to build a blockchain in private, so the task to become like easily 10 times more expensive in general. And easily, I'll say, if you start building it even with good expertise, it can be easily a year or 2 years before which you can see something meaningful coming out from such an adventure. My aim from this discussion today is to show that there are interesting or easy way to build this solution on blockchains. We have to deal with some security mechanism, but it can be built. And my hope is to demonstrate that with some small examples, and for other things, I'll more say that this can be done, believe me. Okay. So there are already some solution which where they say we are going to build protocols on blockchains. It is already considered where we want to build this secure protocol on blockchain. But many of them still consider and call blockchains as broadcast channel. But in fact, they are not. So on the left-hand top, I've written a more formal definition. But what can blockchain offers you? And I want to really talk about those 3 informal points I've mentioned there. The first thing is that when I send a transaction, it will eventually appear. Okay, I can't give you any guarantee it will appear in a minute or 2. It may appear in milliseconds, but I can tell you that it will eventually appear once it reaches enough RPC nodes or validators. But I can't give you guarantee when, okay? Because there are multiple events and incidents happening on blockchain. It's a shared environment, and I can't give you any guarantee when it's going to appear there, okay? Different people may see them at different point of time because everybody just sitting in different part of the world, okay? However, they all see them in same order. So if I saw your transaction in block 10, then others also going to see that in block 10. They may see block 10 after 20 minutes, after 10 minutes, but they are going to see it in the exact same order. So I know that I saw in block 10, so you are going to see in block 6. That's a nice guarantee that blockchains offer. And by the way, I'm using this term here, SMR or state machine replication. That's just a technical name for blockchain because like a blockchain like a state, and we're replicating that on different environment. That's the reason that term. So maybe in the talk I use SMR, you just think that in your term that it's a blockchain in general. All right. So, and this blockchain cannot solve this broadcast channel. So again, I'm not going through the technical detail, but you just can't achieve the termination property. So blockchains are not equal to broadcast channel. And we have to think about these when we are building this SMR channel from the first principle perspective. And this is just like a summary slide that I already mentioned. So broadcast channel assume that there is a known delta that every message is going to appear on chain. We can't guarantee that. And everybody sees them, and at the same time, we again can't guarantee that when we call blockchains in general. But the property that SMR achieves is still sufficient. We just have to make minor adjustment and solve the protocol. But why should we go that? Is that we are good at building. Now, what we have shown with starting with Bitcoin, Ethereum, and all new systems we build is that by now we are good at building blockchains. So once we build blockchain, now can we build privacy-preserving protocols based on them efficiently without reinventing the wheel is the attempt over here. So can I use blockchains or SMR and build privacy MPC protocol, multi-party computation protocol on top of that is a quest that we are looking into in this case. And while doing that, if we can do that more efficiently, even better. So the first thing, the core principle there to consider is secret sharing. I have a data, and I want to post that on chain in a fashion so that nobody knows what that data is, and so that later it can be used. The prominent mechanism in that perspective is the secret sharing. It provides interesting properties over encryption in general. And if you're using broadcast channel, it's required 51%, again, required any honest majority, 51% honest party sufficient. If you can't assume synchronous or broadcast channel, you required much higher number of nodes. So the way to look at it this way is that when you say something as a problem I can solve for 51%, mean that I can tolerate many more bad parties in the system and my protocol will be still secure. But when you say 67%, that means even 33% of nodes go bad, things can go wrong. So whenever possible, I want to have a low number of honest party to make the system work. So what we observe is that if we assume this blockchain channel available magically, this whole problem becomes extremely easy. The only thing is what we have to know as non-interactive VSS, where non-interactive terms say you just create this VSS like an encryption and you just post that on blockchain. And everybody is going to see that in exact same order. We have to use some very simple zero-knowledge proof for that, but it can offer a very nice properties, and all our problem can be solved for honest majority. We do not require super majority for such thing to work. So, and in general, so here's the summary slide. So if you assume broadcast channel like it was assume more in academic literature, you can solve this problem 51%, but again, we can't assume that to be true. If you go to the pure asynchrony, you require many more parties and require more honest parties. But we assume that you have access to some blockchain, and that blockchain is fast enough, we can solve this problem much more efficiently, very easily, without requiring much programming on the developer end, using just 51% honest party. And that's a good way to start building such systems in such an environment. The next thing is now what is known as distributed key generation, or DKG. Some of you might have heard about the concept, where somehow you want to have somebody providing threshold signature on your environment, or basically maybe we can call it the more space efficient version of multi-signature, if you heard the multi-signature term. There also, this protocol can be built very efficiently on the SMR just by extending my verifiable secret sharing scheme. And where now what will happen is that we'll have some key which is secret shared on such an environment, so that nobody knows that key, but these parties, my part, node 1, node 2, node 3, can themselves sign data for you, such that even when, as long as at least 2 of them in this example, or as long as 51% of them are honest, no incorrect signature can be generated, or only correct signature can be generated. So it's also a highly relevant concept also from the account abstraction perspective as well, or building more complex escrow environment or any such privacy preserving solution. And again, this is the problem. If we don't build these solutions without SMR, just purely on the internet, we have to go for 2/3 honest majorities. But again, once we have access to blockchain, the problem becomes much more tangible and much easily solvable in such an environment. And again, programming becomes highly efficient. So the aim, my key theme, as you can see, is to how to build these solutions assume that you have access to a blockchain, and how to make them efficiently and securely without having any issues or vulnerabilities present into such an environment. Right? So once we have such a thing available, it can be used to generate randomness services. So if you heard about VRF, like randomness services that required for gaming environment, or all others, even other DeFi environment, how to build that. Once you have such infrastructure I showed that's available, you can build these services very efficiently in a purely asynchronous manner, very simple programming. You don't need to, as long as you have SMR, your blockchain is working, everything will continue to function correctly. Okay, threshold ECDSA, EDDSA signature. That's like say you want to build signature for Taproot. This approach can be used in that perspective. Again, in a one more aspect is publicly verifiable manner. That means you can prove to the world that you are doing computation in a fashion so that anybody who comes and check that blockchain 10 years down the line can still know that you did that computation 10 years ago in a correct way. That's certainly something that's possible. And in general, multi-party computation or privacy-preserving computation that we want to perform, that can be built in what is known as threshold linear homomorphic encryption. And because many people, I assume, already heard about FHE, so this is a way to do it in technical level, but maybe I'll be happy to discuss, but I'm not going through the technical details over here. I make sure to add in case there's some technical audience who can catch a word, and then we can discuss later. But I want to even dedicate one slide to comparison between FHE and MPC, as I was trying to explain here. So I assume you heard about FHE. It's certainly something that's getting picked up quite a lot these days. And conceptually, FHE could be looked at as the one way to do multi-party computation in general. And there are multiple ways to do multi-party computation. What I'm trying to show is what is known as secret sharing-based multi-party computation. And here is one slide where I'm trying to provide some comparison. And somehow, thankfully, with some graphical I got, so I want to show a bottleneck, right? So if you look at the fully homomorphic encryption, it's an expensive task. Okay, things happen. You can continue to work on this environment. There is no communication that you have to perform per se that much, because everything can happen just on the blockchain. Okay, but it's an expensive task to add and subtract. On other hand, if you consider multi-party computation, as I was saying, it's network bound, where you have to do some interaction, you have to send some messages to the network to make it work. But in that respect, if my network is fast or network is good, but my computation available to the node is not so good, in that case, I should go for MPC, as I was mentioning. On the other hand, I have like extremely good machines, and my computation have lots of what we call as multiplication or processes which will require interaction, then I should go for FHE. Is the approach. So they offer interesting trade-off that has to be considered when you're building solution. But I can simply say anything that we can do with FHE or fully homomorphic encryption can be also done with this approach, and vice versa. But the idea is that there will be interesting trade-off present, which will just clearly demonstrate one thing or other as you required for your applications and your environment and use cases. So hopefully we'll see many interesting things happening in this space in this year as well as in the coming years. And we already have codes available for all these environments that people can play on and try to understand the things. And hopefully we'll see many interesting things getting built in production based on that. So in conclusion, I want to say that using SMR to build all these privacy-preserving solutions is a really good idea. It can allow us to have better resilience. We can tolerate more faults. But more importantly, it can make the development a very easy task, and that can be that can play a significant role. In general, there are also interesting problems I keep putting there, like being in more academically oriented, how to prove these lower bounds and other things. But and there's a lot more to build here, but still things look promising and very interesting to build upon. And thanks a lot for listening to this talk. I'll be around if you want to have some questions here, or if you want to reach me, you can reach me on Twitter, or you can just send me an email to my
Great.
academic address.
Well, listen, thank you so much. Round of applause for Aniket, please. Thank you. And up next, we have Slava from DRPC. So please welcome Slava from DRPC with a fresh mic, ready to go. There you go.
Yeah. Hope it's working. Hey, how's it going? I will try to be short because we're out of time. So maybe I will help a little bit. So the presentation.
While we're waiting, I'll just kill time by mentioning one thing, just so everyone's aware. Stick around at 3 o'clock. We have Fluence launch. We've got Juan Bennett from Protocol Labs and Kyle Samani from Multicoin. Fireside chats with both of them and hear about Fluence, our cloudless compute platform that we are launching today. So stick around for that. It's going to be worth your while for sure. And we've got the deck up. So Slava, back to you.
Okay, so yeah, my name is Slava. I'm CTO at drpc.org, and I'll talk a little bit about like RPC decentralization without compromises. And probably this talk has a little bit the topic is a little bit misleading on purpose. So yeah, as I said, I'm CTO at DRPC, and we're building universal access to a collaborative network of data providers. Doesn't really matter what that means right now, because my topic is about RPC decentralization in a whole. So we're quite, in crypto, we like decentralized stuff. Like we're trying to build everything decentralized, and when we're facing a choice to build something decentralized or centralized, probably we will prefer decentralized, because like it is part of our ethos. However, because of that, a lot of the time decentralization became an excuse basically for bad UX, bad DX, weird interface, bad performance, and all this stuff. So we're like, it's not because like we're bad, because early there was a lot of developers and tech-savvy people who were in crypto, and they kind of were okay with that, because we were pushing, and we're still pushing, the bleeding edge of technology. However, a lot of clients don't want to hear about that, and a lot of users don't want to hear about that right now. They actually don't want it to be decentralized. They want to have a good quality. And when we're talking about RPC, the market when basically is B2B. You have a business that pays you for providing data on chain for RPC, and they are quite don't want to hear about your fancy decentralization stuff. They want it to work. So what really they want? They want three things. They want high speed, high resilience, and they want low cost. And they will, if you're saying that you're decentralized, and then they will talk with centralized provider who offers them better latency or lower cost, they will probably go with it. So let's start a little bit with what is every RPC architecture. For those who don't know, RPC is basically the protocol that allows us to get some data from the blockchain. And every RPC provider that decentralized or centralized, no matter, will have something like that. So basically there are three components of that. It's basically blockchain infrastructure, so nodes, and also a load balancer. Because even if you're a centralized provider and you're running your own nodes, you need some kind of load distribution. So you will have load balancer, maybe it will be very simple, but still. And web UI, where basically the place where developers will come to copy-paste the RPC endpoint link. So if we're talking about centralized RPCs, well, it looks kind of like that. Everything is controlled environment, and our industry is on this centralized RPC needle for a good reason. Because as I said previously, clients don't care about technology. They pay you money for quality. They pay you money for resilience. And yeah, they don't want to pay a lot of money. So centralized RPC providers is the easiest way to reach that, fulfill this promise. Everything is controlled. You can set up your own nodes like how you want. You can set up settings, everything. It's just easier. And when you compete with the centralized providers, you can say, I'm down 30% of the time, but I'm decentralized. Well, when we're talking about decentralized RPCs, probably we'll look at something like that. So there's still those components. The difference is that if we're talking about infrastructure, it's probably decentralized and permissionless, meaning that it's like some independent actors and anyone can join. Yeah. But also there's some load balancers and web UI, and I will talk a little bit about it later, because decentralized gateway is actually very hard stuff, and yeah, we need to talk about it in detail. So when we zoom in this decentralized infrastructure, we will very, very soon we understand that it's a very complicated task. If we're talking about popular decentralized providers like Pocket Network, for example, they were mentioned a number of times already. So they run their own blockchain, which is it's hard in itself. But if you're running decentralized infrastructure, you probably don't have you don't only need blockchain, you also need staking, because if anyone can join, they can be malicious, they can do weird stuff, and you need a way to punish for them, Every provider should stake something. And if you have staking, you probably need a token, because what will they stake? And token is itself a problem. Tokenomics is quite hard. It's really not an easy task to get it right. And moreover, proof of work done. When you're decentralized, you have decentralized infrastructure. The provider should have some kind of mathematical method to prove that they serve the requests. And it's also not a solved problem for now. So, and the last one is quality checks. Because if you don't have automatic or semi-automatic quality checks and you have decentralized infrastructure, probably you will not punish anyone, and you're also running on trust. So this is hard, Yeah, and that's just the first part. What about gateways? Yeah, gateways is even harder. And actually, there is no project that I know of in RPC, decentralized providers, who have decentralized gateways, or sufficiently decentralized, I don't know. So there's a solution to that, yeah. And most of the projects take. It's like they use client libraries as gateways. Basically, it's a very neat and elegant idea, Convert any of your client to a gateway, which is cool. You can't get more decentralized than that. However, there's problems to that. So first is maintenance costs. So clients don't want to integrate your, client library. And even if they do, there's maintenance costs on their side. But also you need to, as a developer, you must maintain library in Rust, library in Python, library in JavaScript. It's hard. It's also inefficient because good gateway or load balancer, it does a lot of stuff in the background. You can't just, throw requests at providers. It will work bad. You will get a lot of errors and you will get poor latency. So you have to track some state of those providers. And if you do that on every client, it increases the load on the providers and on the client side. And the most important thing is nobody wants it. Basically, if you're talking to the client and say, okay, so you need to install this library and you need to integrate into your code, and then they talk to centralized provider who says, okay, you need to copy-paste that link and insert it in your configuration. You know what client will choose? Not decentralization. So yeah, sometimes it's just even impossible because a lot of your clients, RPC clients, they are just running some software, they participate in some protocol and they can't, this protocol does not support your client as a key. So eventually you understand that centralized gateways are necessary for 99% of the clients. And it's not ideologically pure, it's not what you promised to build, but you submit to it because otherwise you don't have any clients. And you're compromising on the centralization all the time. And eventually you have this. The picture which basically looks like that. And it's all of the, or most of the decentralized protocols out there. Well, however, yeah, you're running centralized gateways in decentralized RPC node provider, which is kind of weird, but you understand one more thing. Decentralized gateways in decentralized infrastructure actually hard. It's not the same. Info or Alchemy, they don't have to have this level of sophistication in gateways because everything is controlled environment. But data providers for this decentralized infrastructure, they build different, They have different locations. They have support different blockchain. They have running different blockchain clients. And they also have different hardware. And everything, all of that affects their latency, the requests they can or cannot perform. And moreover, for each blockchain client, there's a lot of settings. And the settings also affect this, the gas cap, I don't know, some return data limit. And if you're just, as I said, throwing the requests to them, it will work pretty poorly. So this is hard, yeah. And this is hard, and this can be built as an afterthought. But remember, if you're building decentralized RPC provider, you already invested in all of this infrastructure, and you dedicated a lot of resources to building blockchains, staking, and all that stuff. And you don't have time and resources to build this level of sophistication load balancer. So you basically, yes, you're compromising on quality now. You're not only compromised on decentralization, you're compromised on quality. Okay, so is there a fix to that? Well, maybe or maybe not. But let's imagine we are building a decentralized RPC provider from scratch right now. Like, we acknowledge a few things. First is, yeah, we have to have centralized gateway at least at the beginning. Otherwise, we just, we don't want how to do that anyway. Yeah, and we also understand that this piece of software in the right circle, it should dedicate a lot of resources to that. Otherwise, you will not be able to compete with centralized RPC providers. So what you could do, you could throw away all these blockchains and staking and other stuff, and you can go with a permissioned provider dataset. Basically, it will be the same, but permissioned. So you still have decentralized infrastructure, but it's permissioned, and you're free to invest more resources in this gateway. So that's basically what DRPC did and keeps doing. We're trying to figure out how to compose quality and decentralization. So what could be design goals for the system like that? First, the main, we should be on par with centralized providers. Otherwise, the future of RPC decentralization looks quite bleak. The second important point is we should be able to connect anything, and I mean really anything, without really affecting consumers. So you may have providers that runs on, I don't know, Raspberry Pi, or providers that run their own data centers. You should be able to incorporate them into your network, and you should, the consumers should not see the degradation. Of course, you have to build something that doesn't have any problems with when individual providers goes down, everything is continue working. And one more important and not really obvious thing is that you have to build something that allows temporary problems for each provider. You shouldn't punish them in long term if you're, for example, if they have some small outage. Because otherwise, you will end up with very few providers that can, maintain this level of quality, and basically you will there will be no decentralization. Basically, you will be running a network of 10 providers. So we spent a lot of time building this DRPC load balancing system. I won't get into detail because it's a lot of time and I don't have it. But saying few things. This is a diagram for that. We're running two-tier system. Basically, one of the load balancers set up on the provider side. It's open source. It's called DShackle. You can use it. We forked it from Emerald Pay, and we maintain it right now. It supports 56 blockchains or something. You can use it if you want for your own purposes. And we have our proprietary system that is currently not open source, but it will be, I'm sure, one day, which is basically so if for DShackle, each provider connect their own nodes to it, and it simplifies the communication between our gateway and the provider. Basically, everything goes through this DShackle, and the network structure is quite simpler right now. The purpose of DShackle is to select the specific node that will perform the request. The purpose of the centralized gateway is to select the provider that will do that. To simplify the algorithm, I'm on the booth, so you can come and ask any questions in details. I will happily answer them. So basically, we're now doing something like that. We collect the real-time statistic for each provider for many different dimensions. For the statistic depends on the network, methods, and all this stuff. And we use our own built machine learning model that tries to predict the performance of each provider in each of these dimensions in the next few seconds. And based on this information, we build a rating, and we allocate requests based on that rating. So it allows us to build, like, to basically distribute requests depending on your historical performance. Also, because of the DShackle, DShackle gathers a lot of information of provider, like what kind of clients you're running, what settings do they have, what blockchain height you're currently running, and send the information to our gateway, and it allows us to 99% of the time select the provider that will be able to perform the request. So 1 year later, we have right now a working product. We onboarded a lot of top-tier Web3 applications like SushiSwap, Curve, and they are with us not because we're decentralized, but because we have better or on-par quality with Alchemy, Infura, and other providers. And yeah, I hope that will continue. What we could do next? Like, we don't thinking in terms like we should decentralize by all means. Yeah, remember we have this thing that we need to be on par with centralized providers. So we need to first explore the things that we can do better than them in our setup. One of them, of course, is open price market. So basically, we can, now every request costs fixed price. We can remove this and allow providers to set up their own price and have more efficient price discovery. So they can compete not only on latency, for example, and errors, but also on price. And it will. This is the thing that centralized RPC providers don't have. They can't do that. So we should exploit it. Well, in the end, I want to say that in future we want future without compromises. We won't be decentralized without compromises, and we have plans for that. However, I think it's relevant not for RPC, but for the whole crypto community. Like, we can't sacrifice on quality anymore, because otherwise, yeah, the future is very centralized. Like, consumers won't care about your technology; they will care about this characteristic that I mentioned. And we need to figure out how we can build a future where it's fully decentralized, fully permissionless, with quality better than RPC, with centralized solutions. So I invite you to do that and to think more about that. If you want to check it out, go to drpc.org, and that's it.
Great. Listen, thanks very much. Let's have a round of applause for Slava, please. Great. And we have our last panel before a break. So welcome Aaron, who is going to be moderating this panel right now. Aaron from IoTex. And we're waiting for the rest of the panel. So let's see, where is Mark from Ceramic? There you go. Head on up. Do not wait for me. And Samao from Lightshift and Radu from Beware. Oh, Alex. Is Alex playing the part of Samu is Alex going up to the stage now. Radu and Andrew from Tableland. All right, we've got people are up there. And I'm going to give one more mic. I'm going to relinquish my mic reluctantly. Here you guys go. You need another mic. Oh, you got two? You got two? All right. Good. Excellent. Well, here we go. Last panel before a coffee break. Take it away, Aaron.
All right, guys. So, welcome to DePIN Day. Really happy to have you guys here today. So, DePIN, it's seen a bit of a movement, a consolidation behind this name over the last year. And really, the last 6 months have been a bit of a roller coaster in a good way. So we really want to dive today into data. And let's kick it off with some introductions here to start with. So name and a little bit about your project.
Hi, everyone. I'm Alex. I'm the head of growth for Beware Labs. We have a decentralized RPC platform that is servicing blockchain data.
Hi, everybody. I'm Andrew, CEO at Textile. We build developer tooling for data architects, and we have a product called TableLand, SQL relational database that indexes smart contracts on various EVMs. And our next product coming out is a yet-to-be-named object storage for decentralized data.
And I'm Mark. I'm a partner engineer at Ceramic. At 3Box Labs produces the Ceramic Network. The Ceramic Network is an open data network. It's built on decentralized event streams. And I'll talk later about how there's different flavors of databases that are built on top of Ceramic that allow developers to interact with the core protocol. So ComposeDB is a graph-based database. We have OrbisDB that actually just launched this morning. It's a relational database that you interact with using SQL. And yeah, really excited about this panel.
Hi, my name is Simão. I'm a founding partner at Lightshift Capital, and we are an early stage fund that also builds alongside our founders. So we focus a lot on the engineering aspect of these projects. And yeah, we're pretty excited about data, the future of it. We actually wrote a piece on it. It's called The Future of Composable Data. You can check it out on our website at Lightshift. And yeah, excited about the panel.
And finally, myself, my name is Aaron Bassi. I'm the head of product at IoTex. I'm just the moderator here, not a panelist like one of these experts here about data, so I'll let these guys get into the details of the questions here that we're about to ask. Specifically, the title of this panel is called Navigating the Decentralized Data Revolution with DePIN. So I want to start first by talking about what the future of data that we want to see in the industry.
Sure, that's a really good question. And in my daily job, in the API business, I work with a lot of users from all different industries, from DeFi platforms to NFTs to all kind of platforms. And in that time being, I realized that there are, for me, 4 main aspects that people are expecting from data. And one would be high availability, meaning that you always have access to the data. It's easily accessible from all over the world. Then, of course, reliability, that there is always, the data is, there is integrity for the data. Of course, performance is very important when it's come to latency and to stuff like this. And the last part, of course, is cost effectiveness. We know that it can get really expensive. And that's where I think DePIN can come in to help to solve at least 3 of those aspects, with the availability, having nodes and operators all over the world, reliability. If you have many sources, then you can also be sure that you have a reliable source. You can compare the data there. And of course, when it comes to cost effectiveness, decentralization is a thing that can help. And what we have discussed before, the 4th part that I was mentioning is performance. I think that's where we need to come in and innovate even more, to have the same performance on a decentralized network like on a centralized network, because actually that's what people care most about. It's not the decentralization aspect. When you have an application, you want it to be always up, and then the performance is the most important part of this. And with Blast, we have managed to to get quite, to solve this challenge, and yeah, maybe later we'll tell a bit more about this when we go to the next question.
Same question?
Yeah, same question.
Ask it again, because I want to make sure I'm answering it.
Yeah, I want you to tell me about the future of data and what you hope to see.
Yeah. All right, so I'm going to take it from a different angle, because I think he answered a lot of the on the ground, this is what we need to do. So kind of from a meta layer, on the internet, the way that you create value in organizations and on networks, there's various different ways that you can accelerate the value. Oftentimes, you can summarize different categories of network effects, and data network effects is a huge one, and we've seen it, take off in centralized organizations over the last couple decades. Data network effects on the internet are incredibly fragmented, so there's a lot of organizations that try to aggregate that value and snowball it into new value, and then it's a power curve, and there's a few organizations that have locked up a majority of that data network effect, and that runaway growth is about to accelerate for all the reasons that you can imagine. I think our opportunity is to defragment the data network effects, and I think we're all creating such valuable data right now. There's already huge amounts of data passing through Web3 pipes. So how do we pull that together and actually make that value accelerate as fast as we can? So at a meta layer, that's what I'm really interested in.
Thank you.
I think just to go off of that a bit, one of Ceramic's core focus is the composability aspect of data. So like you said, there's a lot of different ecosystem players producing a lot of useful user data, and how to make that data work together in a way that benefits both the end user, who's able to take their identity or take their reputation or the information that they're creating from different environment to different environment, but also benefit end developers who are able to circumvent the cold start issue and use real user data from day one. So that's what I would say.
Yeah, I actually completely agree with both views. First of all, like we need to unlock the value of all these data, and then we need to make it a lot more composable, right? The problems that we're seeing in Web 2 are exactly the same problems that we're seeing in Web 3. Everyone is discussing like the state of Ethereum and Solana, right? It's pretty much the same thing that we're seeing in Web 2, because we could not scale this infrastructure. It was very hard. Then Amazon came in, but then it's still very fragmented, right? And so what we'd love to see is some type of infrastructure where we can have a lot more use cases built on top of it and unlock the value of this data. So first of all, having storage, then being able to retrieve it very easily so we can access it no matter where it is, right? And Amazon and these big players nowadays, they completely force us to leave the data there because you don't pay to put the data, but you pay like 3 times to remove the data. We'd love to see compute on top of all this so we can extract the value and insights from what we're storing, and finally having smart contracts. So making them like in a way that we can trust the outcome of this compute, and then we can trigger actions either on the blockchain or in real world. And we believe that's what all this like DePIN infrastructure is about to bring.
Yeah, heard a pretty consistent theme there. It seems like we're all in the same boat and think that Web3 is a great answer for some of these different solutions. So let's talk a little bit about where we are in that current roadmap and how long it will take to get to this vision that we discussed.
Sure. Yeah, the current status here, I'm going to talk a bit more about what we are building and how we are standing right now. So Blast is a decentralized RPC platform leveraging third-party node providers. And of course, what we discussed before, you might ask yourself, how can we offer performance? And these are things where we still need to innovate. Right now, we have 2 aspects on that side, and one is that we have internal, so it's not totally decentralized. These are things that we run ourselves. We always check the health of the nodes in our protocol, and of course the performance when it comes to latency and stuff like this. This is all still centralized, run by us in order to guarantee the performance. So yeah, the current status is that it's still a mix of decentralization, parts of decentralized stuff and parts of centralized stuff. And this is what I was mentioning before, I think, where we can innovate a lot more and yeah, bring this even further in the decentralization part.
Yeah, super complicated question, actually. I don't really have a good answer for how far along we are. I'll say like, I think the whole DePIN umbrella is showing us that there is really valuable data being unlocked. Networks like WeatherXM are creating data where the value is the actual asset, the data is the actual asset that the network is producing, and that's going to actually demand a lot from the tools and the ecosystem that's built around it. And there's a good number of networks that have that same proposition, and so the demand is finally there. Whereas, like I was saying out during coffee, that like what's old is new again. We tried to build similar technologies 4 years ago, but the demand for data on Web3 was nascent, and so it was too early. But I think this time around, like every talk you've seen, even from the first 1KX talk, just showing that there is demand, there are people actually running hardware that are creating original data. All the EVM layers are all creating their own original data. There are ways that we need to bring this together and make it actionable and able to build things on top of it that they're demanding. So I think it's accelerating really fast, and we're going to have just amazing solutions over the next year.
I think I'll address the question from a perspective that lives at the application layer. So as a partner engineer, I work with different teams building on our infrastructure. And what I'm noticing is we have the functionality, the capabilities to enable composable data across different environments. But what I'm realizing is even though that ability exists, it's so far been kind of difficult to organize around, for example, like what does a canonical, profile look like for, a person given this environment, and how do we ensure that all of these different applications who are basically using the same data and want to be leveraging the same user base are able to compose across these different environments. And I think part of the issue there is the underlying incentive mechanism is still kind of yet to be established or fully thought out. But I do see a lot of promise in where that's headed, because now that, at least from a Ceramic perspective, we have the underlying capability to allow it, it's now just a means of like facilitating it.
Yeah, so maybe giving an example, we usually look, okay, what are the impacts of like this composable data can have? And we would like to see a world where we can have all these layers that I was mentioning before, right? In different use cases, such as like DeFi, which is something that most times we don't associate that much with. But for example, when we think about how can we build a better DEX than like Uniswap v3, for example, to improve the capital efficiency and reduce slippage, we'd love to, for example, see a world where we can store all the data from all these blockchains, right? Not just transactions, but really going to, okay, what was the volume? What was the user? What was the time at these users are trading, right? What kind of assets they're interacting with? So really extracting a lot more data from these simple actions, storing them somewhere. Then we can have compute on top of it. So machine learning algorithms that are trying to understand the demand for some types of assets and liquidities at certain points of the day in certain exchanges. And based on that, we can trigger smart contracts that are going to adjust the liquidity at certain times so people don't have to move them, right? So this is just like a very simple example of how like data and AI could kind of like improve something as basic as DeFi. I think we're still a bit far from that, to be honest. Only now we're being able to kind of like building all these L2s for compute that can go and grab the data and actually do compute over data, so we don't have to move it, right? Because we're seeing like a lot of projects doing like computation and decentralized computation, but you still have like to move these data to where the compute is, which is like extremely expensive. And so I think we're only now trying to create almost like put some glue on all these topics to kind of like bring them together and create something that is like cohesive and easy to use.
Yeah, I love that. So my buddy Larry on our BD team at IoTexi coined this thing. It's called the holy trinity of technologies that were kind of appearing. So yeah, DePIN, AI for sure, and then data. So DePIN to collect the data, you got your data, run AI on it, machine learning. I think those three in conjunction are gonna make some big differences in the very short term in the next couple of years, and that leads me to my next question: is how do you see DePIN revolutionizing the data management of the next couple of years? Over the next couple of years?
So yeah, especially when it comes to blockchain, data has been a really big challenge in the past, and it still is. So I think DePIN can really come in here and help leveraging those unused compute power that we have, making data more available, all the points that I mentioned from the first question. You have so many points of access, so many data lakes, and it makes it much more reliable. You have always access to it. So I think really this is something that we need to go to the next stage, because right now it still happens from time to time that the data is incorrect, blockchains are halting, a lot of stuff going on that's not stable. So I think really DePIN can help come in and get all of these bad things out of the network, let's say.
Yeah, I think a lot of these problems that we'll face in collecting, organizing, mobilizing data, I think there's just really big opportunity to create competitive markets to make it more efficient to solve those needs. And that's something that DePINs and token economies have been really good at. There were some good examples of basically that being the superpower in Bitcoin over the years, is making people compete to make, you know, the hashing algorithm the cheapest, most efficient network doing that possible. And I think that we can replicate that with data and DePINs again and again and again. And these open competitive networks just will allow us to compute the next generation of data faster, better, more efficiently in more places.
I feel like at this point I don't have too much to add on, but for me, again, I think it comes back to the composability aspect. And to give you a more specific example, kind of the organic behavior that we're seeing across a lot of these different teams and environments that are building on us is the need for a computation of user data that comes perhaps from, like, you know, disparate different places, but ties back to one individual. And then there's some, like, layer of opinion, or like a computation of opinion that, you know, weighs those different data points and then personalizes it for the user. And the user then can choose which UI to access, but they're all indexing on the same information that ties back to that user. That's not really possible anywhere else. So that's what I find most exciting.
Yeah, let me riff off that a little bit. So the composability thing, I really do love that second time you brought it up. And I think the synergies between some of the DePIN projects that are already out there today, like the fact you can pull weather data out of your demo smart card. I didn't even know that was a thing, man. Like, I didn't know you could pull weather data out of a car. Like, the synergies that we can see here between some of these different projects, like WeatherXM, maybe riffing off it. One of the projects that are building on IoTeX called EnviroBlock, they're talking to these different projects about how do I import weather data, how do I export. Like, I think the composability factor is going to make a big difference in the next couple of years in revolutionizing the space for sure. So kudos to that point for sure.
Yeah, so there are two main ways that we think that DePIN can revolutionize. The first one is on the amount of data that we're collecting. So exactly to that example, right? We're going to have like a lot more machines that can track a lot more data points, and we'll be able to have a lot more data going on. Actually, on our article, we mentioned like the expectation, according to several stats, is that the amount of data is going to 10x over the next decade. And so that's the first one. But the second one is we actually, even though that's the amount that we report, we don't agree with it, because we believe that we're completely missing the connections and the exchanges between all these DePIN networks, or kind of like agents that are going to be operating, right? So we're going to have like all these machines that are probably going to be responsible for the majority of transactions that we have on the blockchain, that will be communicating with everyone else, and we'll want to also store that data. And so that's the main thing that we're seeing is, okay, we're talking about like compute and retrieval and applications on top of it. I think very soon we're going to go back to data storage, because it's going to grow so much. And once again, is exactly the same thing that we're seeing in Web3 and blockchains, right? We're going to be constantly moving from monolithic to kind of like horizontal scaling, because the state is going to keep on increasing so much until we kind of have like a solution that we're comfortable with.
All right, guys. Thank you all for joining the panel. That's all our questions. Just wanted to see, is there any final thoughts you guys had before we wrap up here? All right. I think we covered it all. Thanks, everyone.
Great.
Thanks, guys.
Thank you. Big round of applause for the panel. Fantastic. And guys, we now have a long-awaited coffee break. Everyone enjoy 10-minute, 15-minute break before we're back here for another several sessions.
All right, guys, we're ready to continue. Please come to the main stage. There will be amazing talks from amazing speakers soon. And I'm gonna announce the talk by Ryan King from FOM. Let's give a round of applause.
Hello. Hey, everybody. This is Ryan. I'm a co-founder of a project called Foam, and we're working on proof of location. So excited to give you an update on what proof of location is and a brief glimpse of our current MVP demo. So taking a step back on what is proof of location, or why would you be interested in it, is first thinking about how we utilize positioning today. So traditionally, we rely on a system called GPS. This is a satellite system that's operated by the US government and made available for free for commercial and civilian use. So there's about 24 satellites currently orbiting Earth. And for you to be able to use this system, your phone or GPS device has to hear from at least 4 satellites. So one for X, Y, Z, and a fourth for time variance. And so GPS has been a tremendous economic value. Things from Garmin to Pokemon Go to Uber all rely on GPS. So it brings value across a number of different sectors. So how valuable GPS is, it's also vulnerable, and its vulnerability has been on the rise. This is through things called spoofing and jamming. Jamming is when you interfere with the signal with a different radio, but spoofing is actually easier. Because GPS is only one directional, and it doesn't know anything about you on the ground, you can easily change your GPS on your phone. So this is very popular with Pokemon Go, as well as with Uber or Lyft drivers, and Uber or Lyft has to find ways to counter spoofing. We've also seen in different DePIN projects themselves of people spoofing where they put the radios to try and earn more tokens. So GPS is essentially vulnerable and can't be relied on for verification at the level of like Bitcoin or Ethereum. So the problem that we're looking at is GPS is extremely valuable, but it's not secure. Data is not verified. And people have to build additional systems to try and check on those things. In and itself, it's a single point of failure, and then if it goes down, it could affect things from ATMs all the way to how your phone works. And like I said, it's trivial spoofed. You could either download an app on your phone, you could open the developer mode, or you could get more sophisticated ways to trick us GPS. And so when it comes to smart contracts and doing things on chain, you can't really rely on data that's so easy to make up or spoof. So at Foam, the solution we're working on is a terrestrial-based radio network. You can think of it as kind of a local GPS. And we use time-of-flight algorithms to do like multilateration, triangulation. But the difference between GPS, other than it being on the ground, is that it's bidirectional. So as a user, I can actually talk over radio and sign a message with my Ethereum key and have that be relayed on-chain. So this is how the system essentially works. We call it a zone of coverage. And you need at least 4 zone anchor radios. We have some at our booth if you'd like to see it later. And so zone operators can operate a zone of coverage. There'll be cryptoeconomic incentives to do so. And then use cases of users, whether that's a person walking, a bus, a ferry, can talk back to this system, pay a fee, and generate what we call a presence claim, which is essentially your proof of location. So the previous image was abstract. This is what these zone anchors look like. On the left is our plug-and-play model that we have an example of on our booth. And we've also have some DIY models we've built using Raspberry Pis. And this is some example of what the installations look like on different rooftops with like fiberglass DBI antennas and things like that. As well as in the middle, my colleague Coleman, who's here in the audience, holding a mobile node for testing, creating presence claims. So yeah, more detail, this is the plug-and-play zone anchors. We have 100 manufactured for a pilot run that will be available for an incentivized testnet to be announced soon. But otherwise, this is a custom PCB with accelerated hardware. We're built on an FPGA, and we use that for nanosecond level timestamps for localizations. In addition to hardware, there's a lot of software that enables proof of location. Our main application is called Hostel. This is where you could manage your radios and see things even like the CPU temperature, as well as what experiments have been run lately. And our core software is something called TimeSync. This runs on all our devices and can manage our radio transmission patterns and how packets are timestamped. I might not have mentioned the radio we currently use. It's called LoRa, which is a low-power IoT radio. And so in addition to having hardware and firmware, we're also a blockchain-based project. And our current MVP, which I'll demo in a moment, is built on the Optimism stack, the OP stack. So we have a set of smart contracts, which is like how you create a zone and how that's managed with a stake, and then how different payments would be paid by users when these what are called mobile presence claims are generated by mobile nodes. So these are some different versions or evolution of the mobile nodes over time. The one all the way on the left was a full radio we used to carry around, not very convenient. The one in the middle is the one we've been using for the last year, and that one needed to be plugged into a computer. And more recently, we've been testing this beta one I have here, which is fully wireless. Still a beta model, can be a lot smaller. But you do essentially a one-time pairing with your laptop to sync it to your MetaMask or Ethereum wallet. And then otherwise, it works fully wireless. And when you want to click the button, it will transmit. So that probably should be the next slide. Yeah, so I have a video, so that's possible to pull up. Okay, so this is a demo of the Hostel app I mentioned. We have a mobile view as well I can show after. So if I had just clicked the button and I was in this zone in Brooklyn where there's coverage, it'll start to spin and show that those different radios heard me. Then popped up that I was heard by at least 3 radios and I got a localization. So then it prompts, would you like to mint this on chain? In the demo I said yes. And then it showed all the previous presence claims I had created in the past. That's the one that I just made. So this is now minted on our Foam Optimism DevNet chain. And this is a zone in Brooklyn. Then in the app, you can look through all your historical presence claims, see them on the map as well. And then you may want to be able to use these presence claims for different applications. So maybe that's a geo-gated NFT. Maybe there's a delivery you're making, and to get the payment unlocked, you must prove you were near where the delivery was made. We like to see this as a primitive that other people could build on top of or hook into. So hopefully the most exciting use cases won't come from us. I always think how Twitter hashtags were invented by the community. So that was a quick video. We have more videos by our booth. If you guys want to check us after, we can go back to the slides. Thank you so much. So yeah, we've most recently been focused on this MVP demo of having a user flow, a front end, and actually being able to mint presence claims. So if there's a zone, unfortunately there's not one in Denver. We have some in San Diego, Texas, New Jersey, and New York. So if you were there, you would be able to then sign cryptographically over radio. And when you're heard by these zone anchors, you'd be able to mint that on chain. So we've been building this for a number of years and started with a test network in the Brooklyn Navy Yard where we're based. And about a year and a half, 2 years ago, we opened up a beta program. This was called the Trust Zone beta program. We had a number of teams from all the way from hobbyists all the way to wireless internet companies help us test these radios. And the purpose of that program was not really on the blockchain side, but it was more on how do these radios perform in different environments. So we had rural as well as urban environments, and a number of teams help us get that testing done. I don't have the video up, but we also have a mobile user flow as well, which we can show you at our booth, where once you have this wireless node set up, all you would need is that node and your phone, and you would be able to kind of see the zone hearing you in real time and when you would be able to mint. So we have a mobile flow as well. So I kind of mentioned through the talk, but this is a low-level primitive that things can be built on top of. So proof of location is not the use case in itself. But some use cases we're excited about are like a secure location passport, so some sort of private sovereign history of where you've been that you can bring on chain. We're working on a demo for NFTs and gaming. If anyone's ever heard of the board game Settlers of Catan, we're working on a augmented version of that. Well, each zone will have different resources, and you would either have to go to all the zones or trade with people who've been to them. But there are more kind of B2B traditional use cases where alternative positioning technology is playing a role. That's primarily in like supply chain, free trade zones, ports, and things like that. So this technology can also play a role there. But yeah, as I'm trying to kind of convey, we see proof of location as a new crypto primitive that then could be built into and enhance other applications. So this is something that can be powerful for smart contract developers. It's something that's new and novel on-chain. Ultimately, the network will be incentivized for people to provide coverage where people want this kind of coverage. And we have custom crypto-accelerated hardware. So in case anyone would like to get involved and operate a zone, we still have kind of a wait list and a rolling participation there. The main requirements are you need 4 locations that have line of sight to each other. You need this initial 4 with line of sight. Zones can then be bigger with more nodes that don't all need line of sight. And so these are the requirements for the DIY nodes. These plug-and-play nodes we have now will definitely be able to go larger distances. But we have some of our contact information here, and we've more recently been active on Farcaster. If you can make an account in the Warpcast app, we have a foam chat room there. But you can find us in the links here, and thank you everyone for your attention and time.
Great. Thanks very much. We are taking one question.
Pretend to be somewhere else. And the second question is, who gives you your proof of location?
Yeah, to the first question, you could give your radio to someone else, but ultimately the protocol will be behaving as expected, as in a radio with a private key is paying a fee and the radio itself was there. In terms of like someone hiding a radio or something, that's on the application layer. So the application could like randomize where they want the location to come from, or say we want 3 within this time window, so you couldn't hide a radio everywhere. In terms of who gives you the proof, it's the zone itself of the other radios on the roofs that's countersigning your message as a user. So if like at least 3 heard you, you can get a localization, 4 to get a more accurate localization, and then they pass that on to the chain.
Great. Well, listen, is that good? I think we're going to stay a little bit ahead of schedule here, which is unusual, but let's do it and take it while we can. So with that, I want to thank Ryan. A round of applause again for Ryan. And introduce Chloe, who is coming up from Orchard. So give Chloe a big hand. She'll be up there in 1 second. Grab the mic from you. Are you up there, Ryan? Transfer that mic. Thank you. And Chloe, give me 1 second before you start. I'm going to go in this other room for 1 second. Excuse me. Sorry. Hello, everybody in this room. We're getting started. I want everybody in here to know. Hello. This is your 45-minute coffee warning. The coffee and water bar are shutting down at 3. This is your 45-minute warning. The sessions have resumed. Come into the next room. Uh-oh. That's not effective. All right, Chloe, it didn't have the right. All right, well, now we can get started. Hopefully we'll turn the lights out in there in a minute.
Awesome. Thank you all. Hi, my name is Chloe Avery. I am a mathematician, actually. I work for Orchid. If you're familiar with Orchid, we have a VPN marketplace, but we're actually launching a new project. We're building a decentralized data storage system. We're calling it Storkid, Storage Orchid, Storkid. There we go. So one question that you might ask is why decentralized data storage? I mean, in this space, we kind of love to throw the word decentralized in front of things, but why storage specifically? So one of the things that can happen is when you're storing your data with, you know, a single company, that company can go, you know, products can go defunct, that company can no longer exist, or they can start making you pay higher and higher fees. They can hold your data hostage. So we love decentralized data storage. The idea is that you're going to store your data with lots of different providers. Oh. So our goal is to design a system which is trustless, incentive-aligned, configurable, and decentralized. So there are sort of three main parts of our design that I'm going to talk about. The first one is provider selection and payment handling. We'll talk about audits, and then we'll talk about file upload, download, and maintenance. So one of the things that we use is stake-weighted random selection. So if you've seen our VPN project, you might know that we have a directory where providers can, and this is going to be the same for the storage project, we have a directory where providers can stake some amount of tokens, and then they will receive a proportionate amount of service. And then the other thing that we have is nano payments. So the idea behind nano payments is to be able to send tiny, tiny amounts of money. And I'm such a nerd, I'm a mathematician, so this is really cool to me. The idea behind this is, say I wanted to send you a penny. A lot of times you can't do this actually because, or maybe fractions of a penny. You can't do this because there's going to be fees, you might not have to send some like minimum amount. So instead of sending you a penny, what I'd do is I would send you a 1 in 100 chance of getting $1. And if you do this enough times, law of large numbers and all, you'd actually end up receiving kind of the same amount of money. So that's what nano payments are. We're going to use those to pay for storage. So if you're storing data and you store it in just one location, that can be incredibly dangerous, right? Something could happen, locally. So instead, the idea is that we're going to break up our file into a bunch of pieces. And we're going to do this by using something called erasure coding. It's this really cool math stuff. So what the idea is that we're going to break our file into, say, n pieces. And you do this in this particular way such that any k can be used to reconstruct the file. So maybe an example here is, say I broke my file into 40 pieces. Any 20 of them could be used to reconstruct the file. This is really nice because if some of those storage providers go offline, you're still going to be able to have your file. So this is super robust. And actually, we go a step further. We use something called twin coding. And the reason that we do this is because it actually turns out that it costs a lot when you're doing repairs. You have to pay for bandwidth. And so we use twin coding in particular to mitigate bandwidth costs. And then a lot of other decentralized data storage projects add another actor called an auditor. So if you're having a bunch of people store your data, you're going to need to make sure that they are actually storing your data, right? But the problem is that adding an auditor is just another person that you have to worry about trusting. So what we do is we do not add an auditor at all. We have two types of audits, interactive and non-interactive. Interactive audits happen when the client is online, and that's just direct communication between the client and the provider. The provider is able to provide proof that they are actually storing your data. And then when the client is offline, this is where it gets a little tricky. When the client is offline, the auditor or the providers will actually self-audit. They will provide proofs that they are actually storing the data. They check each other, the providers check each other to make sure that the other providers are actually storing data. And they're incentivized to do so because if they find out that another provider is not storing their data, then they will get some fee. And the other thing is, sorry, I'm forgetting what I was saying. So storage providers will audit each other. Oh, and then storage providers post their proofs on chain, which I know what you might be thinking. That sounds like that's probably going to be incredibly expensive. But we actually mitigate this cost by using something really cool called proto-danksharding. Maybe you've heard of this. It's very neat. Yeah, so if you want to know more about our storage project, come talk to me, come talk to the other ORCID folks, scan this QR code, read our light paper. Yeah, we'd be happy to talk to all of you. Thank you.
Great, thanks very much. Fantastic. Any questions? Do we have any questions? We're a little bit ahead of schedule here. Any questions for Chloe? No questions. All right. Well, thank you. We've got a panel coming up. I've got to make sure everyone is ready for this. So give us 1 second. I know I saw Shannon around. But guys, hold out for 1 second as I gather the panel that's coming up shortly. But again. Thanks very much, Chloe. All right. We've got Hugo. I see Hugo up in the front there, right? All right. We got Hugo. We need Ayush. And where did Evgeny? Evgeny just walked. Where did Evgeny walk to? Hold on. Let's go, guys. Got no panelists. Don't know if we need them, but let's see. Three. The other thing finished early, so now we're ready to go. But we're gonna figure out what it's at. That means everything's gonna be early, so there's not. can yell. I can yell in this. Just a question of how long.
If mic works there.
It stops working right around the corner, which is the frustrating thing. And so we're not supposed to start for another 10 minutes. So I don't know how long we want to talk. We got a 30-minute panel, right?
Yeah.
So we have time.
It's better to wait. It's better to wait time. Because we want to start this.
Then, yeah, because we want that to be closed and people to be in here. Yeah, I get that.
This panel, should I be in this panel?
Yeah, this is you.
Oh, okay.
I'm playing the part of Scott Burke. And Hugo's up front. Here, you guys see the questions?
No.
There's some good questions. I didn't even write them. I think we may hit some technical. You get the technical ones again.
She actually finished earlier, right?
They both finished. right, Hugo, let's do it. Evgeny. Evgeny, time. Yeah, Shannon's here. I just saw her. Shannon. There we got Shannon. So we have 4. We're missing. Well, we're missing. Yep, grab that. We're missing. He is. Where is he? Come on up. Get up here. What are you doing? Come on. You're holding up the panel. What are you doing over there? There we go. Don't be shy. Welcome. Here's a mic for you.
Yeah, thanks.
Great. Well, listen, thanks everyone for, we're kicking off the post-break part of DePIN Day, which is really the last part before the main attraction, which is the Fluence launch, which is going to take place starting at 3 o'clock after this panel. So everybody get ready for that. Kyle Samani will be here from Multicoin and Juan Bennett as well. So stick around for that. As of right now, we're going to be talking about the challenges of DePIN. And so this is not necessarily the most uplifting topic, but one we have to address regardless. And so everyone here has different perspectives on that. So I think I want to start the sort of standard way. Everyone give a quick introduction of their name, their project, and then we're going to dig into some of the challenges that we face in different aspects of as we build out DePIN networks. So Hugo, kick it off.
Hi everyone, I'm Hugo, co-founder and CEO at Minima. Minima is a proof-of-work layer 1 blockchain where every single device runs a full constructing and validating node. We can run in full on mobile devices, IoT devices, and eventually on chip as well. That allows us to effectively do access control, token generation on device, data attestation on a device as well, and also peer-to-peer communication between nodes as well. So a completely decentralized network.
Evgeny, co-founder of Fluence, together with Tom. And we're working on cloudless computing platform, as you probably guys know.
Don't assume that. Don't assume that. And if they do, they need to know more.
Yeah, so it's basically the decentralized analogy to cloud computing platforms, to centralized clouds. And we're going to tell how it works later on our talks.
Shannon needs a mic.
Hey, I'm Shannon. I'm head of growth at LivePeer. LivePeer is one of the OG DePIN projects launched in 2017. We are a global decentralized network of transcoding GPU node operators. So our node operators run GPU chips with encoding and decoding. I just gave a talk at ETH Denver to announce the launch of our AI video subnet. We're adding new AI video processing capabilities to the network. Happy to chat more about that.
Hi everyone, I'm Ayush. I'm one of the co-founder and CEO of Huddle01. Huddle01 is DePIN for RTC, which is real-time communication. We are a people-powered communication network, which means that instead of using, for all the audio and video calls, which happens in the entire planet, instead of using cloud providers for that, you can use your own compute and bandwidth of your own laptop to basically power these calls. So essentially think about it like if Zoom is using AWS, they're paying millions of dollars to cloud providers, and major of the costing goes towards the egress cost, which is the data cost. And this can be reduced by 90% if you use Huddle01's network. We have a three-pronged approach, an app layer, which looks like Zoom and Google Meet. We have an SDK layer, which looks like Agora, Twilio, and we have a network layer, which is essentially the people-powered network, which means you can just use it with your own laptop at your own home itself. So yeah, we have a two-sided marketplace, a demand side, which is the app and the SDK layer, and the supply side, which is the network layer. Yeah, great to be here.
Excellent. Well, we've got good handle. That's terrific diversity of DePIN projects here. We're going to this challenge, and the topic is what are the challenges in DePIN? And I think there's some that are common to everybody here, and there's also ones specific to each project. And so I guess the first one I'll talk about I think is probably one of the more important ones, which is kind of network effects. And all DePIN projects, I think, kind of rely one degree or another on network effects because you need infrastructure, you need users that both have to play and work off each other. So let's talk about the difficulty and then the opportunities of kind of kickstarting and scaling to make the network effects less challenging. Hugo.
Yeah, I mean, I think you probably have to, I sort of go back to the 2000s when the internet came along and everyone came up with a terrible business idea, but thought if they put .com at the end of it, it would be successful. And obviously, most of them weren't. And I think that likewise, just because you're creating a DePIN project, you actually have to make sure the fundamentals are are there to actually make it a business that works. And so you need to be looking at the sort of the demand side. I mean, you can get supply side working, but you need to make sure the demand side is actually there, and actually the profit that is going to be delivered by that demand side is actually going to make it a profitable business. So I think that it's important to make sure that you look at the business and the fundamentals of it before just sort of jumping into it and saying this is going to work because it's got DePIN sort of related to it, basically.
Anybody else, Jen?
Yeah, I'd echo that. It's been interesting over the last several months, just feeling there's a Cambrian explosion of people realizing they have idle GPUs that could be put to work somewhere, but for what purpose is not super clear. So I totally agree with you. At LivePure, we are very focused on video as a use case and really trying to understand what are the compute pipelines around video workflows specifically. And I think I was going to talk about opportunities, but I know that's not this question, so I can.
No, you can.
I think in a in the Web3 context where we are seeing an emergence of specialized compute networks. You have storage, you have transcoding, you have other types of processing. I think that's where we have an opportunity to collaborate to ensure that we are leveraging network effects for end users who probably want at the end of the day a nice packaged software that is going to serve all of their needs.
Yeah, just adding on to what I think Hugo and Shan mentioned, supply side bootstrapping, which is that you can have these GPUs lying around and you can just make sure that you have a interesting token dynamics, which means that anyone can just spin off and can you have a 10,000 node supply all across. I think that's comparatively easier with the cryptoeconomics, which is out there. But now coming the question of the network effects on the demand side bootstrapping, that's where you have to basically make sure that you build your own demand yourself before making sure that others build on top of you. So what we did at Huddle 01 essentially was also we made sure that we build our own app layer, and which is like very similar to how Zoom works, but in a completely Web3 native manner. We got a lot of feedbacks. We got a lot of people that, hey, why should we use this and all those things. But these kind of active feedbacks from market made sure that you get a very good feedback on what actually works. And then you can make sure that you can participate in hackathons, make sure people build on top of you, and that's how you essentially start getting this network effects on your demand side. So I think it's very important that you do demand side bootstrapping, which is not just on incentive layer, but also based on inherent market validated research.
It's called the Elon Musk Starlink model as well, right?
Yeah, absolutely.
And for those of you who don't know, he had excess capacity in the rockets going to space, so he said, why don't I throw my own satellites up there? And what do? Let's make a communication network. And that's kind of one of the ways Starlink happened, was Elon doing exactly that because he had the excess capacity. So I call that cheating. Evgeny.
Yeah, just a quick comment on network effects. I think we all in crypto here, right? And crypto is actually a great way to achieve network effects on the demand side. Like you just, with the tokens, with all the token economics, like, if you do it right, then like people really start spreading the word about it. And your basically community starts growing, and that's free. Like issuing token is free, and it's regardless of DePIN or not DePIN. It's like works for crypto, and I think for DePIN, what is kind of relevant is there is like AI use case, right? So biggest AI models require huge capacity of computational power, like GPUs and stuff, right? And that basically means that if you don't have the huge amount of capacity, you cannot really train big models, and people not gonna use this infrastructure compared to centralized infrastructure which has this big power. So like the the volume of the supply side in terms of computational power makes a lot of sense. It makes a big difference for DePIN networks if we want to address AI use cases.
You know, Evgeny started that with what my answer would have been, which is effectively marketing. And marketing is a way you can, if you can't build your own demand, then you better be sure you know how to market and create a network effect. And the coin is a terrific marketing tool because it's wrapped up with economics, which are always compelling. The other risk, I think, we're going to go through a list here that I have. The next one is technological. And so this is technological risk both in terms of hardware for DePIN networks, right? Like each of these networks require different hardware and different software, right? And I think that software, we can confidently say us collectively know how to handle and to build and to fix, but I'm not as convinced that this group, sort of ETH Denver crypto world, is as comfortable in the hardware space. And so I'd like to hear people kind of talking about any hardware dependency that you have or you think is a challenge for, you know, different elements of DePIN. Some have zero hardware risk, others are, you know, think of Helium, think of others that are like super hardware intensive, whether it's the design, whether it's the size, whether it's the cost, all of that. So anyone want to take that?
I think NVIDIA's the elephant in the room here. Like, where do we all get our hardware from?
Well, it depends what
NVIDIA.
kind of hardware. If you're talking CPUs, it's not NVIDIA.
Well, are we talking, I guess, yeah, what hardware are we talking about?
This is just DePIN, so it could be any type of hardware.
It's most likely GPUs.
No, Helium doesn't use GPUs. HiveMapper doesn't use GPUs.
If we're talking about AI, it's GPUs.
But this is DePIN overall.
Okay, well, we didn't define DePIN, so.
Well, DePIN is decentralized infrastructure networks, right? So physical infrastructure. Physical infrastructure could be cars, could be microwave ovens. So anyway, NVIDIA is critical in the GPU market, obviously, and that is definitely a centralization risk. But my point is, different elements of DePIN are dependent on different elements or different hardware complexities, depending on what it is.
I just think like NVIDIA's a full stack data, compute, hardware, software, infrastructure provider, and I think that's, you know, the reason why they've been able to build that mode is because they've also developed software that is what accelerates hardware. So I just think like it's important for us in the Web3 space to look realistically at like what it takes to disrupt, what it takes to leverage hardware in the first instance. And I just don't know yet that we're at that stage of being able to provide enterprise-grade software that NVIDIA's been able to deliver so that people can access, yes, GPU hardware, but also form the partnerships with other industry players to provide the other networking physical infrastructure as well.
That's what we're trying to do. We'll see how successful we are. Hugo.
Yeah, so I mean, that's one of the things that we've been approaching from our side as a layer one blockchain is in terms of we're a software download, so we are completely device agnostic. So we can go on to mobile phones, we can go on to EV charging stations, we can go on to chip eventually. And so effectively, we're hoping to sort of take away the need for specific hardware and just allow people to use the devices or the equipment that they actually have already. And so, you know, one example is, you know, I guess we call it sort of, in many ways, sort of enterprise DePIN, is that within the automotive vertical, there's not enough EV charging stations to deliver the demand required. So effectively, they have absolutely got demand because all these electric vehicles are coming on board, but actually the public charging stations aren't able to cope with that. So we're working with OEMs in Europe. They're looking to expand out the network of charging by allowing private wallbox owners to actually rent out their own private wallbox to other users. So effectively, sort of a DePIN, but from an enterprise perspective, they're actually trying to expand the network of EV charging, and they can do that because we can basically put nodes into vehicles that then can talk to nodes in the EV charging wallboxes as well, basically. So that's like a sort of step change. You don't have to buy specific hardware. I mean, obviously you buy the wall box, but the wall box comes ready loaded with a blockchain solution inside it.
So is the wall box purchased by people in your network wanting to get rewarded, or do they already have it and then just install your software? How does that operate?
So the methodology is that if you buy an electric car, you want to be able to charge it at home. So effectively, in order to incentivize people to actually invest in buying a wall box, they're saying not only can you use it to charge your car up, but you can also bring on board, like Airbnb, you can actually rent it out to other people so that when you're not using it, you can bring other people on board and they can actually come and park in your driveway and then use it as well. So it's an extra income stream. So effectively, it totally takes out the sort of upfront cost of buying your own wall box. You can actually make money from it as well.
Gotcha. Go ahead.
Yeah, I think answering this question, I think it's hard because of the NVIDIA point. I think we all saw that shareholder, the quarterly earnings report in which they smashed $18 billion NVIDIA in terms of just data centers. So if you're trying to compete on the compute angle, I know that it's becoming difficult day by day because and there are LPUs now where Grok is trying to do something where you need to have this different kind of hardwares which are trying to compete in a way which is a bit differentiated than what NVIDIA does. But my point is on the point where you don't require compute but require something like bandwidth. So if you require bandwidth, that is something which your mobile phone can also do right now. So how can you essentially, the DePINs, how can you create this network which doesn't just depend on compute, but barring the compute, other kind of networks. I think Demo is trying to do something, WeatherXM trying to do something in terms of the weather. I think these are the networks where you can actually compete with the current centralized monolith architectures out there. For us, it was bandwidth. Everybody has 500 Mbps to 1 Gbps of uplink and downlink. That means you can essentially do anything what a data center in AWS can do, and you can just snatch out. And just for instance, AWS charges what they pay to ISP, they charge 80x to that to a customer. So that's an 80x multiple, which just because they have a monopoly there. So that's where we are attacking the market, where we're saying that, hey, you know what? Why do you have to pay an 80x multiple to AWS? You use this network, which is you have a free internet at your own home, and you can use that, and you don't need to pay for bandwidth. I think moving forward, in terms of these kind of hardwares, you can make sure that if you have an FPGA inside your own device, you have to have these kind of staking and slashing mechanisms to make sure that at least they are behaving in a very, not behaving in a rogue manner. I think that's where crypto economics comes into picture. But yeah, I think barring the compute, because of the elephant in the room, there are a couple of other angles where you can actually create dent in various different manners, WeatherXM being an example, Spheron trying to do something as an example, Fluent what they're trying to do is an example on that, and what we're trying to do in bandwidth is kind of example. So I think in different areas of vectors, you can try to attack and create a good go-to-market motion.
So the internet rewards scale, and that's why we see the growth of Amazon, Google, the hyperscalers. They're the ones that dominate hosting, dominate kind of the web in many ways. You would think, what is the panel's perspective on whether that scale benefit is equal for DePIN networks? Will we have a DePIN network, a fragmented DePIN world with a variety of different DePIN networks in each vertical, or will we have one? Will there be one storage provider? Will that work? Will there be 10? Will there be 3? Like, how do people think about, will you have competitors? Will you have competitors? How do you guys think? At Fluence, on the CPU network, everyone is competing in the GPU network. We will certainly have competitors in the CPU market, but fast forward that, will scale and ease of use lead to one? Is that what we're going to head to, just like we did in the internet? And kind of curious what people think of in that context. Evgeny.
I think it's all the same all the time. It's kind of like Web 2 problem of creating these monopolies. So basically, like every company that grows, trying to lock in customers and do not allow them to go anywhere outside or like use easily some other services. So they basically break the interoperability, right? Then in Web 3, we've got layer 1s, and every layer 1 wants to be its own universe. It wants to get all the smart contract developers into this ecosystem, and ideally, so they do not really go to other ecosystems. But because Web 3 has this interoperability sort of spirit and like assumption built in, it's actually like a little different from what we had in Web 2. So I think like in DePIN networks is gonna be closer to the landscape of L1s and L2s, like blockchains. So every network would try to keep customers inside, but still would be able to, have some sort of interoperability. Like, because we at the same time, like, we want our network to be big and popular, right? So that's why we need to keep customers. But at the same time, we want to use, again, Web3 way of marketing and adoption. We are partnering and integrating with like other networks and basically make customers to like easily transfer between networks and benefit, like make it beneficial for both.
Any other comments on this?
I'd agree with that. And I think open source kind of culture and principles like core to Web3 as much as crypto economics is. And I agree. Technology partnerships become really critical. And I think that, events like this are really good opportunities to make sure that we are staying in touch. And, the opportunity to extract value around specialized compute use case or specialized DePIN use cases, the size of the market is just really huge. And as long as I think we approach the market with an understanding of, we can probably package up something for this one use case together that makes a lot of sense, and that at the end of the day is really cost competitive and cost disruptive. I think that's what's going to win over people in the market. We've seen that with storage and video. Video and storage go hand in hand. LivePeer is not a storage compute network. We've had a lot of success with partners like Storj to deliver enterprise software that is, up to 90% cheaper than traditional cloud providers. So I think the more we can have good success stories of technology partnerships, that will be really helpful.
And yeah, I think it will come down to usability and also cost as well, because as Evgeny says, because it's open source, then actually the interoperability is there now, is sort of inbuilt in Web3. So it won't be that you'll be able to create a huge moat around your solution. So it will come down to usability for people and then also the margins that people are seeing there, basically. So it will create a very competitive and hopefully sort of user-centric solution.
Yeah, I mean, I guess the way I answer that is you should have competition, and with low switching costs, you should get to the best solution quickly, but that also means people can switch, but still reward scale. So I still think you see dominant players in these DePIN verticals. Another potential risk, and curious if anyone here has dealt with this, regulatory. Any regulatory challenges on the horizon for anyone here, or anyone want to touch on that?
I think one thing for us is to make sure that, for example, it's audio and video. You have to make sure that there are things like data fencing to make sure that your data doesn't go out of this region. That means if you're doing an audio and video call, which is happening in India, there are regulations which are passed in various kind of governments which make sure that your data should belong in this area. This is the same which happens with storage as well. A lot of this is same which actually happens in China a lot. That's why there is Alibaba Cloud, and AWS also has a different charging there. So I think that's one of the verticals where we are also trying to basically make sure that how does our node operators get all these demands, which is already happening in Indian region if the client is on the Indian side. So yeah, that's one of the things which you need to keep in mind when you are dealing with nation states and to understand their regulatory vertical. So yeah, that's one thing which I would like to share there.
Yeah, I mean, one of the things that we're finding with sort of our more enterprise clients are looking at, especially in Europe, GDPR. So the ability for people to be forgotten online digitally. So obviously, blockchain is inherent contradiction with that, because obviously it has a public ledger and everything's immutable in terms of the data. One of the ways that we've been approaching this is effectively, in order to be able to run a full node on a mobile device, it has to be very lean and compact. So effectively, everyone keeps their own data rather than keeping everyone else's data. So that means that each device, each car has that data, only keeps the car on that data itself. So effectively, you're complying with GDPR in that respect. Another area is looking at sort of income from renting out a Wallbox as well, because that is actually income, because people think, okay, it's just easy money, but actually they then have to start doing taxes on it and everything like that as well. So, everything has a knock-on effect that you don't really think about in the sort of the concepting of it. But then when actually it becomes sort of proper money being transacted, then that is something that also has to be sort of taken into account as well.
Right. I mean, what I think you're talking about also is there's the DePIN network regulation issue. You have to worry about data availability or lack thereof, and transmission and spreading or lack thereof. But then if there's a token involved and token economics involved, that leads to another sort of layer of regulatory concerns that also primarily driven by the US, but also global, which create another kind of regulatory risk that I think is still a big, big concern out there for a lot of people.
Yeah, I mean, the challenge again is you know, over different jurisdictions. So I mean, the beauty about crypto is it travels, it's borderless, but then it gets very complicated into terms of different jurisdictions, how that's then sort of captured and how it's then dealt with, basically. So again, that is definitely an evolution that hasn't been sort of finalized yet.
Right, and if we think about that some more, the regulatory risk can impact token prices impact rewards impact profitability. So how do you guys think about profitability for your networks or networks overall, and the durability of that, given kind of some of the risks both we talked about earlier on some of the technological side, but also on the top-down regulatory side?
Well, I mean, I think it comes back down to you need to look at the business model to make sure that the profit margins are there. I mean, obviously, you'll have good periods and bad periods. That you make sure that as a sort of an offering, you can actually sort of weather those ups and downs. So I think that it isn't, it's not easy money in most cases. So it is something that you would have to definitely look at from a business model perspective. So you have enough fat in there in terms of making that work, basically.
Yeah, just thinking about live peer, I mean, our node operators get rewarded through inflationary live peer token, but they also get rewarded in ETH for fees paid on the network. So every time a broadcaster on the network needs transcoding, they pay for that in ETH, and we'll see other payment currencies being accepted over time. So I think that's one way we've kind of thought about just diversifying ways people can make those profit calculations for themselves. I think on the, the pricing and regulatory risk on the token, it's always hard. I think, regulators, I used to be a regulator. I was in Canada's financial department regulating Bitcoin as a financial crime many years ago. No one knows what DePIN is today. People are just starting to understand DeFi. Helping regulators understand that, in Web3 infrastructure projects, we now call them DePIN, the people contributing to that actually do own physical assets, and you can't treat those assets the same way that you treat capital gains or other investment assets. So I think we need to really educate regulators that these are different tokens. They're not speculative, they're actual utility tokens, and that can help over time, decrease that risk.
And the other element there, which I think is also important for regulators, is the communities around each of the projects that are voters. And so hopefully the more we scale, the more communities are involved that can exert some appropriate pressure as well. One other question for you. On the payment on ETH, is that dollar denominated or is it ETH denominated? i.e. they pay for something, it costs X dollars, but I'm settling it in ETH, or is it just an ETH payment?
That's a live issue.
Okay, fair
right
enough.
Now.
Okay, it makes a big difference, obviously.
No,
given
but
where
there is some volatility that we know is there that we're working to remove.
Fair enough.
Yeah, I think just circling back to the point which I think Hugo mentioned regarding what's your business model. So if you just see the gross revenue margin which data centers have in general, because it's public of NVIDIA, it's 74.8%, which is their gross margin, which they have. So I think considering that now networks are basically becoming more people powered, you have a lot of, and if you use these different kind of cloud bare metals like Cherry servers and all the others, you see that the margins which you can make here is enormous. So even after the regulatory hurdles, the margin is so high that if you have a decent business model, you'll be able to crack a very, very good, substantial, sustainable economy out of it. I think a lot of projects are doing that. I think Filecoin is a live example of that part as well. So.
Yeah, and I'd argue that's also possible because of the global market for tokens, which gives a huge, buying power to create that scale that allows these to happen, right? So you have a global market of capital allocated and interested in believing in these projects, or just thinking it's going to go up. But that is what funds all of this, which is terrific. And we've done this, 10 years ago wouldn't be the case. We're running out of time, so we got one more question. Either a risk that you think we haven't discussed that's worth articulating, given that's the name of the panel, or you could talk about an opportunity that we may not have addressed. It might be easier, but this is a risk panel. Evgeny.
Yeah, I think one of the big risks of all the DePIN is, illegal content and all this like content regulation stuff and privacy, because we are kind of trying to decentralize stuff. We want to allow anyone to participate and like exchange data, whatever. But then, 20 years ago there was a time when BitTorrent appeared and all this regulation wars around illegal content in torrents. Which basically killed the torrents for like public use. They are kind of illegal in most of the world, and we need to design our protocols carefully, the way that we do not like really make some big guys angry about usage of the content or about like data exposure. So I think that's kind of like technical questions that we really need to think carefully about.
I think another risk is sort of not finding enough demand because it's too complicated for normal users. Obviously, we're in Web3, but we're quite a small microcosm, really. And actually, if you want to get to the scale everyone talks about, next billion users and everything like that, it needs to be something that is very, very simple and very straightforward, and is, I think comes back down to utility. And so the ones that succeed will be the ones that are actually delivering a really genuine utility, and they get paid for it as well, rather than purely doing it for the financial gain.
The point I guess you're making, which is terrific, is that if it's not simple, it's not going to work, and everyone's on the clock.
Exactly.
I think there's a risk of not innovating enough in the space as well, even as we think about what demand to go after. We all know that the market for enterprise customers is large, and I think there is a good case to be made for go-to-market strategies that seek to capture that. But I'm not in this space because I just want to sell a nice SaaS product to a really large corporation. I actually also want to be part of building an entirely new generation of internet applications, and I think continuing to be part of the Web3 ecosystem to help developers, front-end developers, creators, designers imagine new internet experiences. If we lose sight of that, I think we're probably not going to win.
Yeah, I think for me it's demand-side bootstrapping. That means I think we have to do much more on the product innovation side. We need to have very fine product designers enter the ecosystem, make sure that it's very, very good quality products out there. And I think we have, in terms of mechanism design, in terms of crypto economics, we have become very efficient to understand how the staking rewards should work, how should our inflation rate should work. But I think what we still struggle on is, this my personal opinion, is on the making the product very fine to make sure that there's not a differentiation between is it a Web2 product or Web3 product. And if you have a very good demand happening on your product layer, I think regulations is always something which you will always be faster than the regulations in that front. And I think over time, that's a problem to worry about once you have enough, basically you get enough attention from those big corps or the nation states in general. I think that's where product side bootstrap.
Yeah, but that's actually the problem, where if you are small and you fail, you don't have any regulatory risk. Great job. Right? So none of us are playing for that. Everyone wants to play to be big, and that's why you have to worry about the regulatory implications, because everybody expects to get there. So I hear that risk. And the one risk not mentioned, but I think it's important, and we're actually going to talk about it in a little bit, is governance. Right? And so what governance do these DePIN projects have, and what risks do those governance kind of mechanisms and structures either have or alleviate based on other stuff we've talked about? So that's one other thing I'll just sort of leave for the next. But let's give the panel a round of applause, please. Thanks, everybody. We're going to move into the main attraction, the Fluence launch. Keep in mind, we've got a couple of great panels, starting with me, who is going to do a keynote. And then we're going to go on to Kyle Samani, Fireside Chat, Juan, and Evgeny's going to explain how the whole thing works. But importantly, we have drinks. But the only people who get drinks are people who leave here with a wristband. So you've got to be in the room, and Nadia has the wristband. So if you're in the outer room, you're out of luck unless you come in here soon. So give the panel one more round of applause, and we'll get started. Thank you.
Thanks, everyone.
The video. Yeah. Ready to go? We're going to kill the lights. All right. Yep, we're killing the lights. This is the video. Everyone sit down. Here we go. Okay, stop talking. Sit down.
The internet has helped the world advance dramatically. But where are we going? A few big companies owning it all, making huge profits, not allowing interoperability between their closed ecosystems, stifling innovation, controlling what we see, how we transact, what we can do. This was not the original vision of the internet. Can we unlock more value and more innovation? How? We can't have a few companies controlling it all. We need to unlock competition to lower prices, add transparency, allow every user to have full control, make interoperability the default. What is missing to do this? We have decentralized payments and decentralized storage, but we miss the critical piece, decentralized compute, the actual work that powers all of the applications and the internet, the calculations that find the best route for your Uber, that complete your LinkedIn search, that recommend you photos on Pinterest, that query an AI model. And without decentralized compute, we are stuck in the cloud. We need something better. We need a cloudless computing platform. We call it cloudless because it is not built on top of the big cloud computing platforms, but instead creates a new, open, global network that is truly decentralized. What does truly decentralized mean? The network is global, always on, and self-healing from downtime and interruptions, and isn't controlled by any one entity. But the cloudless platform is more. It also is secure, no single point of failure, distributed, no single point of censorship, cheaper, up to 80% less, verifiable, receive proof that your compute was performed, and it even is green. Users can pick to use only green energy. How does it work? Compute providers in top-tier data centers all over the world contribute their excess capacity to the Fluence network, which collectively serve as a global always-on DePIN platform. The protocol rewards providers with Fluence tokens for every server added, and the more servers on the network, the greater the competition and the lower the price of compute. On top of the server marketplace, the Fluence protocol provides provability. Every single function execution, every result is cryptographically signed and attested by the protocol, making applications tamper-proof, auditable, and verifiable. And for every application, the FLT token is staked and locked with compute providers, which guarantee that applications run correctly. If not, their tokens will be lost. Security grows with more tokens staked and more applications deployed on Fluence. How will Fluence help us move forward? Cloudless compute will change how applications are built and how they run. We can have AI models provably use certain data sets, and we can prove the AI model wasn't manipulated. And we can have AI models that run fully decentralized with no owner subject to influence. And all of Web3 is running on centralized compute. Infura even runs on AWS. Both Fluence, they can be fully decentralized. But Fluence isn't just for Web3. Low cost and audible compute will change much more. Biotech companies doing highly intensive analysis on test data. Researchers studying vast climate data sets. Companies needing to prove to regulators that calculations were performed. The uses are endless, and the uses will help us all move forward. Think bigger, think open, transparent, cloudless, think Fluence.
Great, thank you. Thrilled to be here for the Fluence launch. If you haven't picked up already, my name is Tom Trowbridge. That means you haven't been in this room because I've been on this stage a lot. So, co-founder of Fluence. and thrilled to be here. Fluence is a cloudless compute platform. And I'm going to explain what that means shortly. Let's see if this is connected. Those screens should be on. What I want to do first is thank our investors. And so we have some of them right here. Blockchain is right here. I know 1KX was around, and there's a couple of others who are here. So first, a big thank you. We've raised 15 million from them over time, and there's what basically enabled this to happen and allowed the building of this platform. So big thank you to our investors. So why do we need cloudless compute? This is why we need it. I don't know, hopefully everyone here knows what this image is, but maybe not. This is an image generated by Google Gemini about a week ago. This is the Google's image generation AI. And they've basically manipulated the algorithm to make it as diverse as possible. And so when someone put in a request for 1943 German soldier, you get this absurd image of a diverse, Nazi army, which is both offensive and also massively historically incorrect and wrong in basically every possible dimension. And this is what happens when you have corporate centralized AI. The AI is manipulated to solve for certain goals, and it's manipulated behind the scenes in ways you do not know. You don't know when you're putting your words in there what the manipulation is until you get the text. Now, luckily for us, it's so absurd and so clumsy, we can tell exactly what it is and what the agenda is. But, you can tell Mark Andreessen has been very vocal about this, and his point is tech AI and censorship is only going to get worse. It's bad now, 2 years will be worse, 2 years later it'll be worse, and 2 years later it'll be worse after that. And that's why we need cloudless compute, because we should have open, decentralized AI. That will be more trusted ultimately. You want to have AI which is trained on data verifiably, it's provably. You want to prove the queries were executed with no manipulation, and you want to be able to run decentralized. You want to run decentralized because otherwise you're subject to manipulation by and pressure from shareholders, from management, from employees, from regulators, from politicians, from Twitter bot armies. So cloudless compute is required. Now, what is cloudless compute? It's true decentralized compute, and that means it's got to be fault tolerant and verifiable. And fault tolerant means that if something goes down, if a server goes down, if a data center goes down, the compute automatically moves to the next provider. It moves seamlessly. And it's got to be verifiable, meaning you can verify and validate that your computations were performed. So you end up with a network that's global, always on, and self-healing from downtime, and isn't controlled by any entity. That's cloudless compute. Let's take a second on why you want it. You want it because it's secure, no single point of failure, distributed, no point of censorship. It's cheaper, up to 80% less. And I'm going to get into a little bit more detail as to why that is the case. And it's verifiable. We've talked about that already. And it's green. And this is interesting because it's a global network. You have a variety of criteria you can choose. And so you can choose to have your compute only run green if you so choose, which means it only will run or only select data centers that are fully renewable. So that I think is something obviously the centralized cloud with AWS doesn't offer. And who is it running on? Well, this is the list of partners that are with the Fluence launch and our early data center partners. We're partnering with data centers that are kind of top tier around the world. This represents Australia, New Zealand, India, US, Canada, and Europe as well. And some of these data centers we visited some of them in the US. These are same centers that are running compute for Netflix, for Facebook, et cetera. So top tier centers. And Fluence right now, there's interest in having 4,000 servers with over 200,000 cores to deploy on Fluence. Now, we're not deploying all those right away. We'll deploy those over time and scale it up. But that's the level we're talking about. And on top of this, every day we have more inbound interest of individuals, big companies and small companies interested in having their compute join our network. So this is a terrific, top-notch starting place, and we're going to scale to be fully permissionless on this in the next several months. Let's talk about what isn't cloudless, though. What isn't cloudless is just a marketplace of compute, all right? And there's a lot of marketplaces of compute out there. But guess what? I can look on my desktop or my laptop and choose a provider. That does not make it decentralized, all right? You need to have resiliency, which means that if you choose something and it goes down, it goes automatically to the next one without reprovisioning. Otherwise, it's not really a network. It's just you choosing a provider. That doesn't count. And you also need verifiability, but finally, you need cloud services. And what do cloud services mean? Because that's a very important point. The hardware marketplace is important, but hardware is not where the value really is. I think most people here everyone's here is in software. We kind of know the value is in software. And so pure hardware marketplace isn't where value is. It comes from all the services built on top. AWS is successful not because it has a lot of data centers, but because it's built a stack of usable software on top of it that people use. And so we are very cognizant of that and have built a stack of software on top of our marketplace as well that mimics that cloud marketplace and that allows the composition and creation of natively distributed applications from the beginning. And I think it's the first one to do that. It covers the composition and execution of decentralized applications. And that is very important. Otherwise, you're just a hardware marketplace, and I don't think that's very interesting. So what then are the benefits if you have both this decentralized marketplace and you have this stack of software on top of it? We've talked about verifiability. We've talked about censorship resistant, but we haven't talked about the low cost, really, and the buildable. So low cost, why is it so much cheaper? And it's cheaper because when you have no switching costs, then there is no benefit, there's no leverage on the part of the compute provider. If someone raises prices, you can switch out easily. Someone joins the network with lower prices, you switch to them quickly. And so you've actually commoditized compute. And that is a big thing to be able to do. But to do that, you have to have the resiliency. You have to be confident that you can switch with no cost and no latency. So that low cost means that the compute providers aren't going to be making high margins here. The margins here are way smaller than what they currently earn, but as long as they are using compute and that they're not otherwise deploying, as long as they're covering the cost of electricity, that's a net benefit to them, and they don't care. The other point is Fluence is offering serverless compute. That is an offering that's more complex than just renting hardware, and data centers can't offer that either. So there's a new product they're offering, and new customers coming to them for a price that is lower maybe than their traditional customers, but is fulfilling demand they don't otherwise have. That is where we get low cost. That's why it's sustainable, and that's why this will be far lower than any centralized cloud cost. And buildable. This is also important. As you run, because it's a decentralized network, you can build on an application, you can build on a module, and as long as any computer anywhere in the world has demand to serve that, it still exists. So I can build an application, and the pieces I use can be subject to 10 upgrades, but I'm not forced into those upgrades. If I build an Amazon, if I build somewhere else, I got to keep upgrading, keep that upgrade cycle going. Things might break, I've got to reintegrate, et cetera. Here, I build on something, and as long as I keep paying the provider that's hosting it, it keeps running, right? So I can build with confidence and not be subject to kind of the forced upgrade cycles that so many software companies go through. So let's talk about some uses. We've talked about AI, and I think just to go a little bit more into detail on this, you want to verify that data, that the compute was trained, that the AI was trained on particular data. You may have seen the New York Times sued OpenAI, ChatGPT, claiming their data was used in that in training that model. So we think that most models going forward are going to want to be able to prove what data they were trained on. And that is something that you don't need a GPU to do that. That's data pipeline. That can be trained on CPUs. Also, you want to be run decentralized. Again, running the model and running the queries is a CPU job, not necessarily a GPU job, which is important, is what we do. And you also want to make sure it's auditable. You want to have auditable compute here so you can prove that the query was executed and was done without any manipulation. Also really, really vital. And so beyond AI though, what are other use cases? Well, there's all of Web3. And if we think of Web3, first obviously there's DeFi. DeFi is fully decentralized. We're not going to even debate that. But outside of DeFi, everything is running on the cloud. And it's nobody's fault. It's just that there hasn't been any viable alternatives. And Infura is a perfect example. It's running on AWS. But now there's an ability to decentralize that. And we're going to see more and more and more critical components of Web3 decentralized. Nobody wants to be centralized, but there haven't been easy ways to do that historically. And that is now changing. And I think we all recognize with the the kind of regulatory environment, the risks we all are running by having AWS kind of out there subject to influence by regulators. And I think that is something that we want to get out of the way of as quickly as we can. But beyond Web3, there is the serverless market, right? And serverless market's $9 billion right now, which is big, but that's growing to $55 billion by 2030. What is serverless? You want episodic, price-sensitive compute. That's really what it is. And some examples of that, which you heard in the video, are pharma analysis, where you're doing long, intensive data, but it's not really time-sensitive, so it's price-sensitive. That's perfect for a far lower-cost solution like Fluence. You also, machines like cars, huge amounts of data generated and want to be processed at the edge. Also a perfect serverless opportunity. And sports, you have massive, more and more data generated, whether it's F1, whether it's football matches, whatever it is, more and more data is generated, and that needs to be analyzed and completed at that time very quickly, and then there's no need for that data or no need for analyzing for some more period after that. So this is what serverless is for, and this is what Fluence can do very well, and that's how big we think this can go. And that's why we think that Fluence and serverless, cloudless, is the next generation of the internet. We started off with mainframes and desktops. That moved to the cloud, and that was a long transition. The cloud is still growing. It's still growing significantly. But cloudless, the basically commoditization of compute, is that next generation. And that is probably the final generation where compute is commoditized and is easy and open for everybody to use and for everybody to build on. And by the way, I'm not saying the cloud goes away. It doesn't. But this becomes a viable alternative to the cloud and a viable alternative on which all of these DePIN projects we've been talking about can also run on with confidence without having to rely on AWS. And how do you govern a network like this? Well, we haven't talked much about governance today, but a network like this should be governed in a decentralized way as well. It doesn't make sense to have a decentralized network that's governed as a company, right? All of a sudden, there's a massive disconnect. So this should be governed by a DAO. And so from the beginning, Fluence needs to be governed by a DAO. And we'll be talking about that later. So how do we think about this in sort of the bigger picture context of the world? Well, we think open platforms, obviously inspire innovation, and they also capture value. And we've seen this happen with Ethereum. Ethereum has a lot of uses. DeFi is a terrific one and probably probably the largest for Ethereum. And so it's to some extent a open banking alternative, and that continues to grow. It's worth a massive amount, 400 billion, and the global banking world is 14 trillion. We view Fluence in the same context, but as an alternative to the cloud. And so the cloud market is over 600 billion right now, growing dramatically to the multi-trillions. And an open, cloudless platform should also be generate and capture a lot of value. But where does that value go? The value doesn't go to shareholders. It doesn't go to it goes to users, and it goes to, if you're architected correctly, to token coin holders who are both validators, users, and in the community. And so that's where this value goes. That's where the Ethereum value has gone, right? It's going to the people who've built, believed in, and contributed to Ethereum. That's what we think will happen with Fluence as well. So what is our mission? We want to empower the next wave of internet innovation. And I want to, basically end with a quote from Tim Berners-Lee, who created the HTTP protocol on which the entire web that we know has been built. And TBL, as you know, did not know, couldn't imagine Uber, couldn't imagine Google Maps, couldn't have imagined the things that created, that the HTTP protocol inspired. But he knew that if he created a platform like this, innovation would follow. And similarly at Fluence, we feel that if we create a cloudless platform where there's no switching costs, with open compute that is inexpensive, verifiable, that will inspire a terrific amount of innovation as well. And that's what our mission is we want to inspire this innovation and drive forward the next phase of the internet. So with that, I thank you, and we'll be on, and appreciate your time. Thank you. So I'm thrilled to have Kyle Samani join me on stage. Kyle, how are you? How are you? Good, good, good. Grab a mic. Yeah, let's do this. No, I need my papers. They're in there. So listen, known Kyle for a long time. We met back in 2017. And, for those of you, if you don't know Kyle, you're in the wrong room, I think. If you haven't heard of Multicoin, you're probably at the wrong conference. But Kyle Samani is managing partner of Multicoin. Multicoin is a multi-billion-dollar investment firm in the space. He has been early in a whole number of projects, DePIN being one. And I was thrilled that he led the Fluence Labs Series A. So appreciate that. Thank you, Kyle. And I wanted to talk to Kyle about DePIN today and also about Fluence. But first, let's talk about DePIN a little bit, because you've been early in a number of sectors. You've been early here. You were in DePIN before it was DePIN. So can you talk about some of the early investments you made and kind of how you think about them?
Yeah. Good afternoon, everyone. My name is Kyle, co-founder at Multicoin. Honored to have the chance to back Tom, you, and Evgeny, and the rest of the Fluence team a couple years ago. And it's exciting to be here at Denver at DePIN Day on the day of Fluence's token launch. Is the FLT token live yet?
Yes, it is. We haven't talked about that yet, but it's coming soon. Coming soon.
Sorry. Whoops. Okay. So, DePIN. So, we were super fortunate to have a chance to invest in Helium 2019, and I think today that's kind of one of the leading teams in DePIN, especially physical side. There's a few teams who are focusing on DVIN, or virtual infrastructure networks, a little earlier, like LivePeer, Filecoin, some others. We had a chance to meet Amir and the Helium team in 2017, and had a chance to lead their Series C in 2019, and then they pivoted to crypto. What really drew us to first to Helium at the time was, Amir said, "Look, man, like I want to build the world's biggest, best telecom network. Doing that's going to take $100 trillion of capital. I don't want to raise $100 trillion of capital, but I want to enable all kinds of random people to build all the network." And that really struck us as just like a huge, huge idea, where you could take all of this traditionally very capitally intensive, top-down, centrally managed processes and basically let the market naturally distribute. If someone lives in a neighborhood and they have poor reception, they should be able to put up a hotspot and make some money. And that really like fundamentally struck us as like the capitalist way to think about the problem, as opposed to now it's actually like the very socialist way, which is like, what do the gods at AT&T headquarters, think, without actually having real world feedback from people on the ground based on where they need coverage. So as we thought more about Helium, we really recognized a huge idea, and we ended up leading that investment in 2019. And then we immediately started looking for other teams kind of implementing the same idea. It took a few years, but as Helium started to take off and they built out a network of over 1 million hotspots, a lot of other people became inspired by the same idea. We led the investment in HiveMapper in 2021 on the same kind of basis. There's a whole bunch of other teams now doing really cool things like Demo, WeatherXM, who the WeatherXM guy was just here. A bunch of other teams building out really cool forms of physical infrastructure around these ideas. Helium and HiveMap are probably the two biggest we've made that are focused on physical infrastructure, and then we've made a whole bunch focused on virtual infrastructure. Teams like Fluence, Graph, Filecoin, LivePeer. I'm sure I'm missing 4 or 5 more, but yeah, we've been very, very active.
And given you've been invested in this space, you guys first heard of it in 2017, a long time ago, invested in 19. We're seeing the rest of the world catching up now, right? So Masari wrote a report just recently, Binance, OKX both wrote their own DePIN reports. What do you think is the kind of catalyst for the rest of the world talking about DePIN now as opposed to later or earlier?
Yeah, I think, I got into crypto in 2016 and launched Multicoin in 2017, and that's when Tom and I first met. And back then, the infrastructure just wasn't ready. L2s that wasn't even a word. Solana didn't exist. Cosmos didn't exist. Filecoin didn't exist. None of these things existed. Even in 2019, when we led our first investment in Helium, the Helium team built their own blockchain, and they ran it until 9 months ago when they migrated to Solana. But the reason they built their own blockchain was the infrastructure didn't exist. They couldn't run on Ethereum or anything else. And so it's really taken, the last 5 or 6 years to get the infrastructure to be mature enough to where entrepreneurs can focus just on, telecom and that part and not worry about the L1 or the L2 or whatever. It's really only been the last kind of couple of years we've been at the point where you can just take that infrastructure for granted. And now that we're at that point, we're seeing this real blossoming of DePIN founders who can say, okay, great, I don't have to think about the payments and the money movements. That all just works. And now they can really focus their energy on go-to-market. I think the other major thing that's really allowed DePIN to start to flourish in the last 12 or so months has been people seeing Helium work, and now seeing, I think the next kind of wave has been this AI GPU compute thing, led by teams like Render and Akash and IONET and a bunch of others. But now that we have kind of 2 different examples, one really being physical infrastructure, telecom, and then the other being virtual infrastructure, looking at the GPU stuff and AI, I think that's now kind of opened up the window of the opportunity set in a lot of people's minds and has inspired a new wave of entrepreneurs to take that model and apply it to different problem spaces.
Excellent. And related to that, I guess Fluence is not current now. We've been around for a little while, and you invested in us a couple of years ago. Talk about a little bit what you saw in Fluence, in the team, in the project that kind of got you interested.
Yeah, so decentralized compute stuff is super, super hard. I mean, in anything in cloud, you've got 3 primitives: storage, compute, bandwidth. Of those, the hardest, in my opinion, to deal with in a permissionless setting is compute because of the verifiability problem. It's super, super hard. And we met a ton of teams starting in 2017-16 timeframe trying to do various compute things. There was a whole wave of early teams like Golem and iExec, and I can't even remember how many others there were. And we were pretty concerned that all of them were being a little bit too generalized in their approach. When I got to dig into Fluence with Evgeny and with Tom, 2 things really stuck out to us. First was building the entire stack from the ground up around the custom Aquamarine language, and recognizing that hey, if you're going to make permissionless compute work in a global network like this, you're going to need to redesign the entire stack from the ground up. Everyone else we saw was like, oh, just take a WASM container and it'll work. And I was like, I don't think this is gonna map over. And so rethinking everything from first principles struck us as very important. And then the second thing that really stood out to us was the focus on kind of Lambda style stateless compute, which again we thought was like, okay, you're not trying to solve all forms of compute in a generalized way. You're saying we're going to take one specific function, in this case, stateless compute, or serverless, or whatever, or now cloudless is the new modern lingo, and focus on that. When we first did LivePeer in 2017, 18, they were like, look, we're just focused on video streaming. And we liked, again, that you could deal with the verification problem in video streaming in clever ways. And we continue to like how the Fluence team has really focused on one kind of function of compute. So those are the two big things that stood out to us.
You know, you've talked about the evolution of the space and now how you have more mature components that allow people to focus just on the sector or just on the problem they're trying to solve, because payments is good and solved. If you talk about compute going forward, do you see a world where the decentralized compute is the default choice for Web3 projects, where you will see, you know, it is no longer, you know, acceptable from a kind of cultural, even economic perspective to run on AWS? Is that something that you see possibility down the road?
Yeah, for sure. I mean, I think most of the kinds of founders who are, you know, building in crypto generally want to use crypto-centric tooling as long as it's reasonably comparable to its Web2 counterparts. Another example I use is HiveMapper, because we're close with the HiveMapper team. They really want to store, you know, they're capturing all of these images from cars driving around, and they really want to store it in a decentralized place. Right now, they're not quite there yet, so they're on S3, but like they've made it very clear that as a function of like the premise of what they do, hey, it's an open public map for the world, the data needs to be stored on a credibly neutral, permissionless backend. I think most of the teams who are building, whether they're front-end applications, DeFi applications, whatever you've got, I think they generally want to use decentralized counterparts where they can. Decentralized components are usually not quite as convenient to use as the Web2 ones just yet, but I think in the next few years that will flip. And then you'll see the entire kind of Web3 ecosystem all using these decentralized components.
Excellent. Let's talk about AI for a second. You know, I mentioned Google Gemini in my talk, and sort of kind of highlights the risks inherent in corporate driven and operated AI models. And you've obviously invested in GPU networks for training models that can be done in a decentralized way, and Fluence can run models on a decentralized way. How do you see the future of decentralized AI? Is it the future? Is it an alternative? Is it lots of models? Is one model? Can you sort of paint a decentralized AI future or lack thereof?
Yeah, so we haven't invested in any teams doing decentralized training. We have in 2 teams focusing on inference, Render and IONet. How do I think AI plays out? You're going to have big proprietary models from OpenAI and Google. Those are going to continue to be leading edge for the foreseeable future, just because the capital and financial capital and human capital requirements are so high. I don't think that's going to change anytime soon. The ability to just pay, you know, those guys are spending $1 billion a year on salaries just for all of the researchers, let alone, people talk about the compute cost, but like they forget about the people part. Those models are very likely to be the top of the line for general purpose reasoning. And you know, OpenAI and Google have both made it very clear they're here to build AGI. Maybe we get to full AGI, maybe we don't, who knows? Assuming we don't get to AGI, then the obvious opportunity is to take LLMs and tune them for all kinds of use cases. Most obviously, coding is clearly different from English language. Japanese boyfriend, girlfriend is clearly different than therapist, et cetera. And so you're obviously going to have these things tuned for these different types of use cases. In that sense, I suspect basically every model that's not attempting to be AGI is going to be open source, because you already have the foundations with Llama, with Mistral, with whatever the other ones are these days. There's enough reasoning in those, and then you can fork it off. And you see this pretty commonly with lots of other open source libraries, where there's a basic foundation, and then lots of teams fork it off to create kind of customized iterations of it. That's almost certainly going to be the case here with models as well.
And with just to follow this one more second on this, on the large ones, given the investment in human capital, which is obviously impossible to replicate at startup level, but if that capital is deployed in a way that makes the models kind of not obvious or sort of suspect, I guess, given some of the manipulation, does that reduce the use, or you think consumers won't care so much because they're still so much better that they're comfortable with, you know, maybe some biases here and there and doesn't really matter?
Generally, I think most consumers won't care. Google obviously has a real big egg on their face from this past weekend, because obviously what they released was stupid. But like, they're going to iterate on it and fix it. I don't think they're that incompetent that they can't fix it. So I think they'll generally get there. Most people consume extremely biased news all day, every day, and they seem pretty happy with it. So I don't, telling people that, oh, they need to have their AI model be like more neutral, I don't think is going to be terribly appealing to folks. I suspect over the next few years, we will probably get more verifiability of what is going into OpenAI's training and Gemini's training. Today, it's 100% black box. We have no idea, other than some very hand-wavy statements that the founders and CEOs make. I suspect that we're never going to get a perfectly granular list of them, of here's all of the domains, and here's all the web pages, and here's all the IPFS CIDs that we use to train it. I don't think we're going to get to that degree of granularity of transparency. But I do think we're within a few years, they'll be able to make fairly reasonable and fairly broad statements that will at least tell you, okay, it was trained on these kinds of things, it wasn't trained on this. Probably there'll be versions, maybe if you want to exclude too left-leaning or too right-leaning, like I can see multiple versions of these things coexisting with reasonable degrees of transparency out of the big AGI teams.
Excellent. Well, that's a more sanguine answer than I might have expected from someone investing in startups, but definitely good to hear. On decentralized compute, whether it's GPU based or CPU, kind of big picture, how do you think of that market size, that market scale down the road?
Infinite. There's a very good Jeff Bezos quote. The effective TAM for AWS is infinite. So I am going to repeat Jeff Bezos.
Excellent. Well, you heard it here. Fluence market size is infinite. There we go. And what about DePIN overall? Is that infinite squared then?
Absolutely. I mean, if you get that, just adding telecom alone on top of AWS, I mean, telecom is $1 trillion of annual spend. So now we have infinite squared.
Excellent. These are going through these questions quickly and with the great answers. And so what about you as a venture capitalist looking at DePIN? Are there areas you see that haven't been filled that you're looking for? How do you think about investing in the next generation of DePIN?
Yeah, I mean, there's definitely certain areas in the physical infrastructure side we're spending a lot of cycles on. I think the area we're most interested in, although it's a very difficult market, is energy. Fairly obvious, but Powerwall, virtual power plants, demand response, all of these ideas have been floating around for quite some time. No one has cracked it. Obviously, it's going to be inherently regional. Texas is very different than New York, which is very different than Germany. So you're gonna have lots of regional players in that kind of a thing working on it, but we really want to make some plays in energy. We haven't made any yet. We definitely want to. Another really interesting area for physical infrastructure networks that we have looked at but we haven't done is third-party logistics. So think like Amazon warehouses kind of a thing. There's an idea that we've seen it floating around with a handful of entrepreneurs for like, hey, you live in a neighborhood, think like traditional suburbia neighborhood. You have a garage that's empty. Can you turn your garage into a warehouse and store? Can you have enough small-scale robots at a low enough price point with enough, computer vision and whatever else that you can basically get real estate storage for free in someone's garage and do last-mile delivery that way? Really, really crazy idea. Almost certainly still too early. Like I think the tech's probably not there on all the AI stuff. Maybe you need drones to pull it off. Maybe you don't. I don't know. But like that's an area that we've spent a lot of time on, even though it's still too early. But it's something we really want to see happen. Those are probably the two biggest markets we've spent a bunch of time on in the physical infrastructure side. On the virtual infrastructure side, there's a ton of pretty obvious opportunities. VPN, CDN, Zoom kind of a thing, video calling. Those all come to mind very obviously. There's going to be more segments of, just go look at basically every revenue line of AWS, that every service line that's broken out, almost all of those at some point can be decentralized in some form or fashion. So huge amounts of opportunity on the virtual infrastructure side.
Interesting. Can you talk a little bit also about regulatory risk? Do we have regulatory risk within DePIN? Is it different than crypto or not? Just general crypto regulatory risk? How do you think about that at all?
Is this being recorded? or live streamed?
It's being streamed. I don't know who's on the other side.
Oh, okay. It is being streamed. Okay. Not your lawyer. I don't give legal advice or life advice or tax or any other form of advice. I think generally serve your customers, act in good faith, be above board, hire very good attorneys, and you can understand the risks you're taking. Nothing in life is risk-free. Launching a token is definitely not risk-free. Make sure you're comfortable with the risks you're taking. It is doable. Lots of people in this room have issued tokens for DePIN type things, such as Juan is standing over there, and I assume other people in this room also have launched tokens for DePIN things.
Lawyers, guns, and money. Another question. Obviously, you've started off by saying you know how long you've been in the space. Any lessons learned? Doesn't have to be DePIN specific, but either team specific or market specific or technological. Anything. I mean, you're sitting here with a lot of experience. You've invested in a lot of projects, backed a lot of founders. What can you kind of tell us about kind of that journey and what you've learned from it?
Definitely learned a lot of things. I'd say the one I'll choose to share here is be very clear about whatever unique insight you have about why your decentralized thing is better than the centralized counterparts. There's lots of decentralized things that are marginally better than their centralized counterparts and not 10x better. So be very clear about how and why you're 10x better. And anything you would have done differently historically, not necessarily in investment, but anything else from, you know, in the space in terms of you know, building your business, et cetera. Yeah, I mean, anything you tell teams to do differently, they always do wrong. Yeah, what is a common mistake I see teams make? Here's one that is very mechanical and that really annoys me. Whenever you raise money and you do your PR and you announce, you know, your fundraise, do not announce your valuation. This is a very silly thing. Founders always want to put the largest number out publicly, and the valuation is by definition the highest number, and that is absolutely very stupid. You should announce how much money you have raised, because that is a way to tell potential employees, that you can pay them. So that's very important, but you do not need to announce your valuation. All you're doing by doing that is attracting more competitors. So very simple, tactical piece of advice for everyone. Terrific. Well, also, you know, last you built a big, you know, it's not a big team, but an incredibly skilled team with some very, you know, super high quality people who we've worked with, you know, across the board in your team, from JR to everybody. Is anything you have to give advice to people to attract kind of top people and retain them, whether it's on the venture side or the team side? Yeah, I mean, to the extent you can build a brand that's known for standing for something, that will definitely help attract talent because of a function of self-selection. We are known for like hardcore thinking and writing theses and that kind of a thing, and we attract that kind of person, which naturally fits for investing. If you are, let's say, Protocol Labs, like you publish a bunch of videos and papers about research and leading edge cryptography and ZK game theory on how to make, you know, proof storage, that will attract those kinds of people. So I'd say, if you, to whatever extent you can, publish content that's very brand aligned. And the most important thing that will do is that will then create self-selection for attracting the kind of talent that is going to naturally excel at that. Excellent. Well, listen, you know, at Fluence, we really appreciate your support, appreciate you being here. So want to thank you again for everything. And I would like to give a big round of applause to Kyle Samani. Thank you. Thanks, everyone. Thank you, Tom. Now we have Juan Bennett, founder of Protocol Labs, with Evgeny, co-founder of Fluence, coming up right now. So you're not going to get a wristband if you walk out now. So here is Evgeny, and I saw Juan fighting his way through a couple of people here. Great. You got your mics there? All right, mics are on.
Stage, like,
good. Yep. All right. Hello, everyone, again. I'm Evgeny Ponomarev, co-founder of Fluence, together with Tom Trowbridge, and today excited to be talking here with Juan Bennett, founder of Protocol Labs, company behind IPFS and Filecoin, like legendary projects. So super excited. And we also have Protocol Labs investors to Fluence, like as investor to Fluence. Very proud about that. And you know, I guess I want to start from, you know, Juan, you guys started building IPFS a long time ago. Like it's like literally 10 years ago, right? It was 2014.
Yeah. It was 10 years. Yeah, exactly. This year is going to be a 10-year anniversary of PL. The 10-year anniversary of the first commit on IPFS was last in December, I think, like December 8th or so.
Yeah, so I'm sure that many people were not even in crypto space, or don't hear about crypto space at that moment. But you guys got like started doing it so early, and I think it was actually like maybe the first DePIN project in this space, and
yeah.
at least, you know, it was the first well-known project in the space, like the biggest ICO, the biggest launch of Filecoin. So I'm curious, like why you started working on IPFS early on, like what potential you have seen and why you thought it's important to work on decentralization of data?
Yeah, great question. And you know, IPFS and Filecoin are separate projects. They have different goals. They definitely interconnect. And you know, Filecoin is the whole Filecoin network is a subset of the IPFS network. The IPFS network is the protocol by which you move around the data and so on. But I started working on IPFS because I was encountering a lot of problems in scientific publishing and scientific research where people were spending an enormous amount of time moving around data sets. And I was like, great, like we have BitTorrent and the ability to like distribute content easily. Like we've seen this work for games. We've seen peer-to-peer tech like Skype build like super successful things. We should be able to do this much more easily. We have Git with version control and so on. Let's, you know, combine Git and BitTorrent and create like a better distribution system. And that's kind of the beginning of IPFS. However, I've been working a lot on different kind of file systems tech before and doing a lot of research in file systems. And that informed a lot of that gave a much larger possibility space for that tech. And I suddenly realized, oh wait, you could put websites in this whole thing and make the entire web move around like a Git repo. You can make all web applications be distributed peer-to-peer in this kind of decentralized setting. And that was like super, super powerful. It happened to coincide at the same time with Bitcoin and like the early stages of what eventually became the crypto world or the cryptocurrency world, not the original cryptography world. And that's what kind of gave birth to Filecoin, because I was like, great, like if we have Bitcoin and cryptocurrency, we should be able to incentivize the distribution of the content with a cryptocurrency of some kind. And that was sort of the beginning of what seeded the Filecoin project. In addition, kind of I was super surprised at the time. This was 2013, 2014. I was super surprised at the scale of computation that Bitcoin had amassed at the time. I still think that to this day, the most important graph in the entire crypto industry is the Bitcoin hash rate. It shows you the crazy level of power that comes from just a free-floating incentive structure deployed on the internet. You know, the single incentive structure of the block reward plus the cryptocurrency itself existing and being able to be transacted and having some value, those two things put together gives you one of the largest computing platforms, computing systems on the planet. Now it's totally wasted, it's not doing anything like computationally useful, but that gives you a sense of like the level of power that comes out of it. And so when I saw that, I was like, whoa, this is crazy. You could actually amass a level of computation to rival the massive centralized cloud providers. That's a huge deal. You could actually get proper decentralized, verifiable systems in place at scale. And that's when I started kind of developing the ideas behind Filecoin. And then kind of, that was sort of like the reason for building that project. It's important to keep the project separate for a lot of, you know, kind of composition reasons. Like one part is IPFS is a protocol for addressing and moving around data in a verifiable way. Filecoin is a specific subset of that that's like incentivized. Think of it as like, you know, IPFS maps to HTTP and Filecoin maps to S3. And you know, kind of like the path of building a kind of so this was 2013. This is before 2013 going into 14. This is kind of right as Ethereum is getting built. and super early in the space, I remember going around talking to people about like this entire model, and they were like, "This is crazy! Like, you're never gonna amass like more than a petabyte of storage. Like, that'll be like huge if you can do that." And look at us now, like, you know, exabytes of scale and so on. So yeah, we sort of like helped pioneer the, I guess that what is now called the DePIN category. Before that was called that. At the time, it seemed like you could go, like, you know, open up the AWS console and look at every single product, sort them by easy to decentralize, you know, and kind of like start in one end and just keep going. That's why I sort of started with storage, because storage is dramatically, as Kyle was saying earlier, storage is dramatically easier than compute. We had to build a bunch of the primitives first. Now you get to write on top of all of the work that a lot of people have been doing for the last 10 years, and now you're getting to decentralized compute, which is much harder to do. And I think that's one of the things that is super compelling about what you guys are doing, is like you have a really good models for how to do this really well at scale.
Yeah, that's, I mean, that's very like, what I'm interested in here is that basically, like, as far as I understand, like, Filecoin success was enabled by one of these, like, it was a lot of components to success, but one of the biggest elements was this proof of space-time, like this cryptographic, like crypto-economic system that basically incentivized people to bring storage into a network. And actually, this proof is like proof generation is a computation work, right? So you guys started sort of, in order to create a decentralized storage network, you created the computational task, right?
Yeah, that was more of like in the whoops category of like, we thought this was going to be way easier category of problems. So the proof of spacetime model is like a really cool way of getting verifiability over some amount of storage being stored for a particular amount of time. That's why it's called proof of space time. It's like a particular amount of space being used in a particular way for a duration of time. And out of that, you can build, you know, slices of space-time and then incentivize the contribution of that over time. So that primitive was key to making the Filecoin block reward actually work in the Bitcoin setting. If you don't have, you know, in proof of space-time is related to a proof of replication, which is like a sub-primitive. A proof of replication is a single point check that like somebody's storing something. A proof of spacetime is like doing this over periods of time to give you kind of like the time arrow. And so those verifiability components were critical to be able to do the block reward style incentive structure for Filecoin. And that was the key quintessential requirement to be able to kick off the massive amount of like hardware accumulation that Filecoin was able to do in a super fast timescale, right? Like in a year we went from the network being 0 bytes to being like over an exabyte, which is super crazy in terms of like the speed of development and the speed of amassing hardware and services and whatnot. So that just shows you the level of power that you can get out of the incentive structures that DePIN networks can leverage, and you can do that across tons of different domains. And yeah, back to your point around computation. So yeah, we ended up having to like build this really complex computational thing because the specific proof of replication that we managed to build, though we tried to simplify it a lot, we couldn't get it simpler than what it currently is. And that just required a huge amount of computation. And so it meant that the requirements for Filecoin storage providers included a bunch of GPUs. But they don't need them all the time. They only need them a fraction of the time, which to us became like a really useful component because it meant that we could also kick off the accumulation of compute hardware in the Filecoin network in addition to the storage hardware. So we could amass the storage hardware and amass the compute hardware, bring it to the network, and set up a great environment to launch computational networks on top, right? So now you can, like all of the storage providers in Filecoin have a ton of GPUs and pretty significant machines that you can then use to run other computational networks. And so that's like a really good kind of springboard for you guys, for anyone building compute networks.
Yeah, that's actually what I wanted to touch after. So like basically, the interesting thing here is that we switched from useless work that proof of work miners were doing to like still crypto economic incentives model, but with much more useful utilization of resources for real purpose, for like proving the storage. And now basically all these compute resources were brought by providers to network, and now they can be utilized for other purposes, right? So, like question here, I know you guys now looking more into compute space, into like decentralized compute use cases. So how you see this like compute landscape?
So I very much agree with Kyle that compute is the hardest one. So I think it's like storage, then bandwidth, then compute in terms of the difficulty. Compute is harder because of like there's kind of like this triangle that you have to worry about. If you want to sort of a collapse of the dimensions around performance into one end of the triangle, if you want to make things verifiable, you unfortunately have to pay that in performance. And if you might want to make things private, that means like encrypt the function that you're going to run, encrypt the data, hopefully encrypt the application of the function and the data. Any one of those incurs additional computational costs. And these do not help each other. Like if you want to make things verifiable, the computational cost that you incur is distinct and separate from the computational cost you incur for privacy. For the most part, there are some constructions that are clever in some places, but this means that you end up in a space where like there's this large triangle with like performance in one of the corners, verifiability, and privacy. And depending on like where you are in that space, you incur orders of magnitude of costs in computation to achieve certain levels of verifiability or certain levels of privacy. To me, that when I sort of was thinking about this like 2-3 years ago, it was super clear that the scale, and by the way, this is only in a decentralized setting. Centralized things don't have this problem because they don't attempt to give you verifiable private computing. They can see everything. They can forge anything. It just doesn't happen because of reputation, and which is why like people trust massive scale brands like Amazon, and they're not going to trust random Joe's compute service down the corner, and that sounds kind of sketchy relative to like a trusted brand like Amazon. But the moment that you solve the verifiability or privacy problem, you can now enable lots of other participants to come into the network and unseat these massive centralized parties. But anyway, in this space, you can spot certain areas that like different technologies exist in different spots in that triangle, right? So like things like optimistic verifiability. So like the optimism style rollup space lives very close to performance. You pay a little bit of computation to verify things. It's not private at all. Things like zero knowledge, like ZK proofs, though the term is zero knowledge, they're primarily used to prove things and verify things. The zero knowledge part is like on the keys that you don't want to leak. So most ZK constructions are used to add verifiability to things, and they don't necessarily give you privacy on the data. Some ZK constructions do. So that's taking steps towards the verifiability and incurring huge computational costs by doing so. There are MPC, like multi-party computation constructions, that do kind of like a mix of you need a certain number of parties computing the thing. They give you some amount of verifiability and privacy. Then there's fully homomorphic encryption, which gives you full privacy, and like that's awesome, but it's like way more computationally expensive. And now there's an additional kind of verifiable FHE, which is even cooler, gives you both verifiability and the full privacy. But that's, again, like more expensive. So each of these spots, because of the scale of cost, in order to use those applications, it really has to matter to your use case and to your application. So it means that there's going to be many different use cases for those areas. And because there are different technologies, and the technologies are not easy to build, there would be many teams building in those pockets. So to me, like that whole triangle is a landscape with different niches that are occupied by different networks, building different technologies, products, and against certain use cases. It is possible in the future somebody might be able to like bring this together and make like a general thing that invokes the special case things. An example of doing this is kind of like how ML today has used a lot of compiler tooling to like abstract out the differences in like algorithms and hardware and so on underneath the hood for the developers. And kind of like you just program in Python and like you don't have to worry about it. But that took like a decade or more of like hard work from a ton of people to like make that happen. And that happened within a highly centralized environment. It's unclear whether this is going to be able to like be bound together. It is possible. I think if things remain super interoperable, then there's going to be a highly decentralized setting with a lot of different participants and in a lot of different networks. But we'll see how it plays out. My sense is either way, you're going to end up with like special purpose technologies, and whether that's like fully different networks in the very long term, or they get kind of like brought together, is like a very much kind of a path dependent question. But I do think, like, at least for the foreseeable future, we won't see any fully general thing actually work, and instead it's like special purpose things that that orient against specific use cases and lean into the advantages of their technological platform. So anyway, yeah, this triangle is like very useful guide, and so that means like for each one of those pockets, there should be like 1 to 2 or 3 significant networks in that area that could be pretty compelling and pretty significant.
Yeah, I actually think that this triangle is kind of great thinking of the whole space and like trade-offs that any of compute models can have. And like asking for friend, but like you guys invested in Fluence. So what is special about Fluence? What's caught your eye?
Yeah, so a lot of things. So what I found like super exciting and cool was like one of the things right off the bat that I thought was very compelling was your approach to distributed programming. So actually leaning into good programming languages and programming systems theory into giving people a much better way to program. So this is like all of the stuff in AquaVM and the language and so on. As somebody who's built a lot of distributed systems, I know how horribly difficult it is to program these protocols where you have like components and you have lots of different software that has to run in all these different machines, and they get out of, like, some people upgrade them, other people don't. You get out of sync. You have to like you have to program in extremely complex environments. And if you kind of massively simplify that and give developers a much easier way of like programming distributed systems, that is a super advantage relative to almost other networks. That gives you like it's a superpower that you can give developers that gives you kind of a huge advantage. So that to me like what seemed like very significant. Another part that I thought was really cool is kind of like actually not getting sucked into the consensus problem and instead saying, no, we're gonna orient towards like more traditional peer-to-peer dynamics and really schedule the computation where it should be. I think there's like hard questions around verifiability there, but if you can like if you can like come up with good models, then they could be like solvable for a set of use cases, and so that seemed like a very compelling thing. And honestly, like the team is super brilliant. Like everyone that I met from Fluence, I was really impressed by, and thought they were thinking very deeply about all of the problems, all of the tech, and so on. So that was like what attracted it to us. One other component I think was I've tried to build a lot of things over the last 10 years in a highly modular way, where each project is kind of like centered around one core set of problems and is well decomposed from others in order to give you pieces that you can then use for other things. So this is why IPFS is its own thing, why libp2p got extracted out of IPFS to then like now power most of the blockchains in the ecosystem, why Filecoin was a separate project, while tons of different things like that. And I thought the way that you approached a lot of things, both like reusing things like libp2p and so on, just like connected super well with the rest of that ecosystem. And so that was like a super good additional thing. So that was exciting.
Yeah, we actually got a lot of inspiration from like Protocol Labs approach to like for modularity and like for creating these open pieces that then you can take one of these, or like you can compose it and build new stuff. So yeah, like got a lot of inspiration. Also like even economic model, how like Filecoin works. It's also got us a lot of thoughts. And so I wanted to ask about another project that you're working on, which is called Interplanetary Consensus, right? Which is also the computation project, and we actually using it to run Fluence, and I'm gonna touch on it later in my talk. So, like, what's your motivation to work on it? Because like this is consensus-based computing, right? It's different from distributed execution. So, how do you think about?
Yeah. So IPC, which stands for Interplanetary Consensus, is a project that we've been kind of steering towards for many years now. So after building IPFS and libp2p and Filecoin, we've gotten a very good view into tons of problems in building things in these distributed, decentralized environments at various scales. And my view has been for many years now that all of Web3 is, like, when you calculate all of the computation that's happening in Web3, it's tiny compared to the Web2 world. And everything is super rate limited by being able to orchestrate applications in the way that the cloud does. Meaning today you can't quite build a consumer product like a social network or something like YouTube or something like Google Docs or whatever, because the underlying infrastructure that developers have is way too complex, and if you try to do like on-chain, off-chain things, you end up building super brittle things that end up like not working. And so we need a developer runtime and developer paradigm that gives devs something very close to Kubernetes or to Docker, where you can super simplify the developer experience of somebody building an application in this environment, so that they can truly focus on solving their problem and not have to get like a PhD in computer science, in distributed systems and cryptography to try and like build their application. And so that led me down a path of realizing that, hey, we really should, for a subset of the computation, areas where you really want to orchestrate programs and computers, you should really just stretch consensus really far and scale blockchains. And then though that consensus can orchestrate other computation, like that does not need to run in consensus, right? So if you think of something like Docker or Kubernetes, think of IPC as like the Kubernetes controller thing that enables you to run a pod with a bunch of programs inside. And then that is connected to a bunch of other machines, and you can decide when you are going to run something and whatnot. So that's kind of like the analogy. Now concretely, what IPC is a framework for writing very modular, highly customizable blockchains, like full chains, where you can decide whether or not it's like a full open chain or a special purpose chain that only carries the programs that you intend to carry. And it gives you the way of connecting chains in a topology with a hierarchy. Meaning you can have like a root L1 chain, and you can derive subnets from that L1 to inherit the security of the L1. And that way move a bunch of the computation into a cheaper, faster environment. One of the other things that you get once you start thinking in subnets is that you can enforce requirements on the parties that join the subnet. So for example, you can create a subnet that is regionally bound. And so you can say, hey, we could have like, you can use this to create, a hierarchy to map to like cloud regions. So for example, you can have, like the L1 representing, Earth level computation. Then, like the L2 would be, something like North America, and L3 would then be like a specific data center in Denver. And so that means you can run an entire blockchain where the computation is just happening in that subnet in that data center and can go at the speed of light there. So that means you can have block times in the 10 to 50 millisecond scale and not have to wait multiple seconds. So that means super fast settlement for all kinds of transactions, which is what you need for things like games and social networks and the real kind of like large scale applications that people use today. So that's kind of the structure for IPC. And it kind of like is born out of like everything that we've learned building IPFS, libp2p, Filecoin. And we're building it, again, in a very modular-oriented way. We're building it as its own separate project that people should be able to use. It builds on FVM, which is the hypervisor that we built for Filecoin, where you can mount many different VM runtimes on top. And so that means that you can have like this customizable structure to be able to like load whatever programs you want. And I'm super like interested in like uses of this where like you can start doing some stuff that seems crazy today to the blockchain industry. And so I think about it in terms of like what revolutionary demos you could show that then like would blow minds, right? Like so things like run a full MMO on a set of subnets where like you have one thing maintaining the state of like a particular like world, and then you have subnets representing a particular region of the space, potentially other subnets representing instances in a dungeon. or maybe potentially run a full FPS where 30 ticks a second. You could actually run something like that in this kind of structure, or a full social network where every single artifact, every interaction, every tweet, every reply, every like, every view, all of that, all of the little artifacts are sort of all that shared state is tracked in these subnets. And then you have the full verifiability rolling up all the way to the root. One key component of this is that you need super easy calling conventions across this landscape. So anyway, that's kind of what IPC is about, and it's really kind of like an orchestration tooling. It's kind of like saying, let's bring the superpowers of virtualization and large-scale compute orchestration that the cloud sort of pioneered, and mix them with decentralization and verifiability and blockchains, and use the blockchain structure as just a very powerful decentralized orchestrator to then power all of these other kinds of things. So to your question about or to your point about, so that's a consensus layer just orchestrating the machines. Now in the leaves, you can put large-scale compute nodes that are going to run single programs. Think of an LLM or a Gen AI sort of thing. And you can orchestrate them using something like IPC, but you're now doing the really heavy computational load in the leaf nodes.
Yeah. So you basically covered a little bit my next question, and one thing that I love specifically about IPC is this nested structure that we can do subnets under subnets. We currently run our just single subnet for Fluence, but there's a way to scale it with setting up more nested subnets. And the funny thing is that actually we are building decentralized compute protocol using another decentralized compute protocol, right? So that's interesting.
Turtles all the way down.
So from AI perspective, because AI is a hot topic, everyone talks about AI. So we have this, consensus-based protocol powered by IPC. We have non-consensus-based network that can run, distributed workflows like Fluence. We have Filecoin that has, massive amounts of data. So how do you see all of it play together in terms of onboarding, empowering AI?
Yeah, we're basically there in being able to start running pretty significant large-scale models, right? We can put the data sets on these networks. We can train the models. We can, once you have the model, you can snapshot it back into the network. You can have full verifiability of every single artifact and object that you're using along the way. You can run the inference through these networks. So yeah, I think the components that are there to build this. I think in order to do the LLM and Gen AI workloads, you probably have to do some special purpose building here. This is an interesting question for computational networks. How much software, how much protocol do you need between kind of a layer like Fluence and maybe a developer that wants to deploy an application to support people going to a website and entering a prompt and getting an image. Do you need another protocol there, or is it basically is the layer now all you need and you're ready to go? I think today you could probably, a set of pretty experienced devs could probably do it on top of just Fluence. But I wonder if there are layers there about kind of provenance of what it means to train an LLM, what it means to run a thing, what it means to there are some interesting ML AI specific things that you could kind of create into standards. So I think we'll see stuff like that in the next year start to emerge in a bunch of places.
Yeah, so it's more on a UX sort of DevX sort of level of which sits on top of this low-level infrastructure.
Yeah, I think if we want to see this at scale, I think what we should do is find a particular set of things that currently is very expensive in the centralized cloud. So it could be some of the video work, it could be some of the some of the more expensive LLMs, and then try to build a special purpose application that does it and tries to and scale it out and see where things are breaking.
That's also super interesting. I believe that these networks can really reshape the AI. We hopefully will reshape the whole AI drama with centralization and big tech owning it all. And there's better price and
Yeah, so this is a pretty interesting space, and I would maybe add some nuance here where for a lot of reasons, when we think about AI, and especially as we get closer to AGI, these are super, super capable models that can do, by definition, supposed to be able to do, if we get to AGI, arbitrary things that any human can do. Once you get to that level of power, a lot of questions come up in terms of like, who gets to build this, who gets to control this, who gets to invoke things. And it is not clearly, like, all options presented in front of us suck in a lot of ways. And both the kind of like hyper-centralized environments are really kind of dangerous in their own ways for a bunch of reasons. Hyper-decentralized environments are also really dangerous for other reasons. So concretely, like, if you give people super capable systems that can do like almost anything and you let anybody invoke them, then you just gave everybody, you like amplify the level of power that any human has. And that can be pretty destructive pretty fast. I'm super optimistic in terms of all of the good that everyone is going to do with that. And that's awesome. But I'm also realistic in terms of the harms that are going to come from that. The hyper-centralized structure also presents problems because now you have small groups of people controlling arguably like, a superpower, like a deity almost level result. And that also has a ton of problems because, who gets to decide what's okay to run and not okay to run and so on. So this is an area where like, I think if blockchains are going to play a significant role here, kind of in addition to kind of cost reductions on the compute side, I think that the best role is in adding very strong provenance and governance structures to be able to decide what we should be running, what models we should be building, and who should get to invoke what. And I think that is an area where we have something very significant to contribute. I would be wary of just deploying like random LLM-powered decentralized networks that anyone can do, where anyone can do anything. That I think is probably going to be more harmful than good at the beginning. And so I think I would like focus on building structures to produce systems that are going to orient and align with what kind of like what is good for humanity. And I know that's a super hard question, but unfortunately we have to like speedrun philosophy to try and morality to figure out like what that means. But we have to like to have good decentralized things that make things better. We have to kind of like solve that coordination governance problem. So yeah,
I'm actually glad that you touched governance question because like we have announcement coming up regarding like very relevant to it. So I guess we almost have no time now, but last maybe like short question. After all these years of building, like 10 years,
yeah.
Right? Any lesson learned that you can share
so
with builders who start building now or like as us? Just launching mainnet, so
yeah, so many. Well, so the blanket thing that I see a lot of teams struggle with is just a lot of like startup or product basics, and so I would like strongly recommend all builders to become like master level product builders and startup builders, and that means go learn everything that like all their startup builders and product builders have written about, and so just kind of like ingest all the material out there, like take the role of an LLM and go read like all of the stuff that's out there and go watch like good interviews and good biographies and like that kind of like that will make you a dramatically better product builder and a dramatically better startup builder, and you will be able to like speed past like tons of other problems that were maybe holding you back. Probably 90% of the problems that I tend to. So I currently advise like on the order of a few hundred companies and over 1,000 projects at this point, and like just 90% of the problems that I see are just fundamental kind of like execution-oriented product and startup building problems. And so like that'll kind of the good news here is like it's not rocket science, it's not like super new, it's all been written down. You just have to like ingest it. Maybe specifically for DePIN networks, the biggest problem that all DePIN networks mess up, and like we mess this up in Filecoin. Everyone is sort of like messing this up. The supply side is easy to scale up because of the structure of how the crypto economic incentives work, but it's still hard enough to build that you spend most of your time building that. And teams don't focus as much as they need to on the demand side, which is both hard to build and not easy to scale. And so what you end up with is most DePIN projects spend most of their time doing the super scalable demand thing, sorry, super scalable supply thing, scale up the supply side, and they don't scale up the demand side. And that means like you get these very large networks with a lot of supply and zero demand in terms of or like, significant demand, but like much lower. And so for example, in Filecoin, like we should have done a lot of that demand building like years before Mainnet launch. We basically had to start there after launching the network, and now we're like in a super great position, but like it took us a while to get there. And I think like most DePIN networks that I see aren't doing this right. I think that they're like figuring out and solving the supply side and launching without the demand side. And so I would like very, very strongly recommend that all DePIN builders go and like figure out the demand side, like either first or like in parallel with, but like very strongly focus on it. And today we don't have good structures to scale the demand side in a cryptoeconomic incentive sort of way. There's a bunch of good experiments, like Falcon Plus is a good experiment of that in that environment. This is something that I think is open. I think somebody will probably figure out a good cryptoeconomic way of like scaling the demand side, but it is harder than supply because adding cryptoeconomic incentives to the demand side it's just a way, way, way harder to do in the supply side. So yeah, that would be like my advice. And optimize for good outcomes, like orient towards like everybody around you is like trying to make the world better in some way. Just kind of collaborate with people, build modular things, build on each other's stuff. Like if you see somebody else building the same thing as you, like either join forces or collaborate, or like, great, maybe you don't have to build it, move to the next thing. That's often what I do now. Like when I find, like I want to build something and I find somebody else that's building it, awesome, I don't have to worry about it anymore. I can just go help them and focus on like the next thing. And try to optimize for like making the world a drastically better place. And we are in a really powerful century. So the things that are built in the next few decades are gonna totally transform our civilization. And I encourage you to like take the superpowers that you have and help us make sure that we have a good future.
Awesome, that's great words. I can only like add that like I agree that in Web3 people think that because it's Web3, it's crypto permissionless, we don't need to go after users, they will come, but they will not come. Like you have to work on this. Like you have to work on adoption. You have to go after users. You have to find product market fit. Like that's a work. That's not different from what like in other business areas. Yeah.
Thank you.
Yeah. Thanks, Juan. Super excited to speak about. Thank you for joining.
Thank you. And congrats.
Thank you.
Great. Thank you, Juan and Evgeny. And now we have an announcement, which is the Fluence token is now live. So we've got that behind us now. And one thing I just want to give a nod to, obviously Evgeny and I are co-founders, but our third co-founder, Dimitri, who is a kind of a critical architect of this, couldn't be here. So just want to give a round of applause to Dimitri, who couldn't make it, but is with us in spirit, and a lot of this is thanks to him. How do you run a decentralized network? I'll spend a couple of minutes on this. So first, what is the Fluence token for? It's got 3 uses: security, rewards, and governance. So security, stake on hardware. When it's staked, you know that your compute's going to happen and it's going to happen correctly. If not, there is a slashing risk. So that is kind of critical. It provides security to the network. It also provides rewards. In the bootstrapping phase, you earn rewards in the Fluence token, just like you do in the Filecoin ecosystem, just like you do in many other ecosystems in the native coin. One difference here is you're rewarded per CPU and per core, which is kind of the unit that we're using. Also, as you scale and get useful work, you're actually paid in fiat and in stable coins. But the last use of the Fluence coin is for governance. And governance is to vote in the DAO. And this is important. I mentioned it in my earlier comments. How do you govern a decentralized network appropriately? And we think the appropriate way is a DAO. And so what is the Fluence DAO like? How does it work? Well, first, it's a governor model. So 1% of stake of the total network stake to propose something is required, 4% to pass, relatively straightforward. but you need to have that 1% behind you in order to get a proposal proposed. There is a veto. Governance committee can veto something that is passed by the DAO, but the governance committee is voted in by the DAO every 2 years. So they can effectively veto something, but only for a max of 2 years. If the community really wants it, it votes those people out and votes new people in. So that is, we think, both provides a check, but not a perpetual override. Now, who can vote? All released tokens can vote, and the team can vote as well. And so everybody, all the tokens vote, over time as they're released, which takes place over, a 2-year period. And what about liability? There have been liability issues with DAOs, particularly in the US. We create a Swiss association that protects DAO members and token holders from liability. So this all exists within a legally protected structure so that it's governed on-chain by a DAO, but you're protected from being sued, as in several cases in the US, from just holding a token and participating in the DAO. So we spent a lot of time on this structure. We have a blog post on it. All of our documentation is open. Happy to share it with anybody. We hope this becomes a more, a common structure because we think this is an appropriate way. It doesn't take much to do this. You can probably implement the similar type of structure for less than $10,000. So we believe in decentralization from the beginning. It's always been a core tenet of the Fluence protocol and the Fluence plan. So we wanted to announce also that these are what you vote for. You vote for treasury management, you vote for protocol upgrades, you vote for partnerships, integrations, you vote in the technical product roadmap. Like this DAO governs this Fluence network going forward. Everything here is from the DAO. And that's what we want to announce, that the DAO is now live. So as of today, everything is governed by the DAO. Everything will be moving on-chain, and votes take place now that will make the next take this network to the next level. So I want to thank you for seeing that. And with this, I want to turn it over to Evgeny to explain in more detail how this network actually functions. So with that, Evgeny's back on stage.
Hello. So I'm going to explain how Fluence works without really deep technical details. So I hope it would be clear for everyone. So we think of Fluence as 3 big components. It's a compute marketplace. So it's a global network of compute providers who contribute their resources, bring to the marketplace, and make them available for consumers of these resources. And consumers of these resources are mainly developers who develop and deploy applications to this network. And they use what we call cloudless stack to create and deploy applications. And then all this network of providers and the stack and the platform development is managed by the DAO that Tom just announced. So first of all, compute marketplace. It's open, permissionless, on-chain registry of providers. Anyone can be provider. We mainly target professional providers because we're kind of trying to replace professional production enterprise-grade cloud platforms that run really reliable hardware in data centers. So we mainly target, as providers, we mainly target professional hardware, in a good places, with great connection, with great performance. By default, payments on the marketplace happen in stablecoins. We use USDC as initial, initial payment token. Potentially, we will open, payment tokens to be other tokens that providers can accept. So potential users should be able to pay in any token if some providers accept it. But by default, it's stablecoins because providers account their resources in stablecoin. They pay in fiat for hardware, they pay in fiat for electricity. It's important for them to have more stable, predictable income. And every provider is different. Every provider is like a company, that has computational power somewhere, and they also have some skills or some services, additional services that they can provide in addition to pure computation. So for example, the run databases, they can provide access to basically external world for the computation, like making HTTP requests, some external APIs, or other services that are also like some sort of analogies to cloud services that we can find like in Amazon. And all of them run different services. So these services should be discoverable on the marketplace, and developers should be able to find them and select with which providers they want to work with. The measure of computing accounting the compute resources we call compute unit, which is one physical core of the CPU, 4 GB of RAM, and 10 GB of virtual disk. So basically, providers allocate such compute units in their physical machines, in their servers, and then they run a lot of servers, and basically they run one Fluence node per server, per physical machine. That is what we recommend. So compute providers basically have a lot of such compute units across their physical infrastructure. The next thing is proof capacity, and this is something that what we discussed with Juan is kind of very similar to what Filecoin created to onboard storage into the network. So proof capacity is crypto-economic system that basically ensures that some compute capacity that was announced to the marketplace actually exists. So it exists and it was provisioned, it's allocated to a network, connected, and has certain performance. So basically we're using RandomX algorithm that providers run to prove that they still have this hardware allocated to the network. And as a part of this system, they have to stake tokens. So basically they stake tokens for every compute unit. And if this compute unit stops providing proofs, these tokens may be slashed. So basically, they are incentivized to keep running this. And for running these compute units, for running these proofs for every compute unit, they get rewarded by protocol with additional Fluence tokens. And the idea is that this way we can guarantee that the hardware that was announced and advertised on the marketplace actually exists. So if a customer comes and wants to rent some of this hardware, they can really take it. So whenever customer jobs comes, these compute units being reallocated from running proof capacity to executing customer jobs. In our case, they execute in cloudless functions. I'm gonna touch on it a little later. And this token stake that is allocated with compute unit will serve as a security deposit for the correctness of the job execution. So this token will be basically transferred together with the compute unit to the job, and if the job was not executed correctly, this stake may be lost. And if it's executed correctly, of course, this job will be paid by a customer in stablecoin, as I said before. So basically, providers constantly have some of their resources working on proof of capacity, some of their resources allocated to customer jobs. And there is some balance between all of this. And additionally, token rewards for running proof of capacity are vested over time, so providers are incentivized to keep this hardware connected to earn maximum amount of rewards. Because if they disconnect, they can lose unvested token rewards. So this way we can achieve like a much more stability of the supply side of the marketplace. So it's not like a moving very fast in terms of like growing and decreasing the capacity. And marketplace is built like on top of Fluence chain, like basically like it runs on top of Fluence chain, which is powered by interplanetary consensus or IPC, which allows us to have high scalability and performance. And we run all the like transaction settlement in there, we run proof validation in there, but actual computation and compute units, they run off-chain on physical machines. And also like we like IPC because it's built by Filecoin team, and it's basically allows us to be close to Filecoin, like massive amounts of Filecoin data, so we can actually we can bring computation to data and we can run it efficiently. So this is super exciting. the next thing is the cloudless stack. And this is the development stack that everyone who want to use Fluence is using. And the core component of cloudless stack is what we call cloudless function. So cloudless function is basically a piece of code that runs on top of distributed infrastructure of nodes, on top of distributed network. And what is great about this, what is special about cloudless functions is actually they are not being executed at particular machine or particular node. They kind of run on top of the network. They kind of run between the nodes. And the way it works is that basically cloudless functions express the topology of the execution step by step. So, for example, you have some business use case where you need to collect crypto asset price from several providers, several nodes, or several sources. Then you want to calculate the average of this price or have some quorum, and then process this price and send it to some client that expect to get it. And this can be executed as a step-by-step algorithm on the network where different nodes are responsible for different steps of this. Like the first nodes basically provide the source data, the second group of nodes agrees on the average or on the consensus, and the other nodes work as a relayers and send it to customer. So cloudless function expresses this workflow and basically makes sure that this workflow being executed across this big group of nodes that are involved. And cloudless functions basically can be executed, is a distributed execution, right? So they can be executed and on top of different external services. They can access storage, they can access databases, they can connect to blockchains, they can connect to nodes and ask them to execute some complex compute task. And this way you can basically describe any kind of computational task. You have this distributed workflow, and then distributed workflow touches, like, for example, you have the event that happens on blockchain that triggers the execution of some WebAssembly function, then it writes the result into database and send it to some client via HTTP. So this is workflow, it's described as a cloudless function, and then it runs on top of this variety of services. And as I said before, these different external services like storage or blockchains or databases can be provided by compute providers on the marketplace, and different providers can provide different services. So Fluence allows your code to discover the right providers and then to make all these calls to execute your business use case. Another additional great thing about cloudless functions is they enforce verifiability and security. So basically every step of the execution being validated by the next node that execute in the next step. So basically when incoming request comes to any node, it takes the request and sees what was executed before and validates what is executed by the right nodes, was it executed in the right order, and if it's not correct, then it just discards the execution. And as a part of this validation system, we are working on adding on-chain validation. So we're going to have, we call it proof of compute. The whole system, we kind of call it proof of compute. So we have this step-by-step validation of the protocol. And then we're going to have probabilistic validation of some of cloudless functions on-chain to add even more security to it. Basically, this creates you audit, auditable traces of the execution, and you always can see, were execution done correctly or not, and you can, have the economic model, so like the stake is slashed if the execution is incorrect, or the node is rewarded if the execution is correct. And some examples of kind of distributed systems that can be expressed in cloudless functions, and it's basically any distributed system can be expressed as a set of cloudless functions. You can think of something very simple, like it's kind of technical terms here, but like from simple things like MapReduce or failover algorithms to more comprehensive, permissionless consensus, multi-party computations with threshold signatures and stuff like that. Because all of these are distributed systems, all of these are network algorithms, all of this basically like a protocol, so like coordination between different agents on network. All of this can be expressed as a cloudless functions, and actually like all of this, includes, besides distributed execution, includes some computations that happening on peers, and overall looks like the computational task. And basically that's simplest explanation of Fluence. There's a huge network of providers, they run cloudless functions, they connect with a variety of storage and blockchains and external services, they can run pure compute, and all of this kind of orchestrated by this distributed cloudless functions. So the tool set of it is, if you're interested, you can check out at fluence.dev. Right now we're running it on a testnet called DAR, and actually the cloudless platform goes live in the next couple of weeks in March. So pay attention. We are basically launching this platform at the mainnet in following weeks. And one more thing on the kind of where we are going with all of this, because this functions is kind of fundamental thing of how you wire in different compute or different services together. We are distributed permissionless system, but we want to this system to be able to run all kinds of workflows, like because computations, as like Juan said, and as Kyle was touching on it, it's a wide variety of different patterns of consuming the computation. So we want to better enable AI. We want to support machine learning frameworks. For this, we need like GPU support, we need Docker support, we need Python support. So it's all actually like in the roadmap. It's all coming. It's not far away, but currently we are limited by WebAssembly and services that are available right now. But a lot of the things we are working on, and we want to deliver a lot of actually such features until the end of the year. We also thinking a lot about hardware types, because some of the tasks require private data to be stored on the nodes, which means it can be addressed by either trusted execution environments or things like MPC, where you like with threshold signatures again. So for example, if you have you build a DeFi bot and you need to make a transaction on chain, you don't want to put your private key from your wallet to some provider that you don't know. So you're probably going to use MPC subnet on Fluence, where every provider has only like a share of your private key and cannot really get the private key itself. Or you're going to trust the hardware that was certified by Intel if you trust Intel. If some providers run TEE, so you're going to put your private key into that. We also want to allow developers to much easier use this platform compared to like many other crypto protocols. So we're gonna enable fiat payments. So you just put your credit card and you basically like can immediately get access to all these compute resources like you do in Amazon and many Web2 startups. So why don't we do it for Web3 as well? We're going to integrate more data storages. We're going to do liquid staking because we want to, with all of this stake locked for hardware, we want more efficient token utilization. So a lot of these things we are working on, and they are coming in following months. Yeah, I think that's it for now from me. Thank you so much. That was short, how it works, Fluence.
Great. And now we have a panel. Bernard, come on up and moderate your panel. And I saw Vuk front seat ready to hop right up. Let's go. And here we go. Another, get on up there. All right, hey, how are you? There we go. We got everybody.
All right, everybody. I'm Bernhard with Fluence, and we got Mark, Matresha, Vuk, and Jenks, all from different areas: Ceramic, Spheron, Web3 Mine, Filecoin Foundation, and sort of the entire platform components you need in order to roll out a good decentralized cloudless application. Why don't you start there, Mark? Start introducing yourself, and we'll just go through.
Cool. So I'm Mark. I'm a partner engineer at 3Box Labs, building the Ceramic network. The Ceramic network it's an open data network built on decentralized event streams, and then there's different flavors of composable databases built on top of Ceramic. So OrbisDB, a relational SQL-based database. ComposeDB is a graph-based database. And really happy about this panel, and also congrats to the launch.
Thank you, appreciate it.
Hey, I'm Mitra. I'm co-founder and CTO of Spheron. In Spheron, we are building a general-purpose decentralized compute protocol. And that's not all. We have built a platform where anyone, like from simple developers to a kind of like users, they can easily deploy their servers, their validators, even a full blockchain, the nodes on Spheron, and that's building the whole the demand side of things, and also the supply side by building the main core blockchain layer as well. So yeah, I'm very excited to be here, and yeah.
Glad to have you.
Hey, my name is Vuk. I'm the founder of Web3Mine. We build the liquid staking derivatives for DePIN networks. So like most of the time, you'll have an economy around your compute network, and you need to figure out how to actually enable providers. So what we do is we basically build a bunch of stuff on Ethereum, and we basically expose you to the market that you have on Ethereum.
Hi, I'm Jenks. I'm a developer advocate at Filecoin Foundation. I've been working in the ecosystem team at Filecoin, between Filecoin and Protocol Labs, working for IPFS ecosystem and Filecoin ecosystem for a while. My job is to increase the adoption of all the technologies that is in these two ecosystems, and explain that really quickly, really well to developers and founders out there, so they can implement their technology, implement the decentralized technology that we provide to add value to their project.
All right, I'm Bernhard, Chief Scientist at Fluence, and we'll leave it at that because you've heard about us all day long, and we'll keep this pushing. So ecosystems. To me, one of the interesting things about technology and ecosystem is that ecosystems really sort of seamlessly bridge customers, markets, technologies, and products. And in the nascent Web3 ecosystem development, we're sort of the markets and the customers seems to be missing a little bit. I think Juan already spoke to that. And at the same time, a lot of projects are early on very somewhat isolated, also nascent, and very decoupled literally from the solution stacks that need to be provided in order to actually get customer adoption. So this was a very long leading intro. So what I wanted to get is, where do you see like ecosystem building at this stage, and where does it need to go in order to be able to compete against established ecosystem, centralized ecosystems, if you will? Want to start with Mark?
Sure. So I was on a panel a bit earlier, a few hours ago, and I spoke a bit about composability. I think at its core, Ceramic's mission at least is to enable developers on the developer end to circumvent the cold start issue and be able to like build from day one with usable, useful user data, user-centric data. And then the benefit for the users is they control the data that they write to the network. I think part of the adoption issue right now is just the incentive mechanism by which we catalyze different applications to build on that useful data, or establish like a means by which they're using the same interface, the same language, and like a canonical definition of a schema to be able to interop between each other. So we're looking to see where that goes in the future, but that to me kind of characterizes what the current state looks like.
In my opinion, I think the ecosystem should be somewhere where people can build easily their tabs and apps, whatever they want to, and can actually make a profit out of it. If you can't show them a profit or show them actual business coming out of it, you can't actually build an ecosystem. And for that to achieve, you have to give them much easier way to like interact with the blockchain, interact with your apps, APIs, whatever that they can get to actually build their own product out of it. So in my opinion, I think it should be in a way where everyone can understand things and just build that is much more simpler for them.
So my view is that each of the networks basically has the role of supporting their own communities, and usually like that's going to be a product in a particular context. So for example, for Fluence, it's figuring out like who are the Wasm developers that want to like use this abstraction that we have created and building a bunch of tooling around that. I don't think we are yet at the stage where when we are thinking about like, okay, now that we want, I mean, like, of course, we've been thinking about that for years, but like, we're not at the stage where this is relevant, where you're thinking about how to pass context around from, for example, a Wasm executable. You need to like pass that to the next unit of computing, which could be like encoding on LiPair, it could be rendering, it could be whatever. That part is still missing, and like, I think we need like more teams to like align on some standards that we want to have in order for us to be able to talk between each of the networks. But before we get there, like the tooling for each of the networks needs to be mature enough, and I don't think we have done like a particularly good job even on that. Just start onboarding like users for each of the networks first, and then figure out how we can work as different communities together to just merge all these communities into one and just enable everyone to have interoperability.
So I will go from a different perspective, I guess. So I was like Web 2 DevRel, and then now I'm in Web 3. I've always been in ecosystem teams building communities, and it was the biggest difference I felt is for a traditional product company. Let's imagine a SaaS. They wouldn't care about ecosystem or caring for developers or building developer platforms until their user number grow to a extreme big scale, massive scale. And then they found out there's a lot of issues that they can't do it themselves. They can't push out features fast enough. They can't satisfy a lot of users' different demands. And then they start to realize, oh, we need SDKs, we need APIs to be able to solve these problems. So it kind of goes the other way. Traditional companies usually have mass adoption first. They're successful at their products first, and then they need ecosystem, they develop that. It takes tremendous amount of resources, capital, and people running around building those ecosystems. It's really hard to make people stay as well, because you're making a big chunk of money. Your ecosystem partner may not necessarily be making money. Now for Web3, imagine that is completely reverse. You start without the product, without mass adoption, but you have the community first. Community is your asset, your ecosystem is your asset. You probably have partnerships before you build anything, but it is some form of asset that you have, probably very intangible. It's completely reverse. So a lot of, for Web3 companies, a lot of them understands my role very well, so developer advocates very well, understands the point of ecosystem, the existence of it very well. But then because the technology is slowly being adopted by the mass, it is a painful process. You have the community, maybe the composition is a little bit different. There are token holders, there are storage providers for us, or node operators first. And then you gradually look for actual customers that are willing to pay for these kind of services to solve some of the problems. And it's a very slow process for them to understand the problem that they have with the current system as well. So I think I'm just trying to provide a perspective to explain why some of the issues that you said earlier about mass adoption and the ecosystem composition is very different.
Interesting. So communities came up, and Tom just announced our DAO. And DAOs, of course, are a representation of communities. And how do you see DAOs working together to shape cooperation, co-opetition, ecosystem building amongst projects? I mean, 5 people sitting on a table is one thing. 5 DAOs sitting on the table, just from a process perspective, is very, very different. Are there any insights or any concerns you have about building efficient or effective ecosystems where the contributors, the decision makers, are actually DAOs as opposed to centralized figures representing a project?
I just need a minute to think. So,
is anyone on this panel in the DAO actively?
Here.
Yeah.
So you don't even know how difficult it's going to be yet.
Yeah. Ultimately, I think the main question is like, what are we actually building? Like, we are really not building software. We are just defining protocols, and then like we're just letting the community evolve. Like the only way to actually do that is through DAOs. Like, and sure, like you have economy, you have like some inflation in the economy. This is a way for you to bootstrap, but ultimately, not all the software needs to be built by the first team building the software. Otherwise, we are at the same exact point where the cloud providers are right now. So like the DAO is kind of like the essential way of steering that economy into a particular direction. And the directions can be like many, and ultimately also define like what that particular protocol needs to do. Because for example, we could say, okay, so like whatever, in the context of Fluence, makes more sense for Fluence to reduce the collateral requirement for allocating resources. That would imply that maybe like we also need to reduce the inflation because that needs to be balanced out. Like that gives Fluence a very different fate from actually being like, oh, now we want to have like 10 times more collateral, but we want to do like super secure whatever computing that like people want to guarantee with like substantial funding. All of those are like paths that like Fluence could take or like some other network could take, which are very different. And we might have like many different versions of Fluence like being governed by the same token. Like ultimately, we are just at the beginning of like something that we are really not sure what it is. And like I would just invite everyone not to think about software, but rather protocols. And the software gets built like by individual contributors in that ecosystem, which is governed by the DAO.
Any contrarian views to that, or no? Everybody agrees? Oh my God, I thought it was going to be a little bit of fight on stage here.
Yeah, like the spicy ones. But
It's awesome.
So I want to add to that. It's not against this idea of having DAO, but DAO has its downsides, right? So I've been
Elaborate.
Elaborate, yeah. So I've asked a lot of DAO members, core members in there, and asked them the biggest frustration they have. And the biggest frustration, like many Web3 projects, is governance, right? Getting machine to agree with each other is fairly simple. There's consensus mechanism that can do that very well and deal with bad players in there. But within the DAO, you need governance is very important. Governance means getting people to agree certain things. And to be honest, a lot of DAO members just do not care about governance. They don't want to participate in it. If the project is even very technical, then there's even less people that can participate in that governance decision, especially for like technical roadmap discussions. So getting people to participate has been a very, very big struggle. In a DAO of 50,000, probably only 50 people or 20 people that are actively participating in the governance. So effectively what you're seeing is actually still a small amount of people are making decisions for the organization itself. Now, I don't mean that in a bad way. Less people actually means speed. You can agree on things much quicker, but then the fact that you're having a DAO, not a single, like a corporate making, like a small collection of group of people making decisions, it's less efficient. We gotta accept that. You need to slow down for a better reason for that, right?
Yeah, maybe to spice it up. So like I think ultimately like it's interesting because we like as a humankind are just basically doing the same exact thing in a different form. So if you think about what we are doing now with like governance that is open, like we're basically just going to the completely other extreme, and then we'll be like building like the governance infrastructure as we go. So like what's going to happen probably next is you have a delegated staking, and that's kind of voting for like a government kind of like entity that is then making decisions for you. And it's kind of the same thing that we have, but we kind of fucked up the thing we had, and now we are going like back to square one, trying to like actually formalize that by building protocols that are actually like exposing that to everyone, because like we don't think the system works. And like ultimately we're kind of like just getting on the complete extreme where like you assume that everyone has an opinion and that opinion is good, and then we'll be probably finding something in between, like a dictatorship model and like the full like open model where everyone is actually deciding everything.
How does that from a middleware perspective look?
I would say it's a very different perspective on like the downside of it. Like it's like on the ecosystem side, you have like we have been part of a lot of ecosystem right now, been a part as well as like building on top of them and doing a lot of user adoptions, things around that. Being a DAO, I would say like it has to be like it has some kind of like perspectives so that you can like bring that vision to a specific route, because like if you don't have a vision, you can't like actually build something that gonna like improve the ecosystem as well as like build that protocol where it needs to be. So in my opinion, there is like a lot of downside, a lot of pros as well, and as well as like need to actually build a better kind of like DAO module. Delegated stakes are kind of like sucks right now. Like everyone has their own kind of thinking process, but you don't know when they will change something. So yeah, like in my opinion, it should be much more versatile, I would say.
Mark, you want to chime in, or?
I don't have a whole lot to add. One of the perceived issues around DAO governance, in my opinion, and again, this comes as someone who I've joined 2 DAOs and currently I'm not part of any, is the reputation of DAO delegates is kind of loosey-goosey. It feels like different interfaces or different services that are providing like an opinion as to different delegates' involvement are reading from different data sets, and that part of the ecosystem feels a bit fragmented. And then when you talk about like the composability of reputation between separate ecosystems, separate DAO groups, like that completely falls apart. And so what I would like to see is that maybe brought together under some like cohesive or shared understanding of like what involvement looks like. And then I'll share something that is maybe not probably an opinion shared with some of the people on this panel, but I think that DAO voting is going to primarily move off-chain eventually in the coming years. I think for a few different reasons. Part of one is just efficiency's sake. And so especially in like that type of paradigm and that type of environment, we're going to need to be speaking the same language to understand, who's making the decisions. Because as one of you said, most people who join a DAO don't want to get involved in governance. They want to be able to delegate that responsibility.
Okay, so DAO is assume, I guess collectively the point was DAO might not necessarily make it easier to build effective ecosystems. Is that correct? So I don't want to really like keep going on the DAO side, because one thing Vuk brought up earlier is the difference between building protocols and software, and how that relates to ecosystem building and representing ecosystems to literally customers and markets. And just wanted to see, like on the ceramic side, where do you see yourself? Are you in the protocol building, or in the software, or are you doing both?
It's interesting you ask. I guess from a timing perspective, we had OrbisDB launch this morning, and OrbisDB is built on.
Congratulations, by the way.
Thank you. Yeah,
big fan on OrbisDB myself.
Oh, nice. Yeah, I mean Baptiste and that team, they're awesome. So, I mean, my role in the organization is working directly with teams that are building, consumer-facing applications on Ceramic, but we consider ourselves protocol builders. And so sometimes it can be difficult to like really understand what new features are needed, especially on a team where like I'm working with engineers and I'm the only one that's kind of like sitting at the application layer. And I can kind of speak volumes to what that experience looks like. But it's interesting. It's interesting seeing like how the different needs of different teams shift over time, and also like what is popular in the ethos right now. For example, points are a huge deal. So trying to understand like how to formulate that into something that can be built on our protocol. I'm not sure if that answers your question. I went in a few different directions.
Not really, but in part I think that's one of those indecisive states of projects that is quite prevalent, I think. And I wanted to ask you again from an integrator perspective, from middleware perspective, how do you deal with it? I mean, you're integrating projects. How do you deal with that protocol versus software mindset?
So, from the beginning, we are actually wanted to build a abstracted layer for any of the protocol initially to bring more user adoption, bring more profitability for any of this protocol as well as the business by the platform business as well. So that part has always been there because like it's actually created that kind of like mindset where you can like you have to move fast to understand like what's the user demand, and you have to be versatile because you have to like change things faster than like even protocol can do it. So from that mindset, we have been building this like multiple different layers on our platform, and after that we figure out like, okay, this is something that is a need of the whole like ecosystem, protocol, even DePIN, everything that requires this kind of thing. And we are moving towards the protocol layer as well, so that we can actually power that platform with much more efficient protocol that can like give you better like systems for building much better application layer on top of it. So from our perspective, it's been the same. Build the demand first, understand where the need is, and once you understand the need, you can bring the supply by bringing more crypto economic stuff.
So before you go to Vuk, let me just ask you, like, hook in there. Do you need an ecosystem, or are you the ecosystem?
I would say both.
Okay.
Yeah, so we also need an ecosystem, but we are ourselves an ecosystem as well for a protocol. But the main reason to build the ecosystem is to like, first of all, bring a business to the platform, plus for the protocol layer to actually build multiple different things, maybe even new Spheron of their own flavors. So that's also can be possible with a protocol layer, but that requires the understanding of both the supply and the demand, and we have kind of like understand which one, how to like bring the demand, how you can like bring the supply, and then you can like merge both and build much better applications on top of it.
So definitely protocol. My view is that like the main unfair advantage that we have as an ecosystem is the ability to think about economies and define economies and incentive structures on the protocols. If it was not for that, like we'll probably not ever have had the chance to compete with the clouds. And if you start thinking about like everything through economies, like it's super interesting. Like I know I met a guy like in LA, he was selling furniture, and I was like trying to really think about his business as an economy, and like it's extremely powerful. And like even for like a stupid business that is basically just like selling furniture, sure, it is rare furniture, and like I did help him reason about that economy, like through basically things that we do like in crypto every day, and you can apply it. And like probably for most of the things out there, like they are slowly gonna get disrupted, similarly to how the internet disrupted everything through the economies. That's kind of the only real thing that we have like enabled with crypto, not really like whatever peer-to-peer like comms and stuff like that. Sure, like those were needed, but those are not the fundamental thing that you actually can get out of like the ecosystem.
Interesting.
So I'll quickly say my view from a developer's perspective, because I have the pleasure of dealing with a lot of developers on a daily basis. I think protocols are great because they're usually built modular, and you can stack different protocols and make something wonderful. Like Ceramic has a lot of different primitives for developers to build on top of. But when it comes to solving problems, developers tend to go to software solutions because it usually is built with users in mind and specific problems in mind. So it's very efficient in solving problems if you have software solutions like Spheron, and also like Web3 DePIN project or mining, solutions for Web3 mining. That's great at getting people started, solves that problem. But when you try to be innovative, when you're trying to create something that is different than that solution, you need protocols.
All right, time's up. So I think I want to thank everybody for coming. Mark, Vuk, Jenks, and I know we haven't solved the ecosystem building approach in this space, but I hopefully it gives some thoughts and some insights into what the problems are, what the challenges are, and how to overcome them. Thanks, everybody. Thanks for being here.
Thank you. Thank you, everybody. And we're going to move quickly to continuing the ecosystem conversation. Just 2 minutes. We got one more thing to talk about. but this is relevant to potentially everybody in the audience. So we're talking community, and community is important to Fluence. We've got some pictures here of a ton of events we've done. We know we can't succeed without it. Jenks mentioned the importance of community in crypto. In crypto, community helps you build your success. We're very aware of that. Last year, we did events on most continents. We did it all over. This year, we're going to follow that same path, do events all over. We want to meet the community. We want to be as close to everybody as we can. We want to let you know what we're doing, and we want to understand your concerns and your priorities. You know, what we have right now and we want to announce is a developer reward. This developer reward, we have more than 100,000 Web3 developers that we have gathered from GitHub, and we're excited for everyone to go and claim your Fluence tokens. So this is a big developer reward. We're doing this because we can't succeed in a vacuum. We need the support of the community. We need to help build that community. We need to get everybody involved. And so we did this large reward to as many people as we could possibly find in order to show how much we think this community is important and how much we want to help this community and what we can do together. So we think that with this community, we can build this cloudless compute platform and really make a difference. So please go to claim.fluence.network to see if you're there, and then you can help participate in the DAO as well, and we'd love your support there. So please join that. If you're a provider, you can join our waitlist, but most of you here can join the community by scanning this barcode. Hopefully you're already part of the community. If you're not, please join the community. And after you've joined the community, you can join us for drinks in the next room and champagne where we are all moving to. So thank you all for joining today. Thank you for joining the launch, and onward and upward and forward. Thank you, everybody. Bye.